in space 3 times, but yet he doesn't know the procedure. He doesn't know the plan off the top of his head. If there was a leak on the ISS that he's traveled on 3 times, he doesn't know the procedure. Come on.
And then there's probably a plan, I don't know off the top of my head, but there's probably a plan for replacing the mechanism.
The reason he don't know the plan is because it's all fake. He was caught by surprise with the question. Thanks for watching, and God bless.
Have you ever looked away from Earth into the black void?
Because you can see the stars.
Oh yeah.
We were never able to see stars from the lunar surface or on the daylight side of the moon.
It's not a black void. I mean, it's black, but there's all kinds of polka dots.
Space is fake AF. Space is fake AF.
There's more than stars. You can see planets. You can see moons.
You see the gas.
It don't matter. Say the sky was not the limit. We fly to the moon in another second. But we haven't been back since 1972. Destroyed all the papers and blew up the Challenger crew. Except for the twinsies. Space is fake AF. Space is fake AF.
Look out into deep space away from the sun, it's the darkest night you can imagine.
Hey, space boy, you broke my rocket man heart. Where are the stars? Is it bright or is it dark? The vacuum of space, oh, the tomfoolery.
What happens if you get a leak on that? You have a leak.
Deep over my bubble.
It's hard to comprehend.
Space is fake AF.
2 little bitty O-rings.
Space is fake AF.
It's not what you think, homeboy.
Space is fake AF.
It's all just start doing this.
Space is fake AF.
Research Eddie Bravo.
You just have a leak. And what you would do is lose air.
And ye shall know the truth, and the truth shall make you free.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Before we can send astronauts into space on Orion, we have to test all of its systems. And there's only one way to know if we got it right. Fly it in space. For Orion's first flight, no astronauts will be aboard. The spacecraft is loaded with sensors to record and measure all aspects of the flight. As the spacecraft and the upper stage begin their first lap around Earth, Mission Control in Houston is monitoring the progress of the flight. Orion's over 100 miles up and going about 17,000 miles per hour. Just as it passes over the Indian Ocean, we lose communication. This is expected. The communications link we have through satellites to Orion is momentarily lost, but Orion continues to receive and process data. Its computers can handle 480 million instructions per second. We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space.
Here's Apollo 12 astronaut Alan Bean being interviewed about the Van Allen radiation belts.
Any ill effects from the Van Allen radiation belts?
No, now I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did. I don't know the distance to the Van Allen radiation belt.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
Didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation. Not on our mission, by the way. They hadn't been discovered yet.
So you see, he wasn't even sure what the Van Allen belts were, and when he was told, he basically says that the radiation belts didn't apply to his mission because they hadn't been discovered yet.
Okay. Okay.
Well, maybe somebody said you went through the radiation belt, but we didn't feel it inside. Not on our mission, by the way. They hadn't been discovered yet.
The guy just said, maybe somebody said we just went through the Van Allen radiation belts, but how is that possible if they hadn't been discovered yet?
Well, maybe somebody said you went through the radiation belt, but we didn't feel it inside. Not on our mission, by the way. They hadn't been discovered yet.
We must solve these challenges before we send people through this region of space.
Not on our mission, by the way. They hadn't been discovered yet.
And ye shall know the truth, and the truth shall make you free.
What you're seeing here is a mirage.
A lie is a lie, and it don't matter how many dumb sheeple believe it. And the truth is the truth, hiding right out in plain sight, and still people don't see it. Man, this shit got me heated, and I won't stop till the elite are being defeated. They keep us deceived about everything that we think, and they keep it a secret. What we're taught is not conducive with reality. Big bang, evolution, and there's gravity. I tell the truth, and then these motherfuckers laugh at me, telling me the earth is photoshopped because it has to be. Most people accept the deception happily, but what they're doing to us all is a tragedy. God created the heavens and the earth in a verse, but we're living in a Freemasonic galaxy. They say we're monkeys on a ball flying through outer space, but there's no proof. It seems to have vanished without a trace. NASA and other agencies falling down from grace. You can take that bullshit pseudoscience and get out my face. I'm the antisocial type. You're a government prototype. That's why you make it a point to tell me that I'm crazy every time you're angry, cause you know I'm right. I'm standing outside the house of cards about to watch it fall. No more living on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl. We follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, not at all. It's a criminal enterprise where deception intensifies. And assholes got us all living life on a cartoon ball.
It is photoshopped, but it has to be. What you're seeing here is a mirage.
They say that we went to the moon 6 times, but pure BS is the way that smelled. Now they're telling us that we can't even leave the planet because of the Van Allen radiation belt. Yeah, okay, sure. NASA, what you lying for? You lying now, you lied before. I can't take this anymore. The only thing they took to space was your imagination. Fake aliens are coming, now they have you waiting. We need to do something about it, no procrastination. Trying to cause the masses to awaken, that's the path I've taken. But you can see if you check all the percentages. So many people having cognitive dissonance. But that's what happens at the loss of your innocence. Then you get involved with all of this wickedness. They try to do all the humans this way. So are they just idiots? Who is to say? Conditioned by the television, it makes your decisions, opinions, and you just obey. Stuck in the material domain of Satan, where everything in each and every day is pagan. Mandela effect, cause the game is changing. People waking up and now the cage is shaking. The earth is flat, and that is a universal fact. If it isn't that, then tell me where the fuck the curve is at. They tell us that we can't see it because we're all too small. And now we're spinning on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl. We follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, not at all. It's a criminal enterprise where deception intensifies. And assholes got us all living life on a cartoon ball.
It is the world that has been pulled over your eyes to blind you from the truth. Like everyone else, you were born into bondage, born into a prison for your mind.
We accept the reality of the world with which we're presented. It's as simple as that.
Yeah. ODD TV. Payday Monsanto. Let's get it, homie.
We sleep. The alarm's going off. Beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live. We sleep. The alarm's going off. Beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite.
to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. I came here to kick some ass just like Roddy Piper. These motherfuckers that walk among us, they got me hyper. But don't be chewing that bubble gum, it's got aspartame. It's a chemical directly targeted at your brain, just like the fluoride that they put in the water supply and all the geoengineering we got in the sky. I'm trying to tell you, and I hope that you're hearing me clearly, this ain't no bullshit speculation conspiracy theory. They live and they're controlling every move you make, from the apartment that you live in to the juice you drink. They give you television to help you ignore this prison while feeding you genetically modified organisms. They want us like the Walking Dead, just obey and consume. Don't worry about anything, keep awaiting your doom. To all my warriors out there, this is indeed my call. It's time to put a fucking end to this elite cabal. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite.
When they try to prove their spinning ball Earth, it's remarkable. All their arguments are absolutely fucking farcical. It's clearly been shown your problems aren't resolvable. Your theory has been blown into tiny little particles. The pharmacological drugs they got the masses on precludes them from putting their rowdy Roddy Piper glasses on. And even when they do, they're unable to gaze too straight, cause for most of them it's way too late for them to see past their conditioning. They will not be listening to anything outside their paradigm imprisonment. They are ensconced in a nonsensical certitude, brainwashed by devils to revel in their servitude. It's idiocracy, pure hypocrisy. Waking these dummies up, it used to mean a lot to me. But nowadays I wanna tip their canoes, and as they drown, tell them this is what you get when you snooze.
They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite.
Either put on these glasses or start eating that trash can.
and have lasers being shot over it at 25 miles and have it hit the target at the other side, 2 meters above sea level. That can't happen.
Okay.
That's the whole point. That's the crux of this whole thing. So if you do have that, I'd be interested to see it.
Well, like...
If you don't, that's fine, because no one else does. No one else has that. So, you wouldn't be the first. Don't worry.
Yeah, I know, because, like... I don't know how to explain it to you, but, like...
Well, what? What
Like,
do you mean?
Okay, yeah, no, okay, you're right. You've done your own, and... Okay, so you're saying you've done the experiment.
No, I didn't personally do
not you. Yes, I know. People have done the experiment.
Yeah.
And they say, well, this happened, and so the Earth is not curved. But other people have done it, and it worked for them. So it's like...
Who did that? Where? Who? When?
Yeah, that's what we'd need to see. But you're right. If that were the case, then we would have to compare the two and say, right, which of these bodies of evidence is stacking up and is legit? Because both of them cannot be true. So if you think someone is doing the same thing that we're talking about, and it is actually showing 8 inches per mile squared, remember it has to be a very specific rate based on the size of the ball they tell us, then please post it. It'd be very interesting. We're all waiting for this one.
Okay.
Because that would shut the whole server down, bro. Be careful. But let's see it.
You can go and get it.
Well, I don't have like I know people have done it, and they have videos on YouTube. No, they have videos on YouTube on both sides, whether it's flat, whether it's not.
So there's a couple on YouTube like Discovery Channel, National Geographic that claim to have done this, but when you examine the videos, you can see where they've misled. And also, the videos that you'll find on YouTube are like 5 to 10 minutes long. They're little reality show puff pieces. They're not scientific papers. They're not academic studies or well-documented experiments.
But look, not everything in theory works. You should know that, right?
No. But this is different because this isn't supposed to be a theory. This is supposed to be reality, remember?
Yeah,
in reality, it's supposed to be curving at 8 inches per mile squared. So, in reality, as you agreed, a laser would be able to evidence that. A high-powered laser, when referenced against the surface that it's being shot over, would demonstrate convexity of 8 inches per mile squared. That's very measurable.
Yeah, and you'd also have to tell the militaries of the world to use laser targeted devices from vessels at sea. I haven't finished.
Okay.
I'll start again. So you'd also have to talk to the militaries of the world who use laser targeting devices from vessels at sea, using lasers to target ground-based targets at over 100 miles away. Now, the laser aiming device is only 40 to 60 foot above the surface of the water, shooting a beam at over 100 miles to target something that they can shoot the shit out of. So we can use lasers to hit targets at 25 miles, but practically in everyday use by the militaries of the world when they want to blow shit up, they use laser targeting devices from vessels at sea, over 100 miles. This demonstrates the practical use of a flat surface. Otherwise, the militaries of the world wouldn't use this shit.
You know that they use satellites, right?
No, they... yes. Right, you didn't listen to what I fucking said, so I'll restate it.
No, okay, I've listened.
Laser targeting devices, beam pencil lasers, RDF, requiring a direct line of sight from a targeting device from a vessel at sea. The targeting device is no higher than 40 to 60 foot over the surface of the ocean, hitting targets over 100 miles away that are ground-based. This requires a direct line of sight from the targeting device on the vessel. Nothing to do with satellites, mate.
Okay, I see what you mean. You're saying that people, cruise ships, and other military things are shooting weapons
Laser
from the ocean.
Targeting devices requiring a direct line of sight at over 100 miles from a vessel at sea, no higher than 60 foot above the surface of the sea. It requires a direct line of sight. You're not going to get a direct line of sight over 100 miles from 60 foot above the surface of the ocean hitting the ground-based target because the curve of the Earth will get in the way.
What did you say at the end? You cut off.
The curve of the Earth will get in the way.
Okay. So this is what I understood from what you're saying. Tell me if I understood something wrong. So you're saying that military are like they're using lasers to aim from more than 100 miles away on a ground-based target. That is correct, right?
That is correct, yes. Laser targeting device.
Okay. And do you know what's the height that they're using?
The height, yes. For the fifth time, no higher than 60 foot above the surface of the ocean.
No higher than 60.
Yeah, think how big a boat is. I mean, I could literally give you 200 foot above the surface of the ocean if you want. It's still not going to make a goddamn difference when you're aiming at targets 100 miles away, mate.
Okay. So I don't know how to reply to that. I'll be honest, okay?
Yeah, then that's absolutely fine. What I'm trying to demonstrate is the practical use of lasers by if they use them to blow shit up or help target things to blow shit up, then they wouldn't use this if the curve of the Earth was going to get in the way, would they? Wouldn't work. Because there'd be a finite limit to how far you...
Okay, I see your point. I see your point. It's impossible to use that type or to use it in that way unless it's a flat Earth, right?
Require a direct line of sight. You won't have a direct line of sight
if the Earth is curved. Okay.
No way.
So the military is not using the curvature of the Earth into calculations to make their laser work. So they're thinking in a level plane, in the level water.
What? What do you mean leveled water?
There should be a mile of curvature at 100 miles, over a mile of curvature. It's not there.
Okay. I also don't know how to. I don't know how to respond to that. I'll be honest.
Yeah, it's a big thing. It's a difficult concept because this, if true, what we're telling you, and you should check this for yourself.
Yeah,
literally destroys the ball.
Definitely. I guess
they both can't be true. They both cannot be true. The surface cannot be being measured flat in the way that it is at the distances that it is if it's curving at 8 inches per mile squared, which is what they tell us it is and has to be if it's the ball that they tell us it is. Like I said, this is the crux.
Well, you should watch things that challenge your beliefs, right?
Which one is Earth curve, and which one is refraction, and which one is just consistent with a flat Earth? I mean, you know,
well,
now you start getting. Now you start getting.
So.
What was that, Sally?
I said, well, we know how refraction works, and it's consistent with the globe. I mean,
how do we know how refraction? There's no experiments that demonstrate how this refraction works.
Sure, there are.
No,
yeah.
No, it's just an assumption based on what we can see.
No, there's not. We understand how refraction. We do understand how refraction works. There are experiments that show that.
I was watching.
I was with the geometric shape of the curve.
Soundly, I was watching that.
The observations,
but soundly,
and the observations match that shape.
But soundly, here's the thing: you're using GPS. Isn't that a model that presupposes? Isn't GPS a model that presupposes the Earth is a sphere?
I know what you're going to say, and no, it does not.
Yes, it does.
No, it doesn't.
It's global. It's global positioning.
You know what I'm saying? Earth curve. Are you going to let me answer and correct your misunderstanding, or? Let me make this point real quick. Earth curve, Earth-centered, Earth-fixed coordinates are just 3D coordinates. It's like any type of 3D coordinate system you could use anywhere. You just set a 0, 0, 0, and then you measure everything from there. That's exactly what GPS coordinates are. You have to then take that data and you have to convert it into lat, long, and elevation. So the actual raw GPS data is X, Y, and Z values. So if you go out and record X, Y, and Z values, and then you take those X, Y, and Z values and plot them back into a graph, you'll get the exact shape that you just drove over. That's what Jesse did. So Jesse did that, which completely eliminates refraction.
It works by imposing a mathematical
Excuse me.
No, it does not.
Yes, it does.
No, it does not.
Dr. Soundly for a second.
It does not do that. What you're saying is wrong.
Excuse me. I'm just trying to clarify.
It is
Okay.
propaganda.
2 links from universities.
Nami, did you even watch his explanation?
What you're saying is factually wrong. It's flat Earth propaganda.
No, actually, it's not. I just put 2 links in the
What if the rate at which things disappear bottom up in the distance also happens to match the rate at which things would disappear due to angular resolution?
Oh, if only we had something like a camera to zoom in.
Zooming does not change the angles and diffraction limits associated with
it changes
your height
the
and your
angular
distance.
resolution, you goddamn mongoloid.
No, it doesn't.
It doesn't? It doesn't change the angular resolution? Wow.
Okay,
wow,
you
heard it
just
here
proven
first,
that
guys.
you don't know anything.
Nothing to do with the point at hand right now.
Yeah, have you got
Flat Earthers don't do the scientific method? Are you serious right now?
We don't do it. We don't do it.
with flat earthers.
Dude, you have to get. You're like
Look,
literally the second
not
step of the
true.
scientific method is developing a model. You guys don't have one. They're not measuring Z anyway. They're literally triangulating.
You said X, Y, Z. This is exactly what you said.
Why? You don't understand what you're talking about. I've been telling you why. It's like a cube, and it's triangulating the X, Y, and Z value inside of that cube.
What I've heard a lot of from Dr. John D is that in most of these low level, like right above the surface of water observations, I think he said you're more likely to get upward refraction, not downward refraction, which is the opposite. Which is the opposite of what the globe size says, and that's what Dr. John. That's what Dr. John D was saying.
Dr. John doesn't know what the fuck he's talking about. That's all there is to it.
Number 6, axial tilt contradicts Newton's theory of centripetal force. Remember, the stone in Newton's sling was neither rotating nor was it tilting.
Newton's sling? What in the world are you talking about? You're not talking about Newton's cradle, are you? No, I don't think anyone's that stupid to call it a sling. Welp, no idea what you're on about here, buddy. Let me just ask my live audience of this premiere if they know what it is. Yes, very interesting. Oh, there, Farhago says it's made up bullshit. Okay, yeah, that confirms it. There's no such thing as Newton's sling as far as I'm concerned.
I mean... This is absolutely pathetic, dude. Oh my god. Dude, I can't believe I'm having to do this. I can't believe this, man. This is pathetic. This is absolutely pathetic. Okay, let's, as Red's Rhetoric, that douchebag would say, let's break out the crayons. Let's break out the crayons, kids. So I'm in Newton's Principia. Okay, this is the primary text of your tradition, which obviously you haven't read. This is page number 74. And I'm in definition number 5. A centripetal force is that by which bodies are drawn or impelled in any way tend towards a point as to a center. Of this sort is gravity, by which bodies tend to the center of the earth, magnetism, by which iron tends to the lodestone, and that force, whatever it is, by which the planets are perpetually drawn aside from the rectilinear motions, which otherwise they would pursue and made to revolve in curvilinear orbits. A stone whirled about in a sling. Did you catch that, Professor Stick? A stone whirled about in a sling endeavors to recede from the hand that turns it, and by that endeavor distends the sling. Say the word? Sling, Professor Stick? And that with so much the greater force as it is revolved with the greater velocity, and as soon as ever it is let go, flies away. And et cetera, et cetera. He goes on talking about, he demonstrates centripetal force with this sling. I mean, dude, like this is fucking pathetic, dude. Like, I am embarrassed for you right now. How bad you are, like, making yourself look. This dude has 150. Professor Stick, are you an actual academic? Do you actually? Are you an actual professor? Because seriously, every single person that has paid you to teach them needs to, like, sue you for their money back.
Still hope you enjoy the show. Tonight, I want to welcome to Truth Frequency Radio a gentleman by the name of Dr. John, as he's known on YouTube. So, Doctor, first of all, thank you very much for taking the time out to visit with us and share some of your experiences, really as it relates to this topic, or this conversation of a flat Earth versus globe Earth.
Well, yes, it's good to be here, John, and talking to you, because it's because this is quite a story, and I'm still like going through this story. I am still like living this story. I'm still like investigating. I still have lots of questions.
Well, as any true scientist should probably admit, that's what their whole life is coming up with the questions, right? And then doing what they need to do to see how close they can get to the truth in asking those questions. So really appreciate that. So let's start out by just kind of talking a little bit about what you're willing to share about your education, your experience. You are a credentialed scientist, a PhD. Can you tell us a little bit about your background?
Well, I've been through the British system, just just like normal people do. The GCSEs, then on to sixth form. I did like the 3 A levels. I'm like in the 3 sciences, then to university, then like to another university to do my masters, and then like to another university to do my PhD research. So in like terms of a scientist, I would class myself, yes, as a scientist, but again, more importantly, I would class myself as a critical thinker that uses the scientific method to help me think and help me realize a problem and apply that scientific method to try and solve the problem or to get results so I can try and solve the problem or find an answer to that problem or even not find an answer to that problem, but find more questions that problem needs. So in terms of my education, it's just your normal classical science education all the way through. So music, languages, forget it. That's definitely not me. You'd be wasting your time. Yeah.
All right. Well, we'll save the music and art for another show. You and I can have a fireside chat about that. But we'll focus tonight on the work that you've been doing. And so, so now your PhD, your classical training, if you will, or maybe you would even use the term as I maybe would, your indoctrination, your programming, right? Going through the system there. Your training is in what specifically?
My training specifically is in spectrophotometry, so using light basically, infrared spectrometry, UV spectrometry, and visible light spectrometry. So it's all about light and the interaction of light with all sorts of like materials, like liquids, like solids. So it's all about light, basically. So you can see why I started to get involved in like measuring light and using like lasers. So you can see where I started to find like an interest in this whole like topic.
That makes complete sense, because that's really, I think, where a lot of people will start then when they start to question things. It's making some observations over great distances, and that has everything to do with light, right? Obviously, what we see with our eyes, the light that goes into our eye or our camera lens or whatever that is, that's where we're going to make those initial observations. Before we get into specifically the tests and the experiments that you've done and the observations and conclusions you've drawn from those, can you tell us a little bit about why? That's always the key question. Why? Why did you begin, do you think, kind of looking back now, why do you think you started to question what you were told about the shape of the Earth? Why did that even begin?
Well, I have to say I didn't question the shape of the Earth. How it came about was again, it's pretty like scientific. It's one of those scientific things where you find something by chance. You weren't planning it, and it's like, oh, that's like interesting, because to me that's the most important word in science, when someone says that's like interesting, because then you've got some amazing lots of questions. Oh, what's interesting? So of course I was part of my job is to teach, and I was planning some teaching on magnetism and light, etc. And I was looking on YouTube for suitable video, and on the side of YouTube, that list of videos that came up, and there was something about shining light. I was shining light across a frozen lake with lasers. So I thought, oh, okay, that's interesting. I wonder what these people are doing with light, because it's because it's my field.
That was your problem right there. You said that's interesting, so you clicked on it.
So of course I then start to watch the video, and they're shining light, and they're saying the lake is flat, and I'm thinking, what a load of rubbish. This is, of course it's not flat, it's curved. Yeah, of course it's curved. And then I start to watch more of these videos, and I'm watching the videos, and my brain is saying, no, this is lies, but I can't tell in the video that these people are lying, so I can see what they're doing, but we all know, the videos could be chopped and changed and photoshopped. So I got to that stage where I'm like, right, I have to prove this wrong, because this should not be on YouTube. This is just wrong, but it looks so real, and people will watch this, and they will think it's true. And I'm not having that, because my classical my education, or me, I know this is not true. So no, I can't stand. And again, like I say, part of my job is teaching science. So I want people to know truth, to know the actual truth. So of course then I was like, right, okay, I'm going to spend some money, buy some lasers, buy a telescope, and I'm going to investigate this, but not just investigate it, I'm going to prove this to be lies. And so then I got together a group of friends who are also scientists like me, and we went out and we started to do the tests.
Wow. So you took it upon yourself. You saw something online, and like you said, you could be anybody you want. You could say whatever you want. You can edit video, and you could try to pass it along as real. And so people throw these videos up, and I think I know which video you're talking about, because it made the rounds in the flat Earth community, which as being some very interesting, as you would say, evidence. That water, if it always is flat, at least the surface of it, when it freezes, you would think that it would be as well, and that makes it a great place to go and measure to see if there is curve, and to the Earth and that sort of thing. So, but you saw that, and you felt compelled. There was something inside you that said, I need to debunk this. Were you going to? Did you plan to do the experiments and then make a video as kind of a response to that? Is that kind of where this was headed?
Well, it's I watched the videos, and I felt like, you know, they're wrong. That, like, they're lying about science, and I'm not going to have that. Do you know what I mean? It was like personal. It was like, no, like, this is wrong. You're not going to show this to people, and people aren't going to watch this and go, oh yes, like, this must be right. It was like, no, I've had years of training. I know, like, this is lies. No matter what they're showing me, I know there's some, you know, like a, you know, trick, like, going on. There's like a magician's little trick that I'm not spotting, or like, you know, or like I don't have the chance because it's, you know, just like video I'm watching. I don't have the chance to see, like, what they're doing, you know, to, like, trick me, and I don't want them, like, tricking people. So it, you know, so like I said, me being a scientist was like, no, like this has to be proved wrong, or like lying. So then obviously, and I did spend, like, quite a lot of money to buy the lasers, because they had to be shipped in from China, you know, and the telescope, and I've never used, like, a telescope yet before, like, ever, or like cameras, but of course I then purchased, like, 2 cameras, quite expensive, because I was like, no, you know, this isn't going to happen. Like, this is partly my field. Like, this is light. This is what I've worked with. So no, like, I'm not, like, going to have this. Wow. So, you know, so then I got some friends together to, like, help me out, and, like, they were kind of, you know, they were more than willing to help me out, of course, because they, you know, saw like the video, and they're like, no, like, this is rubbish. Let's just get this, you know, like, proved wrong. So we were gonna we're just going to do some of the experiments and like take some observations. We weren't going to, we hadn't even thought about making YouTube videos yet. We were just going to get out there, get some experiments just to see what it was like, just to even start to do, like, the experiments, because because obviously it's outside, it's across the sea for, like, miles and miles. So we just started to just experiment with, like, the equipment first before we planned the full scale thing. Plus, like, taking, like, videos, or, like, making all the PowerPoints. We just started just to play about with it first.
Yeah, makes sense. And I could see, you know, from that perspective, to kind of relate to that, try to relate to that situation. It was also something that was going to be kind of fun, you know, a couple of guys getting out there. You got some new toys, you got some lasers, you got some new cameras, and going out there and doing some of this and practicing the scientific method. That's what you were, well, it's almost like what you were born to do.
We were doing real science. Like, real science, absolutely real science. It was, like, amazing. And like, one of my friend who used to be a scientist but stopped being a scientist, he was like, man, like, I haven't done real science for like 5-6 years. You know, actually, buying equipment, planning, like, the experiment, you know, actually doing the experiment, just like fantastic. And of course, not just that, you were shining lasers, you know, like, on, like, the seafront. We, you know, at a certain point we had crowds of people around us, like, asking us loads of questions, you know, because there's lasers and we're just standing on the seafront, so everyone can see the laser beam. So loads of people, like, like, what's going on? Like, what are you doing? Well, you know, we're doing some science here.
What about science? And I put that in, you know, in kind of quotes to say the scientific method, the scientific process. What about that process gets you so excited? Because I can hear it in the voice when you start talking about doing real science. You know, that's like, it's like, you know, it's very invigorating for you. What is it about it?
I have to say, it's just, yes, and it does, and I'm very, like, excited about, like, science, because it gives you the chance to explore and find answers to questions and truth to, like, understand, like where I am, like, where I live, how things work around me. I mean, it's that thing. You're being a child again. You are exploring your environment. It's what we're built to do as human beings. I mean, when was that fascination knocked out of us that we stop asking questions? When do humans lose that?
Well, I was going to turn that around. Where do you think, because you've been through years and years of the system, and obviously they didn't take it away from you completely because you wouldn't even be sitting here. But there's at some point when you obviously are learning about the scientific method, probably early on in grade school, in elementary school, you're learning about probably the scientific process. Where do you think, trying to look back now in your training, did you have to start taking maybe some things that you were told to be truths at face value and not where's the missing empirical evidence, where we come to an understanding, or we think we do, that we live on a globe that's spinning. Where do you think that line is crossed to where we're now obviously having to take that on faith, because that's not something that we can self-verify. And in fact, when we go out there and do some experiments, we're finding, making observations that don't seem to reconcile. Can you look back? Do you see a transition in your training where they get us to get away from the scientific method at some level?
I've got to say, and part of my job involves teaching as well, and it's very difficult. The whole thing of learning science these days is not learning science. It's content. It's learning content to pass your final exams. That's it. The exam system does not test your thinking ability. That's not what the questions do. They are testing what can you memorize, and and what can you then regurgitate to give the answer to the exam question. So unfortunately, I have to say, and it's partly me responsible because because part of my job involves teaching, is that we teach content, not how to critically think about science.
Exactly.
Unless within the class that you are teaching, you are trying to push both at the same time. But exams do not reward you, for critical thinking.
It's your ability to regurgitate the material as needed. Is what they're doing. So they're teaching you. The system now teaches you. This is a kind of a statement, or a profound statement I think it's profound, that the system now that the majority of people are going through, the public school system and universities, that they're teaching you how to take a test, not so much teaching you how to do tests. How to go out there and do exactly what you did, and that is roll up your sleeves, get out in the field, ask questions, come up with a hypothesis, the scientific method then, do the experiment, make the observation, draw conclusions, and then retest and change variables and that sort of thing. That doesn't seem to be practiced as much as it should be. Maybe it is in other fields, but when it comes to the topic we're talking about, it seems like that has kind of gotten away from.
Well, Paul, I have to say, I've been through the whole system, and it took me 45 years to start to think that for myself.
So it seems like it's designed to kind of keep you away from that at some level. The system is not, like you said, doesn't teach you how to think. It teaches you what to think, and not how to think critically. And
yes,
definitely don't ask certain questions. There's some certain things that I think we're finding now that is unquestionable, so to speak, that you don't question these things. These things are universal truths. The science is quote unquote settled, and so we don't even need to go there. Is that what you found as well in your experience?
Well, not just even that, Paul. I know when students ask certain questions, some teachers just lie. They just lie to them.
Wow. Can you give me an example?
So, for instance, yes, I can give you an example. When I talk to students about gravity, and gravity can't be proven due to the strength of gravity compared to the force, the magnetic force, and the electric force, the electromagnetic force is billions and billions of times stronger. And when I told them this, I said, well, if you've got this electromagnetic force and it's billions and billions of times stronger, how can you even know that gravity is within there working? How can you? So I say to them, imagine me I'm like pushing you for a billion times stronger, than you are pushing me. How would we even know that you are pushing me? And then obviously they went to like one of their like, other teachers because they were a bit blown by that. So they went to one of their like, other teachers and he said, well, yeah, they're all kind of one force. So gravity and electromagnetism are just all one force.
Just blurring the lines and causing confusion.
Yeah, I'm like, well, no, they're obviously not all one force. It either like does exist and we can prove it, or we can't prove it. You're lying to the students, because it's then I mean, like, where do you go from there? You know, because we're talking science and like scientifically here, you can either prove it or you can't prove it. If you can't prove it, say to the kids, we can't prove it, but this is what we think. But be truthful with them, because I'm always very truthful, you know. So, I mean, you know, and like, you know, they ask me loads of questions where I say to them, I'm sorry, I don't know the answer. That's way outside my field. I'm not going to just make something up. I could say something to you that, you know, that sounds okay, and you would nod your head to, you know, yeah, but I'm not willing to, because this is something that you need to go and like look up, or like, this is my homework. I need to look this up, and I need to get back to you and like tell you, you know what I found. But I've seen like this experience of other science teachers, you know, lie to them. And of course, Paul, you know what I do. I specifically set them up with these like critical thinking like exercises. They go to like the other science teachers around, and then they report back and say to me, oh, like, you know, like this science teacher said like so and so, and I'm like, oh right, really? Did you then speak to them about this, and did you ask them this? And the student says no, because the problem is that because the students haven't been taught, because the system doesn't teach them to like critically think, they never kind of like disagree with what you say. I could tell them like anything, Paul. I could tell them like anything, and like they would just nod their head and just believe it.
Exactly. That's the point. That's the whole point, I think, of the system. So it sounds like you've got a not that you were dishonest before, but it sounds like your teaching methods have changed a little bit since you started. Let's just say your perspective changed on tutoring and teaching the youth of today and the leaders of tomorrow. You're trying to at least subtly get them to become critical thinkers themselves.
Yes. So I present to them, for instance, so some things I present to them, this is what we think so far, or like this is just one of the things we use to like represent, like, this is what we use to represent, real life, like reality. But like this may be like different, it's just, this is just something we use to like represent it, but it doesn't mean it's real. It's just like, like this is the best we've got so far, but it doesn't mean it's right. And of course, like these things change all the time. The way we view like reality has changed for years and years and years. Just one of them is the model of like burning and why burning takes place. I'm not sure if you've heard of the theory of phlogiston. Even the word is crazy.
No, not even.
So like scientists used to believe there was a substance inside stuff called phlogiston, and when burning took place, that was this stuff called phlogiston, and this is what everyone believed. And then of course, we realised, it's not phlogiston. There's this substance around us that's needed for burning, and we all know what it's called these days. O2, like oxygen gas. And that's what everyone believed. There was this special substance inside everything, phlogiston. And of course, that was what we believed. Okay, fair enough, because that was the best we knew. It kind of worked. In a way, it matched the observations, or like most of the observations. But then, of course, someone came out with this new theory. There's this gas around us. We can test it. Like, scientifically. I can prove it to you, so I can show you data. And now we've changed. We don't believe in phlogiston like anymore, you know. And like people can go and read on this. So it's just like proving to the kids as well. Science is not a fixed thing.
Exactly.
It's always, you know, like evolving. We're always like redefining it. We're always, you know, just like refining it. We're always even completely changing it if we have to. That's what science is. It's not a, you know, like religion type thing where, well, like so and so said this, so do not like question it. No, you should be questioning all of the time.
Exactly.
You know, if someone, like I say to the kid, if someone makes a massive statement to you about science, physics, whatever, it's your job to like challenge it and ask for proof. You have to ask for proof.
Great.
Show me like, huh?
Yeah, no, I was going to say we got a break coming up. We're visiting with Dr. John, credentialed scientist, PhD, talking about the scientific method. And in the second half of the show, we're going to be talking about the experiments that he's done. We'll be back in about 3 minutes. Don't go anywhere. You're not going to want to miss the observations and the experiments that he has been conducting. So stay right where you are. Welcome back to Paul and the Plane Live here on Truth Frequency Radio, your protection from deception. Another Flat Earth Truth Tuesday is continuing as we are visiting with Dr. John, a credentialed PhD scientist and teacher. So we've been talking a little bit tonight about the scientific process, the system, quote unquote, the system that in his classical training, and maybe some of the shortcomings it has about the scientific method and just believing what you're told. And that's kind of where we left off here. And we're going to be getting into specifically what those tests and experiments are that he and some fellow teachers undertook. So let's get going again, Dr. John. So you were kind of talking a little bit about how the students really, no matter whatever the teacher is saying, they're just nodding their heads, they're taking notes, they're expecting that this is going to be tested on, and so they're getting really good at regurgitating information, whatever that is. And what your methods now, it sounds like, and not that you weren't doing this before, but maybe more of an emphasis now on getting them to think critically, ask questions, and be skeptical, and always test, and always think about maybe better ways of looking at a question or a problem.
Yes, Paul. The problem is these days the students are just doing things to pass the exams. Yeah, if you see what I mean. All they want to do is pass the exam to get the B grade, the A grade. They don't. It's very difficult because their main goal is to pass the exam, not to think, just to pass the exam. So, and I find that really frustrating because, to me, the joy of like teaching is to see your students thinking and just like questioning. Surely that's why we train humans up. So I do say to them, okay, we'll pass the exam. I don't, that's what you want to do. You want to pass that exam, but my job is to build you as a critical thinker. So when you leave here, you're a critical thinker, because that's how you're going to benefit in life. No matter what job you go into, no matter what you want to choose to do for the rest of your life, to me, if you can critically think, that they're like, you're made like for life. And surely people want to give people jobs who are critical thinkers. Surely.
Exactly. You're going to go a lot further, obviously, with with that sort of a skill than just the ability to regurgitate information, which anybody could do. Where you're going to separate yourself from the masses, so to speak, it's going to be in your critical thinking, problem-solving skills, and a lot of that is obviously practicing the scientific method and questioning everything. How do you find a better way to do it if you're not questioning the current way that you're doing it?
Yeah, totally agree. Because I say to my students, all of the companies out there, they want people who can like critically think, who can take a problem apart. And, you know, like I'm not one for making, I'm not like a company person where, you know, my whole life's just about, you know, like making, you know, loads of money, you know. Yeah, to me, it's, but I do say to the students, if you want lots of money, if you can critically think, you know, that's who the companies want, people that can save the money or make like more money. So, you know, so that whether you're like, you know, like greedy for cash or not greedy for cash, critical thinking is the way forward. And again, as like parents, we have to make certain like choices in life, you know, like for our children. And I want you to be able to critically think about all of these choices that you will make, you know, as a parent. So critical thinking to me is the most important skill. Like you say, you know, like content, the whole of human like knowledge, I'm sure you can fit like on a data stick, you know, like that's a robot's job. Humans, we do stuff with that knowledge. We like take it, we think about it, where can we use it, how can we apply it. That's what, to me, that's the joy of being a human being, is, you know, like that challenge of what to do and how to critically think. And again, it's that critical thinking that builds teams as well. You know, you like come across a problem, you don't know the answer, you then speak to someone else, that does have a certain skill, and that just builds all of the teams. And of course, us humans are such social creatures, and we thrive in teams. You know, it's
well said.
It's there.
Yeah, and that's where, and that's what it's going to take. More people with that mindset and going out there and doing things like you've done. All right, I want to make sure that we get in some, I have some time to go through some of these experiments that you've been doing, because I think they're really, really amazing. And your strict adherence, I told you this before we started recording tonight. Your strict adherence to the scientific process is what really caught my eye in your work. So for those of you that don't know, Dr. John has published some videos showcasing, exactly that scientific method, what the process was, and the observations made. Everything was documented thoroughly and published, and I'll make sure that we include, obviously, a link to all of those videos that you can view after the fact. So let's kind of pick up where we left off in the first half of the show. And you went out and you spent some money, you invested in yourself with some lasers, with some cameras, and you got some fellow teachers or colleagues together, and you all had this idea, obviously, to go out there and conduct these tests. So take us from there. Where did you start, and what was the idea?
Well, just like small boys, we started with the lasers. I mean, who wouldn't start with the lasers? Like the cameras, okay, fair enough, but the lasers, we had to start with the green lasers. They were far too much fun. They were amazing. So we knew it had to be, we knew it had to be along the coast. It had to be, right across the sea from one place to another place. So we knew it had to be across the sea, because the sea should be curved. So obviously you can't do it, with land, because land may be higher or lower.
Sure.
So living along the south coast of the UK, it was just the perfect spot. So we had people in different places along the coast, a few miles apart. I think we started about 10 miles apart ish, and we just went out just to see whether we could see each other's laser beams. That was it. We also had a bright torch each, and we just first of all just went out, let's see if we can see each other's laser beams and torches.
Sure.
So, and straight away we could, which we didn't expect to happen.
So you started with 10 miles. Was that an assumptive distance that you should not ever be able to even see the laser? I mean, I'm not sure how high off the ground we're talking here, but obviously you probably did some rough calculations to say, this should be behind the hidden height of a curve, or behind the curve, or whatever.
Yes. And then, of course, when we were standing by the beach, standing by the sea, we then, had our phones switched on, so we were talking to one another, and we would then just squat down lower and lower and lower till it got to the point where we were both kneeling next to the, next to the tide level. And I was like, nope, this can't be happening. And I was like, well, this has to be due to refraction or something like that. So thus I then like obviously had to go and read about, refraction, look up all the cases of like refraction, inferior like mirages, superior like mirages. So I then, like, again, it was that beautiful period of learning again. I was learning. It was fantastic. I was doing this science, and then I was reading all the background, just like soaking it up again, like questioning it, looking for photographs that, that proved it or like disproved it. So I then had to once again teach, because there's like refraction, that you learn within the lab, but it's very different when you get outside. Theory's one thing, theory's lovely, but once you get outside, then it's practical, that matters. So it was then learning, the like practical of light and how it interacts with, like the atmosphere. Yeah. So again, it was just back to learning again. It was, like being a student again. It was like brilliant.
I could see you got a big charge out of that, being part of that process again, and that's really why you probably became a scientist in the first place, was because you enjoy that whole process.
Yeah, like we were doing science. It was brilliant. We were doing real life science, like by ourselves, and we were doing the research, then like we were doing the practical, then we were looking at the results, trying to make sense of the results. What did they prove? What didn't they prove? What could we say to, like what like confidence did we have in these like results? How low could we get? How low could we get like to the sea? I mean, there was one point where I didn't care. I just walked into the sea. I wanted to see how low like we could get. So like boots on, I had on, like my welly boots, didn't matter. I just walked straight in. This was too fascinating. I didn't care about being wet. I didn't care about driving home being wet. I had to find an answer here. I had to find an answer because I wanted to prove these people wrong. So I was like, no, I have to do this.
Wow. So you guys started at 10 miles, and then I know you increased. What's the longest distance then that you've shot a laser to this point to kind of try and measure, obviously, measure for curvature? That's what you're trying to do. You're trying to measure curvature.
The mileage, I don't know, because we don't work in miles.
My apologies. All right, we'll do kilometers.
Yeah, unfortunately, sorry about that. Like 45
kilometers, so that's probably what, 25 to 30 miles. I'm assuming. I'm an American, so we're stuck in the miles. I forgot what we even call that system, the standard system, even though it's not standard throughout most of the world. But we think we're better than everybody else. So our increments are much longer. So for those listening here in the United States, 20, 25 miles or so, and how high were these lasers above the surface of the water?
10 meters.
Got it. So
about like 10 meters. But this was like we like we did them quite close, and then we thought, okay, let's go really far. According, we had to look at the coastline and go, okay, where's two good sensible like places. So we then went to those two sensible places. And we were both about 10 meters above sea level, and we could see each other's like laser source. And it was raining in one place at the same time.
Interesting, as we said.
So I was like, oh no. So once it got to that, obviously, I was confused. And I think a bit of what they call it, cognitive like dissonance started to like kick in.
Okay, all right, yeah, take us through that.
It's like no, something must be wrong here. Something must be wrong. This doesn't match with like what I've been told and what I know.
Well, that's your scientific mind, right? You're questioning even the results. So you got to find ways of eliminating some of those questions, right? So what did you do from there?
Yes, and of course, because the lasers, we've seen lasers do amazing things. Like I've seen laser lights like bend in weird like directions over large like distances. Because it's across the sea. All of the all the hot air, like the cold air refraction. I've seen some crazy like laser beams like bend and twist. So we decided to give the laser beams up for the time being, and we decided to just use cameras and the scope and focused on fixed points of light along the coast. And then of course that that lets us do like the calculations like better, because they're at fixed points, fixed heights. We know they're at fixed heights, and of course it would make the experiment repeatable, and it would make it reproducible. We could repeat it, and someone else then they can come along and they can reproduce it for themselves. So we decided to move from lasers to fixed lights along the coast.
Makes sense. So what's the extent of the long distance photography then that you've done?
45 again. 45.
Okay, so you can. Did you
23 miles?
Did the photography then provide, I guess, a level of validation or confirmation for your laser test then at some level? You were able to compare data, correct?
Yes, yeah.
So the lasers were propagating in a pretty straight line then, or at least at the same refractive levels that the photography did? It was consistent?
Yes, it was, yes.
Okay, interesting. Well, again, it's light going through a medium, right? We've got ambient conditions that are affecting that. You've got the medium with different temperatures and humidity, like you said, and so, there is a little refraction. So when you started to suffer, as you said, from the cognitive dissonance and said, this can't be, there's got to be some other explanation, you obviously went and started to look at other research or other explanations. And one thing that I've heard, and maybe you came across, is that refraction is causing objects, whether it's the light or whatever, to be lifted up from behind the curve to allow it to be seen from great distances. I'm assuming you came across something like that. And what are your thoughts? What are your thoughts on that?
Well. First of all, I have to say, as soon as I started to doubt everything, I knew what I had to do was just observe. So for hours and hours and hours, all I did was just go down to the seafront and just observe. Not make judgments, just observe and kind of watch nature. Just watch. Let kind of almost let nature teach me how she works. Don't make judgments on her. Just watch and observe and see how she works. Each night, so I'd be down there, for a few hours just before sunset. So, like this was during the summer months. So I'd be down there from 8. I would then leave about 12, like 1 in the morning sometimes, just to watch and gain an understanding. Because as you know, the textbooks are nice and easy, but once you're out there, it's a totally different ballgame. So I kind of said to myself, don't judge at the moment, just observe and experience, and let that experience shape your understanding, because otherwise I'm just going to jump to conclusions too soon. So I just had to watch. So I'd just go down to the beach and watch light sources and watch ships come and go. And I would just watch. I would, before I went down, I'd look at, the weather reports. I would look at the weather there, and I would try and gain an understanding of what I was seeing and how that was relating to, all of the temperatures, all of, the weathers. So before I wanted to even try and make a judgment, I just wanted to understand, if you see what I mean. Absolutely. So that would then make my judgment a more secure judgment. I would know that my judgment was a valid judgment rather than just jumping to one.
Very good. And then when you study refraction or these I guess other explanations on how you can see so far, despite there being a curvature of the Earth, what was your conclusion there?
Well, obviously, this is quite a simple thing. This is land and sea breezes, though the sea heats up more during the day. I don't even got time to go into the science. The specific heat capacity of water means it stores more like heat energy before its temperature rises. And so it stores more heat energy during the day, and then it slowly releases it during night. Now, no one yet debates this. This is what causes land and sea breezes, and no one debates this. So, this is agreed. So during the nighttime, the layer of air just above the sea will be warmer than the air like higher up than that.
Yep.
So refraction will occur in normal temperatures, unless there's freaky temperatures like going on. Refraction will occur in like an upward direction. That's it. Unless there's something freaky going on, that's how it is. And I know that's how it is because we've watched our laser beams and they always get refracted upwards. So I know it. Every single time it's upwards, every single time. If it does get refracted, it's always upwards. It's, that's what we've observed. I've never seen a laser beam being refracted downwards ever.
So how can if that explanation that we get holds true, then how could light? I'm left to see that doesn't seem to reconcile then, because we're told that light would be bending down and therefore we could see further. Or maybe I have that mixed up. How do you explain that to somebody?
Agreed. Light can be bent down if there's a temperature inversion, and then that will cause the light to be bent down. So like I said, unless there's some freaky weather conditions, light across water, not land, I'm talking across water, and especially at night, is always bent in an upward direction, unless there's a temperature inversion. But if there's a temperature inversion, you get a superior mirage, and you would see the superior mirage when you've got the object, you are looking at it, and there's one like just above it, which is inverted.
Yep.
So I've never seen one of those, and I've never photographed one of those.
So refraction is not an explanation for seeing that far, typically. And even if it was, then we should see like a Fata Morgana then, right? Which would be the inversion of the image, and it would be distorted a little bit.
Which is what then, like, I would be seeing and photographing all the time, which I've never seen and I've never photographed. So yep, I have gathered no proof that supports that.
That refraction would cause us to be able to see further than we should.
Yes, I've gathered no evidence. I cannot show you a photograph that has that inverted, picture on the image inverted. I've never seen it, and I have to say, I live by the coast. I've lived by the coast most of my years, and if you ask most people along the coast that live along the coast, that they've never looked along the coast and they've never seen a superior mirage.
There you go. So we've only got just flown by. So where's your head at here? You've been taught that we live on a globe, that we live on a sphere. Not to mention any of the movement of the Earth, but just the shape of our world. And I know you haven't been to every spot on the plane to measure or to make these observations, but at least where you live, in the places that you've been conducting these experiments, what's your conclusion?
My conclusion, Paul, is down to 10 centimeters above tidal level, the globe Earth-up model is indistinguishable from the flat Earth model, down to 10 centimeters above tide level. So obviously, I can't say it is flat full stop, but I can say 10 meters above tide level,
10
the
centimeters.
two models, 10 centimeters
10
are
centimeters.
indistinguishable, down to 10 centimeters. Now, whether that completely changes down to 5, you can't tell, because the sea-air interface, that haze that gets in the way. but 10 centimeters, because if you look at one of my videos, I'm filming from Worthing to Brighton with my P900, and I'm 10 centimeters above the water. So I can say down to 10 centimeters. But the globe Earth model is indistinguishable from the flat Earth model.
Wow. That's and you know what, and that's what we would expect, because we've been taught one thing, and reality would be, obviously when you, like you said, when you get out there and you're in the real world and doing these experiments, some of those theories don't quite hold up.
No, and what is also really strange, Paul, is people that live along the coast actually see this every day, but they don't realise the distances are actually that short where you should not be able to see things. And like I said on my videos, if you do not believe me, phone, send a contact to the Royal National Lifeboat Institute that is situated on Selsey Beach, and ask them what they see every night across the water. So if you think I'm lying, if you think I haven't told you the truth, you've got to send one email to prove me wrong. That's all anyone has to do.
Has anybody done it yet?
Well, no one sent me an email to say that I'm a liar. Let's just put it that way.
Well, you guys can go. Anybody listening, I'll make sure I include the link in the video here for the show notes, so that you guys can go and check out some of this work. We've only got a minute left, so I want to say thank you, Dr. John, for staying up late there in the UK to visit with us. You got 30 seconds here. What's the last word?
The last word, right. If you don't think the Earth is flat, please contact the Royal National Lifeboat Institute that Paul is going to put up, and prove me a liar. Please prove me a liar. And if you can't prove me a liar, guess what? Welcome to cognitive dissonance. It's hard, but we all have to get through it.
All right, thank you, Dr. John. That was a great last word. All right, thanks for listening to another edition of Paul and the Plane Live here on Truth Frequency Radio, your protection from deception. Hopefully we'll have Dr. John on again in the future, and we can hear more about some of these experiments. Strange World with Mark Sargent is coming up next. Thank you again, everybody. We will see you next week, same time, same channel. Good night.
Hey, Farguden, are you trying to get a word?
Sorry?
Go ahead. I was just going to let you get the floor. Yeah, go ahead.
Oh, yeah. Well, hello. I was hanging here for a few minutes, 15 minutes, watching all this going on, and I must say that they didn't quite look that good.
The last gentleman?
Oh, yes, especially the last one. He was a bit fast-paced.
You seem like an interesting guy. So, what side of the fence are you on in this debate here?
I think, just to set it all a bit straight on my side, I'm a current student of physics, so I place myself on the very, very other side from yours. That the Earth is a globe, and everything that entails it.
Okay, cool.
Yeah, that's cool. Glad to have you.
Well, that's good.
I just have one question, and I'll let you guys take care. Is there a difference between physics and theoretical physics?
Theoretical physics leans more towards generating new mathematical models and theories that are then observed and verified by experimental physics. They are both both sides of the same coin, experimental and theoretical physics. but they just focus on different areas of physics.
Are you saying there's no difference?
Oh, there's a difference. It's a difference of either spending the whole day in a lab or right next to a blackboard, doing math or creating theories to test. That's the word.
Making stuff up, yeah.
The difference in physics and theoretical physics is one is doing experimentation to draw a conclusion from the hypothesis test, which comes after the hypothesis, which is a supposition as to what causes a natural phenomenon, versus theoretical physics, where you have presupposition or theories as to why something's happening, and then you draw up a mathematical abstraction with that. Would you agree to that?
In the broad sense, yes. Physics can be split this way into either focusing on doing experiments or creating theories to test in those experiments. I mean, like 50, 60 years ago, there wasn't much of a distinction because back then everything was a bit more simpler. So physics can be at the same time very good at doing mathematics and theory, and also doing experiments in a laboratory with glass, bells, and vacuum pumps, and such things. But yes, in a broad sense, yes. I mean, there might be some disagreement in the details, but in a broad sense, I didn't hear anything that was blatantly off. So yeah.
Yeah. So were you in here when we were explaining that all of these theoretical physicists and different astronomers and people with PhDs or whatever, they're all on record saying that there's no way they can actually prove that the Earth is heliocentric in a heliocentric model as opposed to geocentric and stationary?
Yeah, I did hear you talk about it, and I think there must be some things to remember. I mean, this might seem like a cop-out, but it still must be kept in mind. Those quotations, where did they came from? Was it from a book they made to the public or in a textbook? For instance,
all kinds of different ones. So they have lectures they gave, textbooks, books, like infamous books like authored by Stephen Hawking. So these are direct quotes attributed to the people in this field, supposedly subject matter experts, right? I mean, within these quotes, we have Edwin Hubble and Einstein, and again, Stephen Hawking, Lawrence Krauss. It's ridiculous. We have the Royal Astronomy quotes. So an attempt to try to hand wave dismiss the whole thing with some excuse isn't honest. You should look at each quote individually, right? And if you really want to think there's a globe, then you may instinctively want to assume that they're out of context. Well, I encourage you to check them. They are not.
Oh, yeah,
here's another one. Go ahead.
Okay, so yeah, all right.
Cool,
sorry.
because it's the best way to learn, right? If you think that those people are right about the Earth being a ball that spins around the sun in a heliocentric model, then you should fully understand what it is that you believe, right? So whether the Earth rotates once a day from west to east, as Copernicus taught, or the heavens revolve once a day from east to west, as his predecessors believed, the observable phenomena will be exactly the same. This shows a defect in Newtonian dynamics, since an empirical science ought not to contain a metaphysical assumption, which can never be proved or disproved by observation. Dennis Schema, the unity of the universe. One of the founding fathers of modern cosmology.
Yes, I do get it, but to be fair, I'll tell you what. Those quotes, they are very interesting, and I would love to see them search back to the source and see that in another context. Because it is a quote.
To understand, well, we need to make sure they're understood. Right. So like when it says this shows a defect in Newtonian dynamics, right? We're talking about Newtonian physics, right? So like this shows a defect in Newtonian dynamics, since an empirical science ought not to contain a metaphysical assumption, which can never be proved or disproved by observations. That's a very important quote if you understand what it's saying. He's saying that for Newtonian to be taught as physical definitive reality or make a claim as such is ridiculous because it cannot claim to be empirical science when within it is contained a metaphysical assumption. That's philosophy, religion, belief. That's not empirical science. The conflation debunks it.
What do you think he meant by this metaphysical condition?
Yeah, like these fantastical concepts of gravity causing us to move around in this other concept of a universe with solar systems.
Metaphysical, abstract.
Yes. I do get what you mean, but the thing is, Newtonian dynamics, the model in which forces are applied to objects which then cause them to accelerate to accelerate. Those can work without a local acceleration, i.e., gravity. That's the whole equation F equals ma, from which we can derive many interesting things about how things can change in their position and speed.
That's not the point. The point is that using it doesn't differentiate that the Earth is spinning and there's magical force called gravity that's causing it, or that the Earth is stationary and things just fall based on the equilibrium being side over top of it, not moving. That's what it's saying. That's why it starts off with the distinction that you couldn't tell the difference if the Earth was moving to the east or if the sky was, or from the east.
Yes, I mean, if I just go outside and look at how the stars move across the sky, from that alone I wouldn't be able to say which one is moving because that's relative. Yeah, that makes sense.
That's right. So how you apply Newtonian dynamics is different if the Earth is moving or not moving.
Well,
so
of course,
if you understand there's a difference if the Earth is spinning and you're applying Newtonian dynamics than if it's stationary, which is why he's explaining that it was nonsense for Newtonian dynamics to make claims about definitive physical reality, including the assumption the Earth is spinning, because there's a metaphysical assumption intrinsic within it. It's just a belief. It's a philosophical belief of the Earth being a ball that spins around the sun. So since of that philosophical belief, you cannot conflate that to science. That's what the quote is saying.
Yes, but the thing is, you can apply the basic Newton laws of motion, and and I don't know if I remember this correctly. There is one of the three laws says that there is a local acceleration. Is that right? I don't think I can quite remember them correctly. If you can correct me.
It's an overview. It's not to get into random specifics of what you think about Newtonian anything. It's an overview of the foundation of Newtonian dynamics as a thing that was proposed. That's what it is. It was postulated as explanation of definitive reality when in fact it requires an assumption that is metaphysical, ontological, spiritual, philosophical, conceptual, abstract,
religious.
I frankly disagree with this. The laws of
what part of it do you? What part of before you continue? What part of it do you disagree with, and on what ground?
That the basic form of Newton's law of motions, the three basic laws,
talking about the difference between. We're talking about the difference between physics and metaphysics still, right? And so we're pointing out that you shouldn't conflate the two because natural science and writing on the chalkboard is two different things. What about that do you disagree with? Because this is what it was summing up.
That it's not a metaphysical; it's a physical assumption about reality, and metaphysics is by definition beyond reality, unknowable.
Right. So these things that are balls that have mass that we haven't verified or validated in any way, it's just presuppositional, which presuppositions don't belong in hypotheses or scientific theories either. Which part of this do you agree or disagree with?
Let me think. Sorry, could you repeat that question? I didn't quite catch it. I'm sorry.
Hypotheses don't have presuppositions that are predetermined, such as the mass of objects and how they move because of a force, without being able to validate or verify them in any way.
Hypotheses can have presupposition if they can be valid, and they can be valid if they are valid in an experiment.
No, but presuppositions aren't tested. Only suppositions are tested. So the supposition is what caused the natural phenomena observed. That's all it is. Then you run experiments to figure out either my independent variable does cause the natural phenomena or it doesn't, which gives you either a positive result or no result. Then your conclusion is the result of the hypothesis test. That's it. That is very different from a presuppositional statement that will not get tested.
Yeah. So, like, let me ask you this, bro. So, like, do you agree that in science, preference or convenience or philosophical idealism, so philosophical preference, right, or convenience, is that included in science?
You are talking. Yes, but those are subjective notions that differ from person to person, right?
That's right.
No, in science we strive to not include these in objective models. That's the reason why it doesn't science at all, to create as close a models as to reality as possible. If you include these cultural notions of philosophy, you model it to a local version of reality, which is not, real. Like, for instance, trying to incorporate your notion of, let's say, superior genders to others. If that is not true in reality, then it would not be. Then it is not true. No matter what you think, reality is the ultimate arbiter of truth, as in or models, which work and which do not work.
Exactly.
Hold on. Listen, I don't think he's understanding what you're saying. Really?
Oh, but I got him. Because where he's about to go.
I think he needs like a specific example, example of where this fails.
Yeah, maybe so. Go ahead.
You want me to give it to him? Okay.
You can.
So we have epicycles, right? That predicts the planetary motions as accurate as the second, I can't remember his name, Kepler's planetary laws, right? So Kepler's 3 planetary laws of epicycles. They're two models. They both have the same predictive power. Now, which one do you choose as the reality?
That's a good question.
So this is what they're talking about, how and even if you have one model, right, there could be another model out there with the same predictive power that you just nobody's thought of yet. This is why you can't say models are reality.
Of course they're not reality. That's true. They are a fiction of our humans, but still, if we try to model nature, reality in those models, we will not get a true value, but we will get a fairly accurate, pragmatically accurate value. So in the case that we have these two models with the same results, then that's a big problem. That's a big problem in science. It's called indeterminate. It's indeterminate. In which case, we try to step back and see from what tinier models are the bigger models made out of. What are their predecessors, as in on which theories those models are being based on, or models. And then try to evaluate closely and see if those models that those two are made out of are actually accurate, and see if they can fail in some experiment or observation.
Okay, so philosophical preference and convenience can only taint any attempt to accurately recollect on reality. So a model is tainted intrinsically if it has some philosophical undertone of preference or convenience.
It's subjective preference. Philosophy is a very wide subject. For instance, it does like a logic. It was originally included in philosophy. It was a field of study, which then evolved into math. So So if you mean first of all by subjective cultural or social values, then those can only model the experiment and the model unless that model tries to explain these from groups and nations.
Okay, bro. So I'm not trying to. You did pretty good. You admitted there's a difference. So here's a quote. The ancient argument over whether the earth rotates or the heavens revolve around it, as Aristotle taught, is seen to be no more than an argument over the simplest choice of a frame of reference. Obviously, the most convenient choice is the universe. And we just talked about how convenience is literally irrelevant to actual science, right? Nothing except inconvenience prevents us from choosing the earth as a fixed frame of reference. If we choose to make the earth our fixed frame of reference, we do not have to, we do not even do violence to everyday speech. We say that the sun rises in the morning, sets in the evening, the Big Dipper revolves around the North Star. Which point of view is correct? Do the heavens revolve or does the earth rotate? The question is meaningless, which actually isn't meaningless, of course, but do you understand what he's saying?
Yes, that unless you try and see what other metric these two models predict and how they differ, then if you just focus on this simple notion of whether I'm rotating or the sphere or the universe is rotating, then it'll be very hard to see which one is more right in this case or more accurate.
No, they're explaining there's no difference in predictive capability, and I'll give you plenty of quotes about that as well. That's what they're explaining. It's nothing more than, it's not that one's more viable than the other. And if that were the case, it would be geocentric because that's the default. This is what they're saying. I've showed you quotes of them saying it right now. Okay. So it is nothing more than a convenience issue, a philosophical preference. So you cannot adequately make claims about definitive reality if they are confined to your philosophy. If your philosophy is wrong, as you just said, then automatically your claims about reality are wrong.
If my philosophy is, as in my approach to or my view of how science is done, is that what you mean?
Yeah, you just now agreed and long-winded that philosophy is not science, and even Indio jumped in and gave you an example. You have to make some philosophical decision, or you just choose with arbitrary means to believe in. That is not science, and people are shocked to find out that in fact heliocentrism versus geocentrism is that very type of a decision.
Can I read two quotes also?
Oh, sure. Yeah, sure. Go ahead.
So before I read these quotes, now the reason that we're pulling these quotes is because you just said yourself that in science, if you have, two explanations for the same thing, something is wrong?
Well, if you have two explanations that are by themselves contradictory to each other, as in they can be both true, then you have to, then you find yourself in a very serious problem. As in, you can't say which one is which. You can't prefer which one is better solely based on what their predictions. Now you can try and be a bit more pragmatic, saying which one has more complex calculations or which one makes more assumptions. I think that's called the Occam's razor.
So you do know that that would be the heliocentric model. That would be the one with more assumptions. But setting that aside, because you're probably going to ask for that citation. So reading this one right here, all masses, all motion, indeed all forces are relative. There's no way to discern relative from absolute motion when we encounter them. Whenever modern writers infer an imaginary distinction between relative and absolute motion from a Newtonian framework, they do not stop to think that the Ptolemaic and Copernican are both equally true. Ernest Mach is his name.
So did you put it into the chat? I can't seem to find it.
No, I didn't. I'm just reading it. I can put it in there for you in a second. But here's another one. Einstein and Infeld, The Evolution of Physics. The struggle so violent in the early days of science between the views of Ptolemy and Copernicus would be that would then be quite meaningless. Either coordinate system could be used with equal justification. Two sentences, the sun is at rest and the earth moves, or the sun moves and the earth is at rest, would simply mean two different conventions concerning two different coordinate systems.
Yes. Again.
So you don't see how it parallels with.
Sorry?
Oh, my bad. You don't see how this parallels with what you said about the problem in science. If what you just said prior, you don't see the parallel here. And then you said, well, the one with the least assumptions, Occam's razor, and I said, well, the one with more assumptions is a heliocentric model.
The thing is, the number of assumptions is not set in stone. Anyone can try and question the assumption and then split them into small assumptions. But it's more of a which one is probably more accurate. It's a guesstimate. It's a guesstimate. Unless you can definitely discern which one is more.
But it's not science, though, right? Because it's a problem.
No,
or is there now not a? So it's not a problem.
Operating by these estimates and guesses is more about pragmatism.
Estimates and guesses. That isn't science, is it?
No,
natural science. I'm sorry, natural science and dealing with the physical and natural world through the scientific method. What you detailed is not that, right?
It's not accurate. That's the problem.
I'm sorry. I'm sorry. The question that I'm asking is guessing a part of the scientific method, or well, outside of the hypothesis, right?
Well, sorry, go on.
Is calculation and guesswork without the test of a hypothesis science? Yes or no?
If you don't test your guesses, your hypotheses, then you can't really say that they are true because you didn't test it by nature, but by experiment. So,
okay.
So they only remain hypotheses, unformed and unbased. Of course, they can have very elegant maps, very nice results, but if you don't test those results in reality, seeing it, if you set an experiment that can tell you if this number is the same number as the one measured, as the one that came out of this model or hypothesis or theory, then it just remains a hypothesis. Experiment is the sole judge of truth, accuracy, truth in this case.
Okay. So anyway, man, dude, we're trying to explain to you that it's philosophy, right? So they did this thing where they looked at the microwave background. The idea is that it's all the energy in the furthest parts of the universe they can see and all this nonsense they make up. Well, it showed you that everything was dispersing away from the Earth perfectly. And so here's another quote, but when you look at the cosmic microwave background map, you also see that the structure that is observed is in fact, in a weird way, correlated with the plane of the Earth around the sun. I need you to listen to this part, bro. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. That would say we are truly the center of the universe.
Yes, if that was not a coincidence of alignment, then it would be a very strange thing and would warrant some further attention.
Okay, I'll go find the quote that explains to you. It's nothing about
Why do they call it this?
That's not how it
works. I want to know, why do they call it the cosmological axis of evil? Why is there a moral connotation to what's supposed to be a scientific question? That's what they call this observation that Earth appears to be in the center of everything. Called the axis of evil.
The axis of evil.
Yeah, good. Cosmological axis of evil.
Correct.
Yes, that's a name.
Oh, yeah. So astrophysicist right here. The apparent alignment in the cosmic microwave background in one particular direction through space is called evil because it undermines our ideas about the standard cosmological model. The Copernican principle seems to be in jeopardy. So he just told you why they call it evil.
Yeah, that makes sense.
And then they came up with a mathematical explanation to band-aid the issue on top of the bad science. You don't see a problem with that?
Wait. Could you expand on that, please? Elaborate.
It's been a long time since So after they came out with this result, maybe India can help me out. What did they propose to correct for this issue? Was it dark matter, or is that something else?
I have not yet
No,
studied
that's
these
something else.
matters.
I actually can't remember, but they did say they came up with some weird geometric thing. I don't know where, like, I can't remember off the top of my head. And I'm not at my laptop, so I have to,
Well,
like,
they haven't really
I
come
don't
up
know.
with much viable at all, from my understanding. I'm trying to find the quote where the dude just admits as much.
No, I saw a Vsauce video on it. They did have something. Something like maybe things are different at different scales or something. Like physics are different at large scale. I think it was something like that.
Yeah. So that's what they're gonna have to say.
I mean, physics as we have it today does differ based on what scale we are, located.
We're literally
located in.
sitting here hearing you admit that everyone that you look up to doesn't know anything about what's out there on that scale, or even about the scale, or how to prove the scale, or that they know anything about the movement in the scale.
No,
how can you then turn around and say that it is like that? We're literally covering in excruciating detail how the people that have given you this story, when you say scientists and they are telling you that they don't even at all know how to adequately map out that scale. They have no idea what it is.
Yeah, I posted the picture with the axis of evil, and yeah, they claim they sent a satellite in space to measure the microwave cosmic background radiation, and they detected. So this satellite was like above the Earth's surface. And the problem is that this satellite detected that actually the Earth's North Pole is the center of the whole universe. And this satellite was not in that center point. So whatever it measured, it found out that everything pinpoints to our North Pole. So in that sphere of scan, which they claim they did, or a dome, they found that North Pole is the very center of everything, of the world and the sky. And they call it axis of evil because, it demolishes the heliocentric model and also the Big Bang theory.
To be frank, I have not yet looked at this particular issue, and to say anything on it from my side would be an opinion in this case.
In the Big Bang theory, the center of the universe is very, very, very far from our galaxy.
The thing is, there is no center of the universe. That's the whole.
Yes, there is. Yes, there is. In the Big Bang theory, there is a center of the universe. Yes.
Right. So, I was able to find a quick article, but yeah. So the problem with the CMB is specifically off of the back of the Big Bang Theory, quote unquote. We wouldn't expect to see what they saw with the cosmic microwave background. That's the problem. Right here it says, at the heart of the picture is the cosmological principle, which says that the universe appears the same on the largest scales no matter where you happen to be looking. This is what you'd expect in the aftermath of an explosion like our Big Bang, with all the constituents winding up mixed together in a randomized homogeneous soup. The reality, it seemed, wasn't like that, meaning the observations didn't match the model.
Yeah. And another funny thing about this satellite measurement, when they did the first measurement and they found this, they said, some things inside the satellite, some sensors must have been miscalibrated. And then they reapproached the problem, they checked everything, all the systems, and then they did the measurements again, and they found the same result. And also a third time, because the second time they also claimed there must be something wrong with the satellite. And they checked it, and then they did again the measurement, and they got the same result. And after that point, they dropped the project.
Hey, just so you guys know, I've heard a lot of people screw that word up. It's homogeneous. Homogeneous.
Yeah,
It's homogeneous.
say the adverb version. Wait, say the adverb version. That's the hard one.
Yeah.
It's the homogeneous. That's what it is.
Yep.
No, it's like hypothesis and hypothesis. To me, it's tomato.
Well, they're two different words, homogeneous and homogeneity. But here's
Is it? I don't know.
Yeah. Here's a different bro for you. So dark energy appears to be in the dominant component of the physical universe, yet there is no persuasive theoretical explanation for its existence or magnitude. The acceleration of the universe is, along with dark matter, the observed phenomenon that most directly demonstrates that our theories of fundamental particles and gravity are either incorrect or incomplete. Most experts believe that nothing short of a revolution in our understanding of fundamental physics will be required to achieve a full understanding of the cosmic acceleration. For these reasons, the nature of dark energy ranks among the very most compelling of all outstanding problems in physical science.
Yeah, that's true.
Yeah, so what they're doing is what they're doing, instead of going and even acknowledging that there's a viable option, which is that the Earth is stationed with a fixed frame of reference, they're frantically trying to explain the other as if it's not even an option. That is not science, is it, right? That is religion. That is zealotry.
And forced through religion. Not to believe it, it means to be a heretic for
He's
them.
sitting here saying, we have to scrap everything. Our fundamental understanding of everything has to be wrong. Yeah. And they're not even going to address that there's one other alternative that isn't wrong at all. And all this does is confirm it even more. And they pretend it's not even there. That is religious zealotry.
But that's not quite true.
It's literally true.
I'll tell you why that's not true. Because
Wait. What's not true? Specifically.
The notion that the geocentric position of the Earth is still remains a viable alternative to this problem that you mentioned.
Okay. So you're answering a question that wasn't asked.
I'm answering an issue. Can't I do
that? I'm just saying you're answering a question that nobody asked here instead of addressing directly what's been said here.
I'm just spotting up. I
know because the point that we're making to you is that though both mathematical representations or coordinate systems are identical, actually practically the same. The only reason that the Ptolemaic model is not viable, it's simply because they don't want it to be, because they don't feel like it should be. And there's tons of quotes where they say specifically that. There's no actual evidence, according to them, that could go against this. There's no hypotheses or no test that would disprove that the Ptolemaic model is correct. But on the grounds of philosophy alone, they accept that we're not at the center of the universe. So what about that is incorrect?
Yeah, when you disagree with it, you're disagreeing with the people that brought you your belief.
Well, to be frank, these are quotes. And the problem is science isn't through quotes. You are basically distilling a whole position to a few sentences.
They're not true quotes. Okay, so what?
No, they are true.
Wait,
but
okay, don't.
Oh, sorry. Yes, sorry. Cool.
So all you can try to say, and I covered this with you earlier, right? Because we're experimenting with this, and what we found out is that anyone that needs to cling on to the ball, they don't have many options here. It's very difficult for them because they think they know the Earth's a globe because they appeal to this idea of these superhero scientists with their capes on that did it all for them. So when you start to bring them those people one by one, and you show them what they're actually saying to explain what it is that they hold to be true, right? Then you don't really have many options to disagree with it. So the only thing you can really say is, oh, this must be taken out of context or cherry picked. Now, if something is cherry picked, that means that if you left it in context, it would actually reveal information that was contradictory to what you're claiming it says. Not one single quote that we're showing you is like that. They're all completely in context, and we encourage you and any of the readers to look up the citations and go verify this. I did.
All right. I thank you for the quote that you have posted in the chat, and I will go look at them later.
Okay.
But you should already know this, because in academia, these kinds of arguments happen all the time. There are hundreds of models. Like, you should know that if you're in school for this stuff.
So do you know what?
I'm trying to figure out what's going on, because I'm an outsider looking in. I didn't go to university, and I know this. Why? Because the people at university are informing me. Because I care about the information, right? So I don't understand why you're just hearing about this today.
It's not that I'm hearing about it for the first time. It's about that I'm hearing this particular. Yes, I am kind of hearing about it for the first time, because physics is a very large body of knowledge. So to expect anyone to know every single bit of it is
no.
I get what he's saying. I get what he's saying.
Very limited.
I get what he's saying, because he's lumping
okay.
physics in with theoretical physics, and we get that already. That's
okay.
Please continue.
Sorry, but
okay, well, we get it, man. But we need you to understand what we're trying to enforce. Like, the reason you don't know about all of it, even if you are studying it, is because they don't teach it. That's right. They don't actually teach it, because what it's set up to do is to get other people to try to help figure out the holes in the story. That's literally what it is. You're going into a field of study that has already made the assumption. That's what astronomy is. That's what modern astronomy is. It is a field that has made the assumption of the Earth and its position. It doesn't even cover the fact that that entire field is actually not even viable or in any way has been proven. They just assume it, and then they try to teach you the details about what's wrong with some of the stuff, and mostly what they think they've gotten right. And they want you to, over the course of years, once you fully get the fairy tale, try and help them piece the fairy tale together. We're letting you know the people that helped bring you the modern version of the fairy tale let you know they had to piece it together just to even propose it to you, and it's with all kinds of stuff they can't prove or understand. There are all kinds of stuff they can't even adequately explain. Do you see the bigger picture, bro?
I think I do get what you are meaning. Meaning to say that, there's the idea that you're trying to get across, that this is a big narrative formed from narrative and not from reality. And it's trying to make a fairly fitting narrative of the real world that can be, or should be, fairly easy to find spots where this narrative should and will disagree with reality, or i.e. experiment.
Yeah. So what exactly is it that you're going to school for?
Physics. Science in this case.
That's a super.
But of course, yeah, it's a very vague idea, I know. But still.
Okay. Fair enough. It's cool. So to understand the physics of the natural world, and it would depend on where your focus is. So are you interested in explaining physics on the Earth, or are you interested in explaining physics in outer space?
Imaginary.
Well, it is kind of true that some experiments done on Earth will be different than ones done in space. But so the first thing is to try and see what the underlying physics would say would happen if it was done on Earth or in space.
You're answering a question that wasn't asked. I don't mean to be rude.
Oh, of course.
I'm just pointing out that a question was asked to you, and I don't know if you're aware or not, but you're not answering the question. You're answering a question that no one asked.
Okay, well, I must try to get to it through this context, but all right. I don't really care if it is done on Earth or in space because I believe it is universal, depending on the local context. Like things don't fall in space, but on Earth they do.
Okay, so anyway, dude, I'm gonna fast forward this, dude. The reason I brought it up was I'm asking if you wanted to explain physics on the Earth or not. All right. Well, because if you want to fully understand physics on the Earth, you need to look back and see what brought us to our understanding of physics that we currently have on the Earth. For example, electricity and everything that we use in the world. And so when we look back, then we'll figure it out. And so all the people that gave us everything we still use for physics on the Earth, the original people, they actually assumed there was an ether. Then there was a test where they tried to.
Oh, sorry, you cut out.
They try to show you. They try to do a test that proved that the Earth was spinning in the ether, and it showed that the Earth was completely nil. Its velocity. Its velocity was nil, nothing. So it was like, damn, what do we do now? Obviously, the ether must be wrong because we can't even entertain the idea that the Earth's not moving. That's what happened.
Well, yes, that's a mechanism.
Funny thing,
right?
these laser interferometers are the most precise measuring instruments in automotive industry. Yeah, we use it to measure micron precision car parts. Yeah, and when you put the part that you made, to measure it, its dimensions, so that it fits the tolerances accepted. If you move that table where that interferometer is, that instrument, when it's measuring the part, you're messing all the measurements if you move the table. So they don't work if they are in motion, those laser interferometers.
Yes.
Yeah, so they show you that, speed, velocity in space is imperative. They have to be still so you can perform accurate measurements. If it's not still, if you install this interferometer in a train and you try to measure any component, you will get fake readings. You will have to take the speed of the train, which is moving, and actually equate that into that measurement anomaly readings, and then you will get your real value.
Yes, that's true. Yes, that's true.
So how can be something? How can something have zero velocity and it's actually constantly accelerating?
Acceleration doesn't always mean that the speed changes. Only the direction can change.
Well, we are always moving in a electric and magnetic field. Yeah, whenever we make a step in the world, we are moving in a electric and magnetic field. Yeah.
Yeah, and really the important part that you need to get, bro. I brought this up because you need to understand what happened. Okay, because obviously as we show you these quotes, you don't know what's happening. They found out the Earth wasn't moving. They had to pretend that that wasn't the case. They didn't even entertain that the Earth was moving. So then the theory of relativity eventually was come up with. And they took something called the Lorentz contraction, okay? And Einstein tried to apply it to the actual apparatus in the Michelson-Morley, saying that the apparatus itself, the physical apparatus, was contracting. Literally, okay? It's insanity. And that's just the beginning of the insanity. Then the theory of relativity goes on to desperately attempt to explain how the Earth's a spinning ball on an axis, but it's going to appear to be the exact opposite. That's what happened. That's what relativity is.
Quick question.
As a physics student, I would like to ask you one question, if you guys okay.
Sure.
Yeah, as a physics student, do you believe in Einstein's relativity theory?
I've only had experience with the special theory of relativity. I've not yet encountered the mathematical theorem behind the general relativity.
Okay, so my question is simple. Do you believe that your feet are older than your head?
That depends on what you usually mean. As in, do the photons that left my feet how much time elapsed since they departed and since they arrived in my eyeball? Then,
so you believe it? So you believe that your feet are older than your head?
The feet are older than I see them. That's the word.
Than your head. You know, your head is not where your feet are, and your feet are not where your head is. They are at different position locations at all the time.
But the relative speed of velocity is nilch, 0. In that case, they both experience the same time.
Not according to Einstein's theory of relativity.
Could you elaborate on that?
He claims that your feet are older than your head. Yeah, the twin, which goes into space and comes back, will be younger than his twin brother.
Yes, but do keep in mind that the twin was in a spaceship moving at very high speed as well, had very high velocities.
Yeah, and in your heliocentric model, yeah, your feet are on the ground and your head closer to the sky. So the radius from the axis of spin is different. So your velocity in space is different than your feet.
They do still have the same angular velocity.
No.
Radius, dude. If you're in a little gravity well space-time fabric, then you're in a different place in that relative to the mass that displaced that magical space-time fabric. So you would have a different effect, and he incorporates time to that, right?
Yes. Oh, that's general relativity. Yes, that's if you are including that one, then yes, those will have different time spans, but of course very very tiny, very tiny. You
So your feet.
them.
Then I was right. You believe your feet are older than your head.
I was assuming that you were speaking about special relativity, but yes, from what I know of general relativity, then that would be true. Of course, you wouldn't really know how you wouldn't really detect that.
Do you think that it's normal to believe that?
That's pretty crazy, bro.
It is not common sense.
Do you think it sounds normal? Huh?
No, it's crazy, I know. But the thing is, we cannot rely on common sense in these cases.
Oh, that's fair.
Right.
You mean actually you have to exclude common sense? Is that what you mean? You have to get rid of it.
Look, where do you think common sense came from?
Common sense is inherent in our reality. Common sense is inherent in our reality, and whoever made it or whatever made it.
Yeah.
Yeah, I mean, if they come from your senses, that's why it's in the word. That's why the heliocentric model is, by definition, nonsense.
Well, let's get to the let's get to the crux of the philosophical debate.
Okay.
So now people say, what shape is the Earth? Is it flat or is it round? Now, problem number one: flat is not a shape; it's a description. It's an aspect of something. So automatically, this juxtaposition is that the media puts out is already incorrect on arrival. So the question is it a sphere or is it not a sphere? So how do we determine that it's a sphere? Well, they've given us certain methods to calculate that it's a sphere with a certain dimension. Now, being that that's the case, we measure and test to see if the sphericity is there or not. So before we even go into that, if the Earth isn't a sphere, what really changes?
Okay, well, on the locally, like within your room and such. So now, actually,
No. If it's not a sphere, like if the Earth isn't a sphere, what does that change academically for you?
Well, I was getting to that. Locally, not much difference would be felt. Like your cup of coffee wouldn't be different on the different laws of physics.
Well, is there any difference though? You said not much difference. Is there any difference? Is what he's asking.
Oh yes, difference would be that under known laws of physics, a series of things would happen depending on what actually do you mean by flat Earth.
Okay, so all the physics were come up with on the assumption that the Earth is stationary and flat. That's the only way we can physically do anything in the world successfully. So physics, if it's science, then you can physically test it, meaning you can use it. You can do something with it successfully because it's physically true. It's physics. That all assumes that the Earth is flat and not moving. So when you say on the local scale, not much would change. No, the answer is that literally nothing would change. And if you claim the Earth's a globe, you just have to say that it's identical to what it would be like if it was flat and not spinning. But relativity says it just tricks you. It's an illusion. And that must be true.
Well, let's not for a moment include general relativity because I don't have the math behind it to tell what would be the consequence.
Okay,
so
it's just important to understand it, man, you know?
Yes, I do know what you mean. But when you ask what will be different, well, to answer that, I would need to know what is different in the scale on the Earth. So would this flat Earth have a thickness? Of course, we know
the deepest anyone's ever gone in the Earth, ever, is under 8 miles. So it doesn't matter what anyone says about anything beyond that. Literally means nothing. It's just a fairy tale. So we know nothing more than that.
So let's also go on.
Well, yeah, because when the globe Earth made all kinds of predictions about what would be all the way down to the 8 miles, they were wrong about the entire thing. So that definitely doesn't help out anything but flat Earth. And that's the point we're making, is everything is like that. Let's use radio waves for an example. What would it change if the Earth's flat? Nothing. That's how we use them. We shoot them horizontally for thousands of miles.
Not quite. In a flat Earth, the signal bouncing back from the ionosphere would travel a larger distances because they would encounter the upper bounds of the atmosphere at a different angle. This comes from.
Well, I didn't really want to get into. I don't know. Maybe I asked the wrong question. So what I want to do is take you to whether or not the Earth measures to be a globe or not, and then go from that perspective, because we can't measure it not being a sphere, and then you then say, well, it wouldn't work if it weren't a plane, therefore it is a sphere because of lasers bouncing off the ionosphere, whatever the case.
But
right?
real fast though, I think it's important to make him before that. I mean, okay, the conversation was, so like, what would be the difference? And so I brought up a perfect example that not only would there be no difference, but it's just how we actually use something. And so he said, nuh-uh. He needs to know specifically, this is a good example because this is how the whole thing is going to be for you. You think right now, nuh-uh, the radio waves wouldn't work like that if the Earth was flat. Now, here's what actually happened. Someone named Marconi sent the longest radio transmission ever at the time, over 2,000 miles, 2,200 miles. All the people said, you can't do that. The Earth's a ball, and it'll block it at 200 miles. He ignored them. He used line of sight. He horizontally hit his target the first attempt, 2,200 miles away. He then ended up sending one 10,000 miles horizontally, hitting his target using line of sight directly in front of him, assuming a plane underneath him. Then people had to theorize with the idea that there's an ionosphere up there, and there's an area where it actually reflects back down and comes down and lands on the globe. Now, that's what actually happened in actual historic reality. That's what happened.
Yeah, that's a good example of what you talked about before, about the two models still giving the same result. So in either case, the signal did go a very long distance, and in your model, on flat Earth, you say that the signal went further because there was no bend, no curvature, so there was a line of sight between the target and the receiver.
Correct.
And also, yes, and on the globe Earth, another idea was formed that there could be something like that, or can be some. There might be something that can reflect back a portion of the signal from this layer of ionized atmosphere.
Right, but they came up with that idea to try to explain how it could have happened on a globe. They said, you can't do this. It's physically impossible. There will be a huge hump of Earth curvature physically blocking the radio waves. You cannot send it that far. He ignored them, sent it anyway, and it hit his target the first try, 2,000 miles away, and it was supposed to get blocked by the Earth's curvature at 200 miles. But then he sent one 10,000 miles. Okay, so the facts are that when you assumed the globe, you said you couldn't do it. Then you physically did it, and we do it all day, by the way, every day, all around the world. Okay, and it showed that it wasn't over top of a curved surface. It was over a horizontal.
Hello?
How could that have happened hypothetically to keep the assumption the Earth's a globe? It's just objective. If you want to know the truth, you have to put your big boy pants on and be honest about it. Right? So like they didn't teach you this in school. There's a reason. Right? But this is just very easy to verify. National Geographic covered this, saying what I'm saying to you. Even mainstream knows.
Yeah. Also, when you go to U.S. Military Academy and you want to learn about radar technology, you will be learning electromagnetic waves propagation over flat stationary Earth.
Correct. The military has a ground weapon system.
Yeah.
As a weapon system, they send radio transmissions, a ground weapon system. And the title of the military paper that you can have access to, it's declassified, is Electromagnetic Propagation Over a Flat Earth. And it explains the only way they can adequately acquire target acquirement, is assuming a horizontal propagation over a horizontal plane. And they use it, and it costs millions of dollars to produce it.
Yeah.
I have not read that report, so I can't really speak on it. But I can say that this comes back to using what models for which purposes. So let's say, for instance, that this is a hypothetical explanation of why they might have used a model of a flat Earth for radio propagation. So let's say that the calculations needed to calculate this effect on a spherical Earth are more complex. They need to account for curvature, so we need to use.
What happened to Occam's razor?
No, it's very simple what happened. If they shot the waves assuming that the Earth was a globe, they couldn't hit their target. So they had to create a viable model to shoot and hit their target, because we're talking about the military. That people's lives are at stake. You have to get the bad guy. We're not talking about I want to play games and make up stories. This is like real life. And so they have to assume that for it to work, and it's explained in the document. They have to assume the Earth's a dielectric plane. Dielectric is just a word that means electrostatic. The Earth is intrinsically electrostatic, and it's a plane within a magnetic field, and it's horizontal. They have to assume that to use the weapon system that they do use on a regular basis. And this is they are dropping the document for you. If they're not, I will.
Okay, I'll look into it later. Thank you for that.
As a student physicist, you also have to know about electromagnetic waves reflection. What happens when light is being reflected by solid matter or liquid? How does it reflect? When it's reflecting off an object, will it have the same lumen intensity? It will carry all that lumen intensity infinitely, or we have light attenuation, light inverse square law?
That's a good question. Yeah. So when light does reflect off materials, of atoms, two things can happen, or two kind of thing happens. Either the light reflects elastically, just bounces back off like a perfectly elastic marble, which really
that's how we try to imagine it at atomic level. But in reality, what we see is that when you have light reflecting from a solid object, when you shine light on a wall, every light beam wave, that hits that wall will be reflecting at infinite angles, all the angles, not just like that certain ray beam. Like when you shoot a laser beam into a wall, you see the laser a straight line, and it doesn't reflect at the same angle, opposite angle, backwards. You will see only a very bright dot on the wall, and it's very much like the light source itself, the laser, but it will not shine to you in your eye the same kind of laser beam coming from the laser device.
Yes, that's true. And I can give you.
It will be diffused.
Yes, that's the word. That's the word.
It's not a beam anymore.
All right, bro. But just because I did take it away from Eli, and like he's asking the most important question, I wanted you to realize that it sounds like a crazy thing to take in. We get it. We got the same thing. Everyone has different amounts of times they can even be honest about it. You find out, well, what would be different if it were flat and not moving? And then you look at everything else in life and you realize that literally nothing else would change because that's how everything you've ever experienced your entire life is. And you see the sun move in the sky because it moves in the sky. And you don't feel like you're moving because you're not moving. And the horizon is horizontal because it's horizontal. That's why it's horizontal. Sea level is called sea level and assumed to be flat because it's flat and level. That's why it's called sea level. And you will find out quickly that everything that works in the real world has to assume this and utilize this fact. And we're trying to break it down for you. You're going to have to look into things because it sounds crazy. And we were all taught that. I did.
And, you know, even on the globe, the down vectors are divergent from the center. Yeah. On the surface of the globe, the down vector is convergent to the center.
Yeah, like if you want to know the truth.
This means, go ahead.
Well, Eli was telling you the most accurate way, most efficient way to know the truth. They claim the Earth's a globe. It has a radius of 3,959 miles. It's on a 23.4 degree tilted axis. It spins 1,037 miles per hour east at the equator. If you want to know if that's true, then you can physically measure the surface of the Earth. It has to curve at a rate consistent with that radius value. That is 8 inches per mile squared, specifically 1.225 times the square root of the observer's height in feet is where you would see the curve of the Earth. Now, I'm not trying to overload you. I'm just trying to explain to you. It's very simple. The Earth's a sphere with a certain size is a geometric claim. The way that you can test or falsify this claim is by physically measuring the surface, and geometry is how you do that. When we did that, and you can do it, it falsifies the radius, which means everything they told you about the Earth cannot be the truth.
Yeah.
Well, I'll take a look at the geometry of that lecture. Okay, so thanks for much.
Geometry is how you measure shapes.
Yeah, I think using geometry in this case is a valid method of saying what will happen and what is, well, yes.
Well, it's what we have to use, right? Because if the Earth's a sphere that's this size, you're making a shape claim with a size. The only way to test a shape claim size is by the measurement of shapes, which is defined as geometry. And it's simple. The sphere has to curve at a certain rate if it's a sphere with a certain size. So that's the most efficient way to test it. We tested it, bro. We have observations where the radius value would have to be over 250,000 miles. And they claim that it's 3,959 miles.
Did you post your methodology in the what was it in the videos in the section about some of the topics below?
Yeah, everything we're talking about is in the sections below, and we can drop in the voice text the observation that showed the radius would have to be over 250,000 miles.
Oh, good. Thanks. I'll look at that later. Let me just write it down.
Don't want to drop the light. I never use commands or anything. I'm modded, but literally never use it.
A black swan. What about modern technology like linear encoders?
I'm not familiar with those. What are they?
You don't know what they are?
I've not yet come across them in linear encoder.
Linear encoders is like a ruler, yeah. We use in mechatronics, yeah, for precision positioning and repeated motion, which you want to be happening between 2 points very precisely, yeah, like CNC machines, computer numerical commands controlled.
Continue.
Yeah. So there is a company manufacturing linear encoders. It is a band strip, yeah. And on these band strips, you have very, very thin lines, yeah. Just like on a ruler, you have those millimeters or inches gradations, you know, and at equal distance. But these band strips has these lines like a few picometers in thickness and a few picometers apart from each other, but symmetrically apart from each other because it's a ruler, you know. And they are laser engraved. So when you look at it, it does look like the surface of a CD. You can see it looks like a rainbow, you know. It refracts light.
Oh yeah, that's a very, very cool effect. Yeah, go on.
Yeah. Now, there is a optical laser device, yeah, which shines a beam on that strip, yeah, and there is a sensor which counts all those strips, you know, and this way the machine can tell you precisely how far it has traveled, yeah, and it's coming back. Now, this linear encoder is 200 meters long, and its precision tolerance is 65 nanometers. So I send this machine moving in a straight line 200 meters far away, I give it command to come back, and I give then command to go back far away again in the same location with a precision of 65 nanometers. As a physicist, I am 100% sure that you are very well aware how much is 1 nanometer.
Yeah, it's not a very small amount. Very small.
Yeah, 65 nanometers is a high grade precision. This kind of small size, we use it in computer microchips, like many computer microchips and smartphones. Inside their chips, they have technology of 60 nanometers. Yeah, 80, 120. Like before 2010, vast majority of computers were above 100 nanometers. So those cables, those wirings inside between the transistors and stuff, they were 100 nanometers in thickness. We're talking very small sizes. And you see, according to the Earth's ball radius, 3,959 miles, yeah? When you convert that to metric units, in 100 meters, yeah, you are supposed to have about 7.8 millimeters curvature drop, according to the overall globe curvature. Now, now this is not really a problem for us, which I mean, we can build flat surfaces, because that's what these people actually did at Airbus. They built a very big building, 200 meters long, and the floor is perfect flat from one end to another. It's a plane, very precisely measured. So they installed this 3D printing machine, yeah, which is laying carbon fiber, and it's printing large structures of carbon fiber for aerospace industry. And the precision grade in printing those carbon fiber structures, they are laying down micron size carbon fiber, yeah, and align it in all their chosen patterns, yeah, so they have they achieve the best structural resistance according to the way you are laying those fibers. Now, this machine, when it's moving from one end to the other, 200 meters, yeah, the down vector on the ball is not parallel between two locations, correct?
Yes, but this is a small part.
Well,
yeah,
we have included. We have included, like, in 100 meters, there is 7.8 millimeters drop. But with our engineering, we built that flat surface. Now, at the start location of the machine, yeah, we align this machine, yeah, with the down vector to be perpendicular, yeah, and it's moving across a flat surface, perfectly straight. And when it's reaching at the other end, after 200 meters, are you trying to say to me that that machine will not be affected by the tilted down vector?
The machine calibrates how many times during its movement? Only once or continuously?
Well, they use actually that encoder, which the machine uses to measure the distance it's traveling. They use that encoder at both ends, they place two plumb tools, plumb lines. They hang them from the ceiling, with a very thin wire, at both ends, and they are measuring the distance at the bottom, and at the top. And this way, they form a perfect rectangle, So now they know exactly when this machine is tilting or not. And guess what? They found, they weren't searching, but the way they installed this machine, those plumb tools, they were found to be perfectly parallel with 65 nanometers precision in 200 meters. So if there were any change in the angle of the down vector, you would have noticed it in those plumb tools. You will see that they are not parallel. But in building this machine, they use those plumb tools because they are perfectly parallel to each other. So the down vector in location A is parallel with the down vector in location B.
Yes. So yeah.
So how does this work on the ball?
Well, first let's can I ask what is the precision of those? So you could measure any the difference that is beyond those 65 nanometers of accuracy.
Well, when you travel 200 meters, your margin of error positioning is 65 nanometers.
Mm-hmm.
Yeah, so you are 10 nanometers further or closer,
Yes. Because the thing
those
is,
65 nanometers, you do them by 2, 32.5, and that is how much that machine will travel further or lesser, 65 nanometers, which if we are measuring the curvature of 7.8 millimeters, with 65 nanometer precision grade, I think you have no clue what you're talking about. How many nanometers are in 7.8 millimeters?
Sorry, how
You
many
can
millimeters?
measure it very, very precisely.
Yes. Yeah. I believe you what you saw.
Yeah. So.
Just let me get this straight. So to check if I got it all correctly. In this room, in this hangar, you have a perfectly flat manufactured surface within that precision. Yes. And to measure how the let's say if you have something that's standing on top of this plane, you want to measure what is the angle towards it. Like, is it perfectly 90 degrees above it, or is it at a slant? I assume you have something like that, right?
Sorry, I didn't get you.
Sorry. You mentioned that you use those two weights on a string to check.
Yeah, the plumb tools. Plumb tools, yes.
Yeah, and then you compare your, I think it's your printing head to these two calibration devices to see if it's still pointing down perfectly, right?
Well, you see, the machine is moving perpendicularly with the surface of that building, because that building surface is perfect flat. It's built engineered like that. But at the start location, you have the machine calibrated with the downward vector. Yeah, so it stays perpendicular, and the downward vector is also perpendicular with the machine. Now, if the Earth was a globe, when this machine is traveling 200 meters, yeah, on a flat surface, yeah, it's not curved, yeah.
So say you
At
do
the,
not
at the
measure any.
end of that location, because your surface is a straight flat, yeah, at the end of that location, your downward vector will be inclined.
By
So
how
the
much?
machine will feel like it will be tilted, because it will not be perpendicular with the machine anymore, because you're moving the machine on a flat surface built on the surface of a sphere, artificially built on the surface of a sphere. And when you have a flat surface on the surface of a sphere, yeah, you can actually choose. Let's say we build a flat circle, like a disc, yeah. So we have a radius of 100 meters of a flat surface circle, and we choose that downward vector, which is perpendicular with that surface, will be in the center of that circle. And now, when you move,
Can I interrupt?
Yeah, sure. Go ahead.
Before I got on the train, we were talking about geometry or possibly the lack thereof.
Yeah.
Is all of this conversation in response to maybe a measurement or something he saw, and now he's trying to figure out, like, what laser was used, or like what is that what's going on?
No. I was telling him about. Well, I didn't get to even tell you. You asked me, and then you asked me what the hell I'm talking about.
Okay, why did you change
Never
the
mind.
subject? I'm trying to figure out what was the reason for the topic shift, or am I wrong? And are you like, how did it get here? Because
No,
I
I
heard you
didn't
talking
say you
about it.
were wrong.
I heard you talking
I
about
was-
it in Midtown,
Yeah.
right? I had to ride underground, and I was like, okay, I'm not gonna bust his chops because let's see what happens. So here I am 15, 20 minutes later asking you, how is it relevant to the conversation that was being had before I got on the train? And you're telling me it's not. Is that what you're telling me?
I'm talking about that curvature, non-existing curvature, and divergent downwards vectors, which are
So he's
has
seen
to
a
be
measurement?
present on the ball.
So
Yeah,
he's seen
I
a
told
measurement?
him about. I told him that this machine is actually doing a very precise measurement between two plumb tools, and they found them that they are perfectly parallel, yeah, in 200 meters distance with a 65 nanometers precision grade.
Okay. Well, I apologize.
Yeah, and this will be impossible on a sphere with the down vector converging to the center of that ball. No down vector on a sphere can be parallel with a different down vector from a different position on the surface of that sphere.
Yeah,
that will be like saying you can have a sphere with two parallel radiuses.
Yes, that's a very good question, a very good example of something that can say which model. Okay, it can very well test the assumption that we have on Earth. Yeah, it's a very good question, a very good model.
Yeah, it's either is there a variation in what would be the proper word? Is there like an elevation change or an altitude change from the point of the observer or the plumb to the next plumb? Like there has to be a change.
No, there is no elevation. Like the surface of that machine, the floor is made perfectly flat and level. So wherever you put a level in that building,
I mean the elevation
bubble will
as
point.
in,
Yeah.
I mean the elevation is in the theoretical, like the 8 inches per mile squared. Like from you, the ground would have to be descending away from you on any on any point of the globe. So it's like, for them to be perfectly and parallel to one another, that's impossible on a curving surface. That's not possible. It's not even about shape at that point. It's about whether or not it's the sphere or not.
Well, the interesting thing is that he mentioned that the surface is made to be flat. Those 200 meters are flat, right?
Yes. Yes.
So, so there's not much. Well, yeah. So the thing is, on a
There is
globe,
zero curvature.
yes, on that plane there will be zero change in elevation. Then very well flat. And you are right. If this was a globe Earth model, would predict that the two vectors, those two plumbs, there would be an angle between them.
Yes.
Now, this is the $1 million question: is could we measure this difference?
Well,
you mentioned that you have like those.
Measure. You see, when I said this linear encoder is the instrument that actually tells you, the distance when you travel 100 meters. Yeah.
Yes.
And it tells you went in a straight line or a curved line.
Yes. And so the way to a very simple experiment. Let's say I'm going to calculate how much difference, how different the angle between those two plumb should be, assuming perfect angles, assuming that those two point to a center and are not offset by, say, a local mountain or a lake. And then I'll come back with an answer, and we'll see what's the answer. Is it below or above your detection limit? That seems like a good experiment, right?
Yeah. I mean, for 100 meters, the arc curvature should be 7.8 millimeters. So this means that between these two radiuses, you have an angle, which that angle we must be able to measure it. That angle cannot be parallel lines. You can't have an angle between parallel lines.
Yes, you're right. Perfectly.
Yeah. This is the problem. Yeah.
Did you can you provide a link to your calculation that shows that the difference? I would love to look at it. If you
This
at hand or later.
This one, I tell you honestly, I'm looking into building my own CNC machine. I was looking for linear encoders. I'm a flat earther. And I came across this company that's producing these linear encoders, and I started reading about them. And I saw that they supply Airbus with these linear encoders for their giant 3D printing machine, which are printing carbon fiber structures for the aerospace. And I went into looking how they calibrate that. I read how that 3D printer actually works. You can find it at Airbus. It's not like secret hidden technology or whatever.
A small question: are you confident and sure that this machine does not account for any possible for this difference? Let's say that the answer that it provides is the raw measurement and not some corrected fact number.
Yeah, it was about 1 month ago, or 1.5. And to be honest, I didn't save this website, which now I'm pretty sad about it. No, I should have saved it.
Yes. Yeah. Because if they, let's say that they are in on it and that they want to still perpetuate this, the myth of the globe Earth, then it would be very easy to ask them, does the machine account for this and how?
Well, they were saying, they were not saying about taking into account the Earth's curvature or anything like that. They were talking about installing and calibrating the machine. And they used plumb tools, to precisely position and also to verify the rail tracks, that they are correctly installed, perfectly straight. So when that machine is moving across inside this building, there is no deflection in the down vector or anything. This machine in no position in that building is not perpendicular with the down vector. And on a globe, if this was true, when you build such a big machine, when you move this machine, like 4 or 5 meters tall machine, printing head, and the down vector is tilting, this machine is heavy and will be bending, and it will change the angle which the printing head position will not be correct, precise.
Yeah, that's also a factor in this.
Yeah, and what I read there is that they built it on a perfect flat surface, a building with a flat floor inside, 200 meters long and about, 20 or 40 meters, 20, 30. It's huge building. They have airplanes inside there. And Airbus, does build very big airplanes.
All right. Well, that seems like something I can try and work out the specifics of the numbers.
Yeah.
And then I'll be back because it's frankly getting a bit late around here. So I thank you all for having me here, and I'll be back. Simply put, goodbye.
Bye.
Man, I sound so terrible. Anybody here? Mic check.
Yes. We've been listening to your conversation from the past.
Yeah, I heard it too, and I must correct myself. The machine was not perpendicular with the down vector. I was rushing, explaining, and the words weren't coming to my mouth. That machine was actually aligned with the down vector. It was vertical, aligned with it. So it was perpendicular with the floor. Yeah.
Sounds good.
Mm-hmm. So weird to hear yourself. I'm like, Oh my god, that's not my voice.
It is. I can recognize your voice for sure.
Maybe. I wonder if you could do that in real, because microphones change it a little bit.
Yeah.
Yeah, the physicist student dipped out. He never came back.
Maybe he didn't want to. He didn't want to deal with you.
Yeah. On a philosophical talk,
Okay.
he was pretty good. But when it was about empirical and engineering stuff that is real, he didn't like that. You're trying to measure like the first and second decimal of a millimeter using a measuring tool which has a precision of 6 zeros after the comma, after the dot. So of course you will be getting a very, very precise measurement.
Gabby Cat, did you ever come across that website again or find any info on it?
Well, I haven't searched it recently.
I searched it. I posted a link. I don't know if it's the exact same
Yeah,
thing though.
I know we spoke.
Oh yeah, gospel. You were talking about the other day, weren't you? Or yesterday or something? Yeah. Yeah.
Mhm.
Sorry.
No, I posted a PDF from one of the Airbus websites, and it looked like it was talking about their. It looked like it was demonstrating or showing their 3D printing stuff, and I don't know if it's the same thing though.
Yeah, it has to be something about it.
Be good to keep a copy of that. I was thinking.
Well, it's really technical.
Well, this information, I found it on the website of the company that was selling these linear encoders. I was searching for some to buy. I came across this website, but my phone navigation history settings wasn't set for a very long time. So after 2 weeks, I lost. You know, I couldn't see which website I visited past 2 weeks. And
I think mine goes back like 3 years.
yeah, but the name was someone posted the link with linear encoders manufacturer, something with letter R, Rex Roth, something like that, a brand name.
I think my memory goes back about 3 days.
Yeah.
I struggle with 3 hours.
To be honest, I didn't save it because Those were kind of expensive for my needs. And the precision grade kind of high. I don't intend to work in the nanometer size.
Memories.
In a straight line, not a curved line.
Mm-hmm.
Straight line. As in not curved. What's up, BMAC?
What's up, Gospel? Long time no hear.
Yep.
How you doing? Where you been?
I've always been around, but I've been spending more time hanging out here.
Well, I suppose I've been kind of scarce myself, so I haven't been on there too much.
Yeah, I noticed.
Yeah, by the way, Gospel Bearer, yesterday when we were talking about your concept experiment, I wasn't hand waving. I was actually telling you that I fully agree with it, but if it was possible to physically do it, because physics of materials actually doesn't allow us, Yeah.
Yeah, I have seemed to found evidence to the contrary.
Well,
if it's possible to have a cable, if it's
Mm.
possible to have a cable that's almost 2 miles long, then why
Yeah.
isn't it also possible to have a cable that's 3 miles long, 5 miles long?
Well, that's very likely like at the edge of, how much materials resist. And that's a steel cable,
Yeah.
Such a long steel cable will be having a very big weight. And that weight has to be proportionally with the cable thickness, diameter.
Yeah, if you find any equations, then like proportional equations or something like that, be really fantastic. Like this diameter has a maximum of, and this corded cable has a maximum of, or some type of like equation to figure that stuff out. That's basically what I was looking for.
About this, I want to tell you, yeah, I did this in school, high school. I was studying, I was making a mechanics high school profile. And we had a science called something like mechanical work of materials. And that's where we were learning how to calculate the resistance of steel to bending, to stretching, deforming, and their elasticity properties or plasticity, And yeah, in those formulas, you will find also this one, like, because you need the formula which is the type of steel.
I found a website
diameter,
that
diameter and how much it can hold.
Yeah. So the issue is, I don't know how much a given 100 feet of, let's say, the two row here. I'll post this thing. So, like, what seems to be kind of difficult to discover is how much weight. Let's
Can
say
you hang on the
1,000
thin
feet
wire?
of 1,000 feet of 2-inch rope diameter. How much weight does it have all by itself? So that chart breaks down that a 2-inch diameter rope would have 320,000 pounds of force minimum breaking strength. It says, but then the safe load is only 64,000 pounds of force, right? So how, if that's the limitations of a 2-inch diameter, then how much rope can you have before you get close to 64,000? Oh, there it is. I guess that's its weight. It says weight per pounds per foot.
Yeah.
600. Okay, so well, that's easy. Hold on. So it is very heavy, is what it looks like. It looks like it's extremely heavy. 64,000.
With that cable, with that almost 2 miles cable, they are very close to the edge of.
All right, so 9,000. Yeah, you're probably right. 9,523 feet would be 64,000 pounds.
Yeah.
So not quite 2 miles at the 2-inch diameter. Which, hold on, how it's not linear. For instance, the 1-inch diameter. Hold on, let me see how it compares to the 1-inch. So you could get 9,523 with the 2-inch. I'm gonna see how far you can get with the 1-inch. You've got 16,700 divided by 1.
You know, in these cases, you are about to calculate the wire resistance closer to the ends of where it's being hanging, and you have to calculate the distribution of weight throughout this cable, but it has bulge, like down bulge. It's hanging, you know. And yeah, there will be some sort of arc curvature kind of formulas, like distribution of force on a curved path, something like that. Because that cable, it's hanging, it's not really being stretched from one end to the other.
Gus was trying so hard to work it out, he's even muted himself just for concentration purposes.
Yeah.
Maths is hard, bro. Fuck maths.
And to be honest, yeah, I had to do this kind of calculus in high school and I was hating it. Even the teacher said that this is the most horrible use for the calculus of force. Like, the resistance of materials.
Well, I got this really handy chart, right? And what I'm noticing as I continue to do the calculations is the smaller the rope, the longer you're actually able to, like in regards to the safe load. So I did here. I'm about to post it. Let me do 1/4 inch and then I'll post it because it's kind of interesting. 1100 divided
The
by
thinner
yeah.
the rope, right?
But
Yeah.
there's a sweet spot because then it goes smaller again. So 10,000
Yeah.
feet with, so the 1/2 inch diameter seems to be the best of all of them. I'll post the numbers here.
For 1.8 miles, yes.
No, well, I'm just putting it in feet. So 9523 feet with 2 inch diameter, 9940 feet with 1 inch diameter, 10,190 feet with 1/2 inch diameter, and only 10,000 feet with 1/4 inch diameter. And that's based on the safe load amount, not its max load.
Yeah.
Right? Which means you could finesse it probably, but that you're risking.
Yeah.
You get one, like the difference between the minimum braking strength and the safe load is quite significant. So if you went with that 1/2 inch diameter, which seemed to have the best numbers, you could, let's say, 90% of the minimum braking strength. So if you went to 90% of that, 21,400 times 0.9 divided by, this is the 1/2 inch, 0.42. You could go 45,857 feet, which which means that 5 miles seems to be extremely plausible with this type of braided rope. Yeah, I know it's not rope. It's like it's a uncoated fiber core, improved plow still. But anyway, you could go 45,857 feet with the 1/2 inch. With 1/2 inch. Now, of course, I don't, by any stretch of the imagination, have the means to acquire probably even a few hundred feet of this rope or have a location to do such a thing in the first place. I was merely trying to establish plausibility of this thing. And
you need mountain climbing trucks, and
well, no, not if you're doing it across the 2 beach peninsulas.
Well, you need then a big ship to carry that cable.
Yes, you would need a bigger than a regular boat.
Yeah.
Unless you could get a truck on the beach and just drive it. If you could drive along the shore, like let's say a cove, you're going from one tip like of the sea to the other tip of the sea in a cove.
Yeah.
That's about 5 miles across or something like that. I mean, it's so 45,000 anyway. You know what I'm saying? Like all I was trying to do was establish plausibility, and with whatever this rope here is, this bright wire uncoated fiber core improved plow still braided rope seems plausible.
That wire still is gonna cost.
Yeah, that again,
it doesn't
you're focusing on these details that I don't care about. I only cared about the
if it's physically
plausibility.
possible. Yeah, if it's
Yes.
physically possible, yeah.
People blow stupid money on stuff all the time, so I'm not really concerned about, like, oh sure, if it costs like $1 billion, then yeah, it would be not plausible. That would be another way to say this is not plausible. If it cost $300,000, for instance, though, that would be plausible. If it was 300 million, I'd say no, that's probably not plausible. But I have a feeling that there's enough people that actually, like, let's say it was $300,000. I think that there's enough people that could make that happen where that would still be in the plausible arena. Which again, plausibility is all I cared about.
I just reminded something. You should be asking a architect or these guys who are building bridges and roads. The guys who design them, who make these projects, you should be asking them because these people, they know exactly, like,
did you see the
based on
chart I
the
posted?
type of steel. Oh, no, not yet.
I literally posted the chart that expressly details the exact numbers.
Oh, yeah.
For that specific rope, which may or may not even be the strongest rope available. It's just an example. And I think even with these details, as limited as they are, points towards plausibility, which was my only point. Driving me crazy, man. Driving me crazy. Just a question of
Well, this
plausibility.
is why, first time when I addressed this problem of yours, I mentioned, I don't know if you remember, but I told you about the cobalt wire.
Yeah.
Yeah, this is a very strong material, much more resistant than steel, any steel. It is a little bit more expensive and it's actually toxic. But it's not that you cannot handle it, Yeah. And a cobalt wire, you should be able to hang it between such long distances. But you will need to accurately calculate, like, the resistance according to the diameter. You have to have the right diameter.
Can I just ask, what is the interest in cables? Why are we talking cables?
Yeah, PMAX. So you know how they say that the Earth is curved, right?
Okay.
All right. So if you go on a beach at sea level and you were to put an anchor in the ground, a really, 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 really strong anchor, let's say 6 inches off of the, maybe even 4 inches off of the sea level, and you tie off a cable and you go to another shore about 5 miles away, for instance, just for example, it might be a different distance, but whatever, let's say it's 5 miles, and you tie off the cable across this 5 mile span. According to the globe, the rope should be going no higher than a certain distance below the water. If it were higher then it would falsify the curvature. If it were lower then it may or may not prove anything at all. But if the rope is at all higher than the expected point, because the curvature it's going through the curvature, allegedly.
Yeah.
If it would be any higher than that point, then it would disprove the curvature claim. You follow?
Yeah, gotcha.
Yep. So that's the point of the conversation. And all I wanted to do was establish if it was a plausible exercise. And
I just had an epiphany. I have to tell you this gospel. Like, seriously, this is very important.
the buoyancy of the water and how that would reduce the tensile strength.
No.
Because that would actually play a role.
When you have a wire hanging from two places, yeah. And on one end, you are able to pull this wire, so you stretch it straight between those two hanging points.
Straight-ish. It doesn't need to be a perfectly
Yeah,
straight line.
well, let me tell you, you see, all these cables, they break when they reach that point of straightness. That's when they break. They are not breaking when they have a bulge downwards, when they are hanging. So when you pull on the wire, yeah, it will come straight line between those 2 points. For a fraction of second, it will be visible, but then it will break after that. So yeah, it's.
You don't have to pull it.
It would be very interesting to see this, like
You don't have
a
to pull it
wire
tight, though.
being straight. Yeah, I know you don't have to, but
Oh, you're
in
saying
the
just to
case,
get it, if you pulled it really tight of the water, and then you'd be like, well,
in a
look at
straight
that.
line, you see it. Even if it's for a fraction of a
Yeah,
second, you
I get
can
what you're
see it.
saying. But that's a
Yeah.
completely different demonstration. My demonstration is merely one of measure. But you're right, that would work too, because in both instances, no one could ever claim that the cord or the cable or the rope or whatever, no one could claim that it was bending up up towards the sky. No one would ever claim that. That would be crazy. So
you could even then use like tree surgeons kind of slightly elasticated rope or anything. Then if you know it's going to fail, but if you had some kind of slow motion camera just filming it, you would be able to get a shot of that being perfectly straight before it fails. Am I right? Does that make sense?
Yeah.
Yeah, when you record it on video, I mean, that's something you can rewind and rewatch. Yeah.
So it's more of a possibility then, because the cost would be a lot cheaper than finding a steel cable or something.
Yeah.
I'm trying to get ballpark pricing for these different types of cords, but it's really hard to search for such a unusual material.
It just so happens they have an unused anchor and 5 miles of cable in my pickup truck. I'm going out right now.
Nice. PMAC to the rescue.
Another interesting thing will be fishing lines, but some like Kevlar or the strongest fishing
That's what I
line.
looked into first. Yeah.
But you have to remove the wax from them because vast majority of these lines they are coated with wax. It's not a hard process to remove the wax from them. It's quite easily to wash. But yeah, in that moment they will be very lightweight and very strong. Also,
strong like Ukrainian.
Ukrainian.
Can't we brag about a country like I don't know, Bulgaria or something?
Yeah, I think that's where the guy who invented the ballpoint pen came from. Was that Hungary? Okay.
Maybe. I've got some. Where are they? Not Bulgaria. I've got some friends that are running a like an orphanage in. It's not. Oh, Macedonia. That's where it is. Which is right next to. Well, apparently
Greece.
Macedonia is North Macedonia. I forgot about that. They changed, but it's next to Bulgaria. Yep, just north of Greece. But yeah, they have an interesting experience over there.
See, over here we have a little saying. When somebody says something, can you handle it? Yes, I'm strong like Russian. Have you heard that one? I'm strong like Russian.
I think I have heard something along those lines.
Yeah, well, I changed it to strong like Ukrainian.
Uh-huh. Yeah, I didn't know they had that reputation, but it's funny. I'm looking at this website.
Bulgaria, Hungary, Transylvania. It's not countries you hear about often, but.
Bruh.
Mornings, PMAC.
Hmm?
I've missed you in the mornings, early mornings. You're normally you and Helio and Flat Earth Dude are normally the morning comedy show for me. You haven't been on for a while. You haven't been on the show for a while.
Yeah, they didn't pay my fee last month, so I fucking boycotted them.
Man, this is a super long and technical document.
Uh-oh.
Well, if anybody's really trying to look into things, this one, this is like it's 157 pages. I was just looking for prices, but this that I just posted is extremely extensive on talking about basically, I don't know, maybe every rope ever, it looks like, and its strength and its limits and the different styles and designs and tie-offs and how that affects their strength, and just big wow. Big wow.
Yeah, the weaving pattern. Yeah, if it's twisted or.
Yeah. That all plays into its strength. So again, I think that this is really promising, and I can't help but think that these different ropes aren't like $1,000 a foot, or from what I can tell, they seem to be in the $2 to $4 range a foot, like worst case scenario. Even like the really, really fancy ropes, they don't appear to be outrageous. So like, let's say you're doing 30,000 feet and it's $4. Well, that's $120,000. I'm not doing that. I could never do that. But somebody, T Stew, or who, the different people that are like, I'll throw down 300K for X. Well, this would be a big one. But then again, most of the time, anyway, I think that there's people that would do it, and it appears to be plausible, which is nice.
What if we install, if we make like a bridge, but we actually make a pipe, supported by pylons, and to be certain that you install the pipe in a perfect straight line, you will look through the pipe. So if you see the other end, light at the end of the tunnel, then of course the pipe is straight. Yeah.
Refraction.
Inside the pipe. Seriously?
Yes. Refraction.
No.
I hear where you're going with that, and it
and actually, you can control the temperature inside the air of the pipe. That's very easy to control and to make it constant overall, its length.
Pipe in the world.
And you can actually make it like lower pressure, so vacuum it a little bit, so that will drastically reduce the refraction. It will be like refraction will be negligible, irrelevant, the amount of refraction that will be happening inside that pipe.
Yeah.
Yeah.
I'm wondering if there's any pre-existing straight pipes, like pipes in the Suez Canal or in the Panama Canal, or all that are already just there, ready to go.
Well, actually, at my workplace, we are making some very, very nice pipes with trapeze thread at both ends. But these are pins for oil drilling. And they are 3-4 meters long, That's like 6 to 8 feet.
Pipe like this one, for instance. Yeah, it's in Iceland.
Yeah.
But of course,
It's
that's
like
over
some water
land.
pipe. Well, yes, it's over land, but when you look from one end to the other through that pipe, you can see if the pipe is straight. Yeah.
Mhm. Yeah. And if it was straight, yeah.
Yeah,
I
if
got
it's straight, then all you have to do is walk along it and measure the distance from the pipe to the ground, and you will have the precise topography of the ground, like if it's a straight line,
yeah.
or hill, or
Trace on it then. You said it was in Iceland, didn't you?
Oh yeah, Drace, yeah. That just I was looking up canal pipes and different pipes, and that was like the straightest, nicest looking one I could find, and it just happened to be in Iceland.
Oh, Danny boy, the pipes are playing.
You got, man. That's something I admire about you and your culture, PMAC, is the music. It's like it really is a part of
Oh, it is.
your culture
It is.
better
the
than
Celtic
others.
blood.
Mm-hmm.
I share that Celtic blood with PMAC.
It's a good thing. I like it a lot. Ireland was one of the places that I had considered trying to defect to, or
defect.
Yeah.
Get out of that fucking communist United States, motherfucker.
The other place that I was interested in was the Shetland
Islands. Yeah.
Islands. Yeah. I don't know too much about it, and I'm sure it's not like paradise or anything, but it seemed like it would be a really cool place geographically.
Yeah, visually it'd be beautiful. The weather might be quite hard.
Oh, I love hard weather. As long as I have, reliable shelter. I love harsh weather.
Yeah, it's my favorite. I love it, man.
You visited?
Well, no, I mean harsh weather.
Oh yeah. Have you been to the Shetland Islands? You know much about it?
No.
Okay, gotcha.
But it is beautiful over here.
Or the Faroe Islands look pretty cool. Just like you're just floating out there, kind of all by yourself. Nobody bother you.
Wasn't there a whole expedition and went to fucking try and research the pyramids, and they had to get their money back because they went to the Faroe Islands?
I don't know. That sounds interesting though. Here, Faroe Islands.
Yeah, they couldn't read English properly, so they booked the whole tour to go look at the pyramids, but they went
Oh
to the Faroe
wow,
Islands.
wow. Yeah, I get it.
Yeah.
Yeah, I mean,
That's
if
hilarious.
this right here
I
is
got
a picture from the Faroe Islands. Look at that. I mean, come on.
look at the waterfall.
Yeah. Like that's fantastic. And this is a cityscape, I guess, in the Faroe Islands. Right here. And I'm like, yeah, I could totally get down with that. Good stuff.
Nice places to see on tour.
You don't think it'd make a good place called home?
Mm-hmm.
I mean, imagine living on that hill. just wow.
Imagine cliff diving off that.
Yeah, I'm not that kind of adventure seeker. I'm good for the views, but I don't actually want to bro, like this is mind-boggling right here.
You got all these lovely pictures straight to hand, like no bar at all. Just say, hey, here's another one, bruh. Yeah, I'm starting to think of gospel. You like your picturesque kind of places. Eh?
Yes. And I mean, I'm blessed. I have where I live right now is boring and super boring and ridiculous to
Man.
some people, but I think it's really beautiful. I'm in North Dakota and I like it. I don't have any complaints. However, I do think that if I lived in a place where I got to see this right here, wow.
Yeah, imagine. I love where I live too. The only problem is there's too many fucking people about.
Yeah, I mean, look at these Faroe. there's some rural areas here in the Faroe Islands apparently, but that also means, I mean, who am I? I'd be the outsider, and they'd be like, "Yeah, you're not welcome here, American."
We're going to stick you in a pot and eat you for dinner.
That's creepy. But yeah, just man, I'd never really looked at that many pictures of Faroe Islands, but here's my home. I found it. I found my future home in the Faroe Islands. It's right there. Boom.
Yow. Need some work?
Bro, I'd totally live there. Or in that antique RV sitting next to it.
Is
Oh my
that
gosh.
plastic on the windows? God. You'd have to import windows to the Faroe Islands. It cost you about $3,000 just to get a couple of windows.
True. Yeah.
Or you could go down to the beach and try and make yourself some window. Yeah.
But this right here is actually my ideal residence. That like that. I yield the floor to somebody else to pick up the conversation. I'll be gone for a little bit. I'll be back then.
Yeah, well, if you're looking for nice views, I could always post a picture of my face.
Alrighty.
See you in a bit. Where are the Faroe Islands? Again. Northwest of Scotland. Sheep mostly. Get fish. Maybe a couple of seagulls.
You got a couple of meals that were giant sandworm.
One or two. I actually watched that Children of June the other thing. I think it's on Netflix. It came up. It was alright, but I could understand why there was no second season. It was a little bit boring for most people. Angry sand noises.
So they talk about the spice melange in that. I love that word. Those words. Mining the spice melange.
Spice melange. He who rules the spice rules the world, or as South Americans like to say, he who rules the fucking cocaine rules the world, yeah? Angry sand noises. That's so funny, man.
Easily scared, but they come back in greater numbers.
Oh, hey, talking about science fiction novels, the Bene Gesserit and all that there. Anybody watched The Foundation? I was talking to Michael this about the other day.
Not yet. It's on the list. Any good?
Oh, man. Very, very good. Very good.
I might move it up the list then.
You would need to. It's kind of boring at the start, and that's a little bit tedious and all that there. But I mean, if you read the books and you understand the concept of the three, the day, the dawn, the twilight, whatever, the three generic people or boars, whatever, that rule the world, or sorry, the known universe, which doesn't actually exist. Yeah, that's pretty good.
I don't mind a slow start or a slow burn story. As long as
Yeah, it's growing on me because I did the whole research thing and I seen that they are doing a second series, but it's not like it's another year or something. But I'm actually going to go back and watch the whole first series again because, well, what it did was when I got to the end of it, the last two sort of episodes, I realized how good it was, and then yeah, your man who plays, I can't remember his name. He plays Legolas's dad in Lord of the Rings. He's very, very good actor.
I know, yeah.
You know what I'm on about, yeah?
Yeah, I know, yeah. Can't think of his name. But...
Yeah, he's very good.
Orlando Bloom. I'll find out. Wait. Yeah, that is his name, Orlando Bloom.
Oh no, that's Legolas. No, I meant Legolas's dad in Lord of the Rings. I'll find it.
Oh, Legolas's dad. Isn't he the Agent Smith in the Matrix? He is Agent Smith.
No. That's
Yeah, he is.
yeah. No, you're thinking about fuck, what do you call him? King of the fucking.
He is Agent Smith.
He's from the higher powers. Is he Legolas's dad?
Actually, no.
Thandrol.
Mr. Anderson.
I gotta rewatch Lord of the Rings. I have the actual DVDs somewhere in my attic.
You got the extra long versions, the 6 hour each ones.
Yeah, the special edition ones. Yeah.
Yeah.
The extended versions.
The extra extended version of the extra version. Extra extended. 6 hours.
Extra double triple.
Yeah, they can't put the director's cut. They didn't actually cut anything out. It's just all the footage just next to each other.
It's just a week. It's just a week of looking at fucking shit.
16 takes of each little scene.
16 takes, 45,000 cuts later.
Director Scott, why are you cutting anything?
It's Lee Pace, by the way. His name is Lee Pace. He does one of the emperors of the known universe in Foundation. Very good actor.
In your opinion?
Yes, in my humble opinion.
Humble opinion.
Humble.
Humble.
Humble. Mr. Jamesy, you're so humble. Humble.
Humilde. Humilde.
What does that mean?
En español, humble. Humilde.
Ah.
In Portuguese, humilde.
Humilde. Yeah.
Portuguese.
Okay.
Is there many differences between Portuguese and Spanish?
Yeah,
There's a lot of differences, but a lot of similarities.
The Spanish added D to everything.
It's a little different between we understand. Like banana, Spanish, in Portuguese, banana. It's like you see the sound is a little different. But the old Portuguese has a lot of Spanish how they speak today, So old Portuguese was a mix between what is Portuguese from today and the Spanish. There's a region, a country actually in Spain, inside Spain, Galicia, and they speak a mix of Portuguese and Spanish.
Yeah, it's like Belgium. They speak a mix of French and Dutch.
They in Belgium they have a Swiss region there, no? Or I think it's at Switzerland, yes.
It's like Ireland. They speak a mix of English and Mexican.
Ireland.
Arriba. Andale.
Just messing with you guys.
Arriba.
Ándale.
I make frontier with Spain. So in the years of my life, I watch a lot of Spanish TV series, and so I learned there how to speak, and I can read too, but to write not so much. But I understand everything that is written in Spanish. We are like brothers, Spain and Portugal.
Neighbors, brothers, family.
You're joined at the hip.
The hip? What is that?
The hip. What's that in Spanish? Hippa.
What is hippa? What is hippa, Jamsey?
You're joined at the hip.
I think
Siamese ones.
Joined by the hip. Yeah, unido por la cintura, like.
Yes.
Siameses, pegados.
Okay.
Oh, it makes sense.
Loud, yeah. There's a doctor that does a lot of operations worldwide with separating Siamese. So he has so many success by operating those people.
Oh, good for him.
Jamsey, sorry, Get. You were talking about pipelines. I was searching the world's most longest pipeline. It was in China. Like oops. Yeah, so like 8,000 or near to 9,000 kilometers.
What is that?
A pipeline, you know. Get Picket was talking about pipeline, you know. I
Like a
think they
straight
are.
pipeline?
Yeah. I think they are almost level. And we can do some experiment there. I don't know. Okay. World longest natural gas pipeline, West East Pipeline. Length 5,410 miles in China.
China.
China. In Portuguese, you say China.
China. Yeah, China.
We have a lot of China stores here. I think they don't pay taxes like 3 or more years when they start. But then they change the name, you know, and our location, and the same guys don't pay tax anytime. where is where we gonna get some cheap clothes and etc. and things from China.
So Portugal kind of incentivize people from China to bring businesses, and they basically give them like a tax exemption for 3 years. So they make a business for 3 years, and after the 3 years expires, they change the name and location, and they
Yeah,
keep evading the taxes.
exactly. They are smart.
That's what PMAC's been doing all his life.
Being smart.
Yeah.
True story, bro.
Have you ever said what your occupation is or was, PMAC?
Me, I'm a barman at the moment, gospel.
Oh, okay.
I've done all kinds of things. Yeah.
Cool.
Fireman, soldier,
Professional singer.
Professional player, game player, like how is the name? Pac-Man.
Yeah, I gave up the professional singer thing. I wasn't making much money out of that. Absolute shite.
I was a fireman voluntary a long time ago.
The bouncers just asked me to go up and sing at the karaoke so they could clear the bar.
Nice. It's closing time. We're not going anywhere. All right, PMAC on the mic.
Bar empty.
Nice. You gotta do what you gotta do.
Professional singer. I'd like to think I am. We have one version of what we are in our heads and the version everybody else sees.
Yeah, it's a weird thing. How our voice resonates in our own skull and stuff.
But I have noticed if you use your voice correctly, people pay attention.
Yes, sir.
Sound is it's a big thing, believe it or not.
I have to buy a better mic than this.
Hi, we can hear you just fine. What's up,
But the sound is not 100% like I talk. Sometimes I hear my sound at the background in some people.
Oh, the feedback.
Yeah, so the sound is not so perfect.
You need to get a Spanish mic, bro. Cheap Portuguese shit.
Oh, actually, this is Chrome with a K. It's not Portuguese, but by the way, in the Conan movies, I think their god was Kron. I don't know. I don't remember.
Okay, this is a bit weird. How did we get from talking about the shape of your mic to the Conan fucking movies, bro? Okay,
No, the name
I'll go
Kron.
with it. Kron, yeah.
Kron. Yeah, great movie. It was a great movie.
And why did that come up?
With the name Chrome.
Oh, okay.
In my microphone. In Spanish is microphone. I think no, microphone. In Portuguese, microphone is like the same, you know.
It's like this. It's almost like it's the same in fucking English.
Yeah, I think when the words finish, sometimes the sound is a little more, you know, in Portuguese, like you said, in more military. I don't know.
Got any popcorn?
Popcorn, pipoca in Portuguese. In Spanish is pipoca too, I think.
Popcorn en español, palomitas de maíz.
It's different.
I'm saying because Donald J. Trump sued Hillary Clinton and the Democratic National Committee and a bunch of other people.
Thank fuck, bro, and they deserve it. I mean, can you imagine having a president like fucking Joe Biden who lied us about everything? Yeah, I finished third in my class. I got 3 fucking degrees, and on the television they said, "No, you didn't. You finished like bottom. You were like third from the bottom. You've got 1 degree." And now and now he's president of the United States, and he likes to sniff people's hair. And then you've got Kamala Harris, who's laughing about everything. Saying, "Hey, Camilla, what's your name?" Ha 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 ha. Oh, Camilla, what's your name? Would you stop fucking laughing? Ha ha. No, she can't. I mean,
the creepy Biden that likes to smell hair.
Yeah, that's just a Suave and Pantene Provy psyop.
I saw some video.
I'm kidding, but shampoo. The shampoo companies got in cahoots, and they have this huge conspiracy with the president to promote their products. It was like all they need to do is show the meme of Biden sniffing these different girls' hairs and be like, Pantene Pro V, don't you want your hair to smell as good as this girl's? It's like, well,
Pantene,
yes and
creepy
no.
Biden. You
Don't you want Biden to smell your hair too?
Exactly.
Yes.
Sonny.
Please.
Sunny, sunshine, smell. By the way, Jamsi, are you join any server, Flat Earth server in Spanish? Do you know some server? I would like to
You know,
speak in.
that's a good question. I actually did search some Flat Earth in the past, but probably a year plus ago, Tierra Plana in Spanish, and I didn't find much. I did find like Landucci, Yuri Landucci, and he has a big following in Spanish.
I mean, I think we've considered having multiple languages on this server before. I don't see why not, especially just Livestream. Livestream 2 could always be used for that.
Yeah, last night, this guy, that's Portuguese guy, Illuminati, he then sent me DM a message about this, about that guy that eats raw meat. So it was weird. What's his name? Swish? I don't know how to spell it, but it's someone that at YouTube that does he talks about people eating raw meat.
I mean, when you say raw meat, yeah, raw meat of I've eaten raw meat, raw eggs,
Eggs,
bison,
yes.
beef.
I've only had ceviche and sushi.
Yeah,
Never had
Yeah.
it.
So, but
I've had raw. I think you're talking raw meat from animals, or because in the Spanish culture, it's like an alternate universe of conspiracies, and there's a lot of very dark stuff that is spoken about in the Spanish
Yeah.
communities. Very dark stuff. And when you say raw meat, when you say raw meat in Spanish, I'm thinking like people eating people.
Cannibals. Animal lecter. No, but
hey,
we eat cows, and so but we don't eat like raw, and people cook because to avoid diseases, because these cows can have the
foot and mouth.
Yeah, some bugs. They
Kuru's another one. Hey, bro, when the apocalypse comes, all I can say is stay out of my way. Who the fuck's this now?
It's Pac-Man to play. Calling to play.
I do eat raw eggs like almost every day. The meat, I cook it kind of like medium rare most of the time, but I've had it raw too. But it has to be like a really good one, not just any meat. Did I lose you guys?
You lost everybody talking about all this meat stuff.
Good.
No, I was looking for other stuff. But by the way, I found some years ago, we should eat more according to our blood type, because there are people that are more available. I don't know if that's the correct word to speak, but to eat more of something, some food than other food.
Hey, Miguel, are you in Portugal?
Yes.
Oh, okay. Very nice. Very nice. I've seen very cool things about Portugal. People buying houses. Well, also in Italy too, but people buying houses there and property in Portugal, like houses that are old houses, 500-year-old houses, whole towns that are abandoned that they want people to go in and build. Is that true in Portugal also?
I don't know a lot about that, but I think some people, some people from UK, for example, they like to come here for the retirement. After retirement, they like to. There are a lot of people that like to come here and to go to the rural places. There's some places. They are abandoned because the last people there were old people, so and the younger guys like to go to big cities, so
Right. So they have a lot of towns that are just empty, huh?
yeah, some
Wow.
in the inner country.
Yeah.
Rural.
Well, obrigado.
Thanks, man. Obrigado.
Obrigado.
Nice try, Sonny.
I know. That's
You know,
the only Portuguese I know. It's obrigado.
I can teach you another one, like friend, amigo, friend.
Sounds like
amigo.
It sounds like amigo. So
amigo, yes, exactly
amigo.
that.
Okay.
Amigo. In
Got
Spanish
it.
is amigo too.
How do you say fuck off in Portuguese?
Fuck off.
Assim,
We don't say that. We don't speak like that.
Yeah, we are
Nice.
cool guys.
Culture.
No, but we
nice
say
people.
yes. We say a lot. Vai-te foder. Gonna fuck yourself like that.
Oh, hey, that sounds good. How do you say that? Say that again.
You say vete a la mierda.
Yes, yes, in Portuguese is vai à merda.
Shit the merda.
Shit is merda. It's like in France, the French guys they say merde.
Mm-hmm.
Shit.
Merda.
Yeah, and I got that. Not crazy. Like French is merda, and you say merda. I think, well, that's shit.
French, Spanish, Italian,
German.
Yeah. No.
Not the Germans. No, not the Germans.
When you say fuck off, you can say vete al carajo. Carajo is like a really, really far place, so you're sending the person far off. So fuck off.
Like into space.
No. Yeah, I know what that word is because 500 years ago, they in the ships when they navigate, they use when someone behaves badly, they send that guy to the top of the ship. How you call it? That
crow
place.
Nest. The crow nest.
The place where you can see far away in the top of the ship.
Yeah. The
So that basket, the name was caralho. So it's like so if when someone does something bad, behaves badly, they said at that time, vai ao caralho, vai para o caralho, vai lá para cima, go to up there.
In English, we have so many swear words. Like
it's like a punishment, They send that guy to
Crow's nest, bro.
Take
that
carajo.
place. To that
Voy
place,
carajo. They say voy carajo. Voy.
Jamesy. No. In Portuguese we say vai para caralho. It is go to the like it's vete al carajo, like in Spanish.
Like the Spanish say like puta madre.
A puta madre.
Is that bad?
Puta madre. Filho, aqui em Portugal is filho da mãe, son of the mother.
That's
but
like saying your mother is a whore.
Yeah, but in Portuguese is we say filho da puta, son of a bitch. Yeah,
cabrón.
Cabrón in Portuguese.
Meanwhile, back at the flat Earth.
Oh yes, better.
Yeah, let's bring it back.
Let's swear words
from the swear word.
I blame PMAC.
I blame myself.
Fuck, man.
How's everybody doing this morning? Evening.
Well,
on the green. We're doing on the green.
Well, I'm not in the green yet. I'm waiting for the green.
In the plane of the existence.
You're talking about the markets.
Yeah.
Are you guys are talking finance? Because we're all going to fall asleep here.
Oh, space is profit, you know. There's a lot of money there. You want to go to Mars? Elon Musk. You know, NASA gives him the money, and now he developed another suit.
So, anybody come in here with interesting topics about the shape of the Earth?
Not yet.
Not today.
Yes. Not yet. Not yet.
Not you punched in.
We're getting there.
What's that?
Not since you punched in today.
Yeah. Although Getting and myself, we had a follow-up conversation, and I found some resources that pointed to confirmed plausibility of the cord/rope demonstration thing.
Okay.
So it's a promising opportunity for anybody that wants to pursue it.
2 years from now, Gospel will be living on the Faroe Islands.
Yeah, we also talked about places I wish would be cool to live, but the Faroe Islands being one of them.
And Miguel was asking about a straight pipe, and I think Miguel brought up that there is a pipe that goes really far away in China.
Yeah, he was talking about like, why don't we just find a mile long pipe or a 5 mile long pipe and look through it, and if you can see to the other end, that's another.
Do you think you'd be able to see to the other end? Who here thinks that would be possible?
If you shined a light.
Yeah.
And if it was a straight line?
No, it's not possible.
Yeah, I was gonna say, who here thinks that would be possible?
The light won't make it all the way.
I think it'd be possible.
No, it'll bounce.
I can see city lights. I can see city lights from 20 miles away.
Yeah, that's not inside a pipe, though.
You think all the pipe would be absorbing the light, basically?
Yeah, what it does is it bounces off the walls of the pipe. It diffuses the light faster.
Okay. Well, what about if the material was metallic? Same thing?
Anything that's shiny is going to reflect it. So, I don't know. If you have a flat black inside, possibly. I don't know. It's a good question. But see, even a straight pipe that long is not that straight. It depends on what diameter inside the pipe is, because let's say if you have a 6-inch diameter pipe on the inside there.
Yeah, but the
All you got to have is a couple inches of deviation this direction, then this direction, then this direction. Your hole is completely blocked off now.
Yeah, I know.
Yeah, but what was proposed was that there was going to be two tubes that hold it up on the side, and a pipe that's a 1 mile pipe with only two things that prop it up. There's nothing going to be in the middle to support the middle of that pipe. That's what was being talked about. Yeah, if I'm not mistaken, gospel, you probably it's not having supports in the middle all the way down. It's just two whatever pillars that are going to hold it up, or I don't know how you're going to do this thing, but a mile long pipe with only, and I don't know how that's even.
No. He was talking about it being supported.
Oh, well, that's different. Okay.
Yeah.
Yeah, because the whole part about it was 2 points that you have with the, just that's all you're using. It's just 2 points.
Yeah,
And
that's implausible, though.
Well,
yeah, because actually pipe that long is not straight. It's not.
We're talking about supported. It's it's the whole straight line thing, which everybody's like, "Oh, you can't make a straight line." It's like, okay, never mind then. Can't make straight lines now.
Now, if it's supported, yeah, that's,
Yeah, I think it'd be another interesting way to go about it, but anyway, the fact is, the chord thing, there is plausibility there. So,
Biggie, where are you gonna come in here and be all fucking sensible and shit?
Yeah, I know.
God damn it, bro.
Well, you got to challenge, man. You got to challenge the minds. You can't just, we got to have some food. Can't keep snacking on Cheetos, P-Mac.
You can't?
No, not good for you. But it's good, though. If you're taking it to the next step, and like I was thinking, small scale, right? Whatever you think you can actually do on a smaller scale.
5 miles would be probably the minimum in order to have a sufficient enough sagitta so that it would be discernible. Because if you're only doing 1 mile, your sagitta isn't going to be big enough for that to be. It would be too difficult. But if you have 5 miles or greater, then you're good to go. And there are chords that are strong enough for 5 miles. 45,000 feet is the amount that I found for one of them, but apparently, different materials, different stranding methods, like it's plausible.
So also, look, what you could do, gospel, is you could use the cord like this. You're not going to be able to suspend it, but you could float it on the water and use buoys at certain distances away. Now, these little buoys or floats could have lights on them. They also could have radio beacons.
So, Sonny, that would invalidate my whole thing about it curving upwards, because they would say that the buoys are helping it be curved upwards.
Well, the ones in the middle, if there's a bulge, the ones in the middle would go up higher. This would be easy to measure. You could see if the ones are going up higher or not. You could just take a mean average of the heights, the highest point where these things float up from the waves. You just find you could do that.
I hear what you're saying. The way that I had it described is actually plausible and sufficient for proof. I can't do it. I don't have the means to accomplish it. I was only looking for establishing the plausibility of such a thing, and I think that I've done that. So there are chords that are capable of being strong enough, and anyway, it's a plausible thing. It's not an experiment, but It's a demonstration that would be, or a measurement that would be plausible, accomplishable.
And what was your end result? Like once you've completed everything and it worked or it didn't work, what was it going to provide substantial evidence for?
100% incapability of. You cannot use the word refraction, for instance. So they'd have to make up a new excuse. But for those of the people that are still stuck because they think that this word refraction being invoked has some semblance of validity or actual, substance of refutability or whatever, it would help those people that are like, I don't know. They might have a point with this refraction thing. For any of those people, they would be like, oh, well, now it doesn't even matter if they say refraction. Now we have this, and this is physically impossible, and observation is mutually exclusive because it's exclusively measurement, free from any possible misattribution regarding observation. You can't blame anything because it's all 100% physical.
Yeah, you can go out and do it yourself.
Well, not quite. That's the only issue. Because it would be tens of thousands of dollars, I imagine, to buy 30,000 feet of some type of cable. That alone is expensive. That's going to be, tens of thousands of dollars, I imagine.
Well, if it's something that you've done, you would have it in whatever constructed form you had it in, and let somebody else come in and kind of go over what you did. Because then, if you spent that amount of money, you're not just going to build it and destroy it. You're going to actually leave it there so people can look at stuff and kind of go over what you've done to verify, even if they couldn't afford to do it.
Yeah,
but it's not,
Hold on, Miggy, did you just say you wouldn't just build something and then destroy it?
Oh no!
You'd never get a job at a space agency.
It's a painful process to build it back again. That's what Gospel Bearer would probably say.
Yeah.
We can't do it. This is a painful process.
Of course, you do everything.
Even though throughout the history of man, that's all we ever did, right? Build and destroy, build and destroy, build and destroy. That's all we've been doing.
Yeah. I don't know if you guys know, little known fact about London, we literally knock the whole thing down and start again every year.
Oh, every year, huh?
Yeah, because, we need to prove that we can build it back again, right?
That's
they do
quite
here.
the flex.
Build back better.
They knock down perfectly good buildings and build buildings right in their place that look almost just like the previous building.
They even age them to make them look authentic.
They age them. The aging process is it's a bit difficult, right? Can be done, but
I know for a fact that I've had this conversation when India was president. I see you're in the VC again, India. But
hey, India.
It won't work because it's something called a catenary curve. All chains will hang a little bit no matter what. You can't get them completely straight no matter how much you pull on them.
It doesn't need to be straight though. That's the thing. It only needs to be like an inch above the sagitta.
Yeah, you won't ever get it with cord. There's no way possible. Anyway,
yeah, I keep hearing about that.
Not possible. It doesn't matter what kind of cord you have. You could have iron. You could have a solid iron bar. It still won't. It'll still sag.
So it's okay if it sags. It
Okay.
only needs to be a fraction of a fraction above the sagitta to be a valid thing.
So I don't know why you don't just use the water then, because you could take a cord that floats, stretch it across the top of the water, then you just have a viewpoint, and you just look. You can you can tell when if the center of the part of the rope is going up higher than any other parts. You could do like this. If he had still water, be better, like across a still lake or something like that. But like I said, you could use boats, you could use buoys. I don't know.
Only thing with that is that if you did what you're saying, Sonny, to be the slight undulation, and that would give them a cause for like, yeah, that's what would be expected to be there, because
Yeah.
they count that as curvature when it would reach the top of the, the top of the trough of the wave or whatever. Like it would be.
I'm trying to think of a way. Could you think of any way, Indio, that could be done physically? I'm not so sure.
You can always rely on flat Earth to shit in your experiment.
Well, see, the thing that I think about, since I live around water all around me, I go down to the harbor, I see water lines painted on these ships going all the way along the far shore, all the way out to the harbor. I can still see their water lines.
Yeah, because the thing about the constructing something like this is you hear all the weasel rebuttals in your head, because you've been down the path of like having conversations with these guys, and they're not really constructive like arguments. They're just weasel arguments. It's ridiculous.
So the catenary curve, okay, I get it, but as long as the midpoint is above the expected sagitta point, it doesn't matter.
Yeah, but
I just drew a little kindergarten picture. I know it's just a picture. I guess the claim, I guess he left. I guess the claim is that the catenary curve, no matter what, will be below the sagitta, and I need more evidence that would be the case. And I provided plausibility regarding the length that cord could be, right? And furthermore, the buoyancy of the cord within the water would reduce its overall tensile stress. So that would increase your ability. And I only went to the 90% mark in order to prove my point, the 90% mark of the minimum break point. So if you're at 90% of minimum break, then you're not breaking because you're not even to the minimum break point. So 45,000 feet, like I showed in the math above, was plausible with that cord, and that cord isn't even known to be the strongest cord. I'm only trying to present plausibility.
Yes,
and everybody's like, no.
Hold on, Gospel. You have a point, though, because I just thought about this when I looked at your drawing. If you're above the water, you could actually use the sag to measure the sag to do exactly what you're talking about.
My point,
if you have it swung like that, where it's bowed down to the water, then you do have a point there, because all you have to do is measure the straight line between the two people or the two structures holding the cord up at either end, sagging down to the water. That should be a certain distance from the center.
No. It's not about that. Okay, you go to the midpoint. You go to the middle point. Okay, between the 2 points.
That's what I'm talking
about. And you measure the distance from the surface of the water to the sag, right? And as long as that sag, the catenary curve, right? As long as that midpoint of the curve is higher than what the sagitta expected point would be, nothing else matters.
You got a point.
It only needs to be slightly higher in order for this to be a slam dunk.
I think that's pretty good, actually, because you just use the sag. Now, the problem might occur that you'd have to be higher and higher at either end to even get it off the water. You know what I mean? So, but
no, I'm thinking like 6 inches, and right at the water line.
Depends on how long. You'll never have no. You'll never get a cord that has 6 inches only of sag.
No, I'm talking. No.
No, I'm
I'm talking about 6 inches off of sea level or water level or
Yeah, I'm
whatever.
talking about where you're holding either end of the cord.
Hmm.
Yeah, you might have to be so high up that you would have a U-shaped cord.
No. Yeah. No.
Yeah,
No.
yeah. I
No.
work with ropes and cords a lot. Like, yeah, I know how cord acts, how ropes act, how they behave when
So,
you.
hey, have you ever seen that video?
I'm just going by
I
my
have not.
experience,
So,
gospel.
Anti-Gatherian Level, he used to be a mod on the old Discord for incident. Yeah, kind of abused his mod power, bot power.
Uh-huh.
Didn't want to be admin, but wanted to do admin things. Anyway, so he came up with this idea where you build a structure that curves at 8 inches per mile squared. That's 6 feet long, basically a big bathtub, right? That's curved in the center. So you're building a structure to this specification that has a curvature of 8 inches per mile squared, and then you fill it up with water. And the globe says that the water, when you fill it up with 72 inches of water, it should be level all the way across it, right? That volume of water. And if it's not, right, then it's flat. I mean, it explains it better in the video than I just explained it, but this would actually work. Problem is, it would be pretty expensive to build 6 mile long bathtub. So you probably have to build it out of wood or something. But you could actually make it into a tourist attraction, fund it.
Yeah.
Of a 6 mile long flat earth proof. Pretty awesome.
I think most of us here have already come to the conclusion that the Earth is not a globe. In order to do that and bring us back to the globe, you'd need to pull my brain out, flatten it, jump on it a couple of times, put it back in my head, and then.
That sounds like a good Saturday night, PMAC.
Yeah, but we're not trying to convince the people here. We're trying to show the people that, can't stop believing everything that comes over the idiot box. But hey, nobody. There's not a first man in space anymore.
What?
No one's been to space. They took that away from the Russians because they're bad now. So Yuri Gagarin is no space. You think I'm joking? This is like real shit.
Yeah, link please. Link please so I can laugh.
They just said, nope, you're Russian. You're not the first person in space anymore. We're taking that away from you.
Wow.
It was a
So if there isn't a first person, there can't be people after the first person, so no one's been to space.
Yeah.
Now they're admitting it in a way.
Yeah, it's like William the Conqueror. They changed all of British history after that. Yeah, you can't have anything before if you were the only one.
Man, listen, who's blowing onto their mic? Would you get out of the wind, bro?
He lives in the wind. Oh, wait a minute. Is it Miggy this time?
The answer, my friend.
Really doesn't.
No, it's me.
It's
I'm in a place called Cambridge Square, and usually this place is full of broken umbrellas. That's how windy it is here.
It's full of wind.
Umbrellas that are turned inside out because the wind broke them.
Yeah, that's fun to watch. I like watching it from my window.
There's like a pile right up against the building over here.
That's what I was going to ask. If all the umbrellas, if people just leave their shit right where it breaks. Oh, I'm just leaving it here now. It broke.
Well, it's like right when you come out of the train station on one side. It's like a wind tunnel. So right as you step out, people open up their umbrella, and as soon as they do, snap in half and ends up in a pile. You just sit here and watch it all day, cracking up. It's hilarious. I've literally come out of it, like, this is a couple years ago, but 5 or 6 umbrellas like blown around, like in the street, like.
What a scam that umbrella thing is, man. Gee whiz. Be perfect if you live in a perfectly static area where the wind doesn't move at all. Great idea. Why don't they just make them so strong that when the wind blows the other way, you could just help it propel you along the street? Shh.
Mary Poppins or what?
Maybe sliding on their shoes with the umbrella. Can you imagine? Like you'd be like water skiing in the city. Don't mind,
Skateboarding with an umbrella.
don't mind me. Yeah. You guys are the ones that give me all these ideas, so
You took that idea and you ran with it, didn't you?
it's your fault. I know. I think that's the way I was when I was a kid too. I would hear something, I would start adding to the story, and pretty soon they were like, "Okay, go on along there, Sonny, with your little stories."
Speaking of umbrella, I just drew one to beat a dead horse on the point I'm making. All right. So 2 points, alleged curvature. All right. Alleged curvature. If the line was perfectly straight, it would be the best case scenario. We know that it cannot be perfectly straight. It must be curved. Therefore, it has to be below that point if the Earth is curved. Okay. But because we know that it isn't, if we were to demonstrate the fact that the curve was above that line, even a little tiny bit, and the fact that it was curving downwards would further exacerbate and demonstrate the extreme nature of it not being curved, it would be profound, ridiculously impossible to refute or even dispute without brain damage evidence that it was flat and not curved.
And so, Gospel, there's probably info out there on cordage and how much it sags.
I posted all of it.
Oh, you
I
did?
already have all the charts, 157-page PDF that goes through every detail of the tensile strength and the max load and all of that. I posted the information. My whole point is to point out the plausibility of this thing.
Mm.
And it doesn't matter if the bottom of the U-shaped catenary curve was sitting right at the sagittal point, or even a little bit below it, it wouldn't even matter. It would still be proof because the line isn't straight.
Right. It would have to be pushing, the sagitta would push that chord way, way up from where it actually is. I got you. I get your point. Mm-hmm. Yep.
Which means more than likely there are already existing examples of this. Underwater cables that span a certain distance, there's probably already existent examples of this thing that would be immediate proof.
There's probably, yeah. Well, that's like you have the tensile strength and all of that, and the load and those kind of things. What I'm talking about is the actual sag rate. There's probably measurements for that.
I posted that too.
I didn't see that part.
It's a catenary curve calculator. The equations for catenary.
Okay, forgive me. I didn't see.
That's okay. I mean, I've been thinking about this for almost 3 years now.
Wow, dude.
And I got poo-pooed then, and I'm getting poo-pooed still, and I'm going to keep beating the dead horse, and then maybe somebody with the means to do something about the whole thing could actually do something about it. But I'm not that guy. I just have thoughts and ideas. And I'm good with logic.
Yes, you are. There was someone else mentioning there's these things that have that can have a height indicators on buoys across water as well. See, that's the thing. You have technology already. Once this buoy got to a certain height, it sends out a signal or a light and a signal, and you just measure, see how high they're all going. That's it. Pretty simple.
Underwater water pipe. It doesn't look like, I don't know how many miles that is. Doesn't look super long. Well, kind of long. 468 meters. Yeah, it's not.
I would start testing smaller lengths of cord in preliminarily to doing this. Just start doing those tests first. See how far it sags. That's going to be a big deal because for you to be able to pull it, what's going to happen is to decrease the sag to a certain point, you're going to reach the breaking point of the cord to pull it that tight. So feasibly, what I was trying to say is at either end, you could be up 100 feet each side, but the sag could be going down to 200 feet.
Yep.
See, this is the problem.
No, not really. Do you think that the water would increase the or decrease the overall tension of the cord?
If part of it's floating, is that what you're trying to say?
If part of it is in the water, do you think that the water would cause like more buoyancy or less buoyancy for the cord?
Oh, more buoyancy.
I agree. That only helps.
We know this because, see, I'm basing everything I'm telling you based on like anchor road and just knowing what I know about ropes when you're throwing a rope over a distance, how much it actually really does sag is a lot more than you would think. I've worked with these kind of things, rope and rigging and things like that. But anchor road going underwater, you have to calculate a little bit for that, how much road you put out, so you know how much.
What in the tarnation? But this is all floating, right, Miguel?
Tarnation.
What tarnations?
Goddamn tarnation.
I mean, 27,000 kilometers or whatever. That's really, really, really. Is that what it said? 27,000?
Yes.
27,000 kilometers?
What?
Yeah.
What's that figure?
But it's all floating.
But I think they sink. I don't know. I just found just now.
This pipe that's to 27,000 kilometers. Supposedly. I mean, that's what it says at the beginning. I don't understand.
That seems way too far. What the hell?
What in tarnation?
How could it be 27,000 kilometers?
The world's longest triple LD pipe tow. I don't know what that means.
So we're talking like that's a little less than 20,000 miles. Are you kidding me? No way. There's no structure that long on Earth.
Yeah, maybe they meant to say 27,000 meters and they put a K in there accidentally.
Probably.
27,000, but that'd still be what, 277 kilometers?
That's pretty far still, like 200 miles.
Yeah, if it was 200 miles long, I mean,
Railroad tracks longer than that. Going across the country. Flat datums. Isn't that interesting? They pretty much engineer railroads just like they do canals.
So, just for example's sake, looking at this catenary curve website, if you look at those curves, is somebody suggesting that if you go from the blue one to the red one, that you're increasing the tensile stress to a degree that it would break by the time you got to the green one?
Yeah.
And that's the suggestion?
My suggestion is, in order for you to be able to pull it tight enough over such a long distance, you would get higher than the tensile strength. It would break.
But look at what evidence is there that curving from the blue to the red to the green is increasing the tensile stress to a degree that it would start to break at the green curve line?
Because the weight.
Again, I already provided the numbers.
Okay.
I don't understand.
I know.
I hear the weight word, but again, we're talking about it being in water, which decreases or increases the buoyancy, therefore reduces the tensile stress. I don't understand. Maybe I'm just not smart enough.
From the part that's above, from the part that's in the water, that's reducing the load on the tensile strength. Let's say you could still have the part that's above water could still reach tensile strength the breaking point.
Evidence? Is there evidence for this claim?
Even more, because when you put rope in water, it increases its weight exponentially.
No,
but the load. Listen, the load. The part of the cord that's going to bear the most load is going to be the ends.
Yes. Yeah, I agree with that. That makes sense. But again, having it in water would reduce that load.
No, it'll increase it actually.
Yeah.
I asked. Okay, listen. If it's in air,
depends on whether the cord is hydrophilic or hydrophobic. Because if it repels water, then it'll just float.
Yeah, that's true.
Regular rope absorbs water, so if you stick that in water, of course.
Yeah, and I'm not talking about like horsehair rope. I'm talking about different types of metals and stuff. But it was my understanding that anything, if you increase the density of the medium, by default, you're more buoyant 100% of the time. I thought if 100% of the time, if you increase the density of the medium, that you're going to be more buoyant regardless compared to the air, right? Air compared to water, increasing the density of the medium increases buoyancy, therefore would reduce the load slightly.
Yeah, you're going to have to start doing actual tests to find out where it breaks and what happens, whether it's like there's polypropylene rope cord but
I know. I posted a 157-page document that shows load strength and stuff.
I was just looking at it. I know. Yeah.
And it's based on air, right? Not in water. So the water would only help the situation. So I was basing it exclusively on the
that's
air.
where you're going to get the truth.
What?
Oh, what I was saying was the best. Like, you should just ask the manufacturer of the cord. Hey, if I pull a cord this long, how much is it going to sag? They know how to do that calculation. I guarantee it. They'll know exactly what the value is. They probably already have a program that does it.
That's what I was saying. Yeah.
You got my point about as long as even if it was at the sagitta point or the bottom of the sagitta, the sagitta is the top, but the bottom of the sagitta, even if it were right there, that would still be a massive win.
Yeah, well, until you test it, you're not going to know. You might end up having to have a skyscraper.
Am I the only one with visual spatial reasoning?
No, I don't think so. I mean, I understand what you're saying.
Yeah, the difference between flat and curved would be enormous. Like what you would like your expected value. Of course, it would be enormous. But if like, so this is my problem. It's not as does not actually have the tensile strength they say. It sags more than you think it does in reality. But the calculation says it should sag this much, and then it's sagged way too low. And then they're like, "Oh, yeah, well, you just proved it's a globe because it's 40 feet under the water instead of 2."
No, but it wouldn't be in okay.
See what I'm saying? If the spec on the cord is wrong, or if it's not manufactured correctly, a result could be misconstrued. And we just took a step backwards.
Try to stretch a rope across.
You got to think of you got to. It's a comparison. It's a comparison between two predictions, right?
Yes.
What is flat predict versus what does a globe predict? One predicts a more extreme, like if you stretch it across water. If it's a globe, it's going to be further under the water than if it's flat, right?
Yeah.
But it's but that how much it's supposed to go under the water is going to be based upon tensile strength of the rope, the length of the rope, the weight of the rope, whatever it is, cord, rope, nylon, fucking carbon nanotube, doesn't matter what it is.
Buoyancy of the rope, how much water it takes on. Yeah, all of that.
Yeah, carbon nanotube. That's what I'm talking about.
Yeah, we'll make a freaking 6 mile long single wall carbon nanotube, then we can do it no problem. As soon as you figure out how to manufacture it. And then in that case, you're not going to even care because you'll be a multi-billionaire.
But here's the thing: if you could, so let's say it's 5 miles. At the 500-foot mark, at the 1,000-foot mark, at the so on and so on, increments of 500, you could measure the depth, and you could chart out its curve, right? The downward, the catenary curve, and you could definitively illustrate how if the surface across the 5 mile, for instance, was curved, I don't know. I still feel like
you're on to something there. There'd be a difference in the shape of the curve because they think that the surface of water is curved. So the value, right? The value, like that difference between the surface of the water, that distance would have those two curves would have different shapes.
That's true.
Correct.
One would be like
really the
very
point
shallow parabola, and whereas the other one would be like a very large parabola.
Mm-hmm.
Depending on the length, and that's
wouldn't even
really
be a parabola. It would actually look like what do you call it? It would almost look like I don't even know what shape that would be. An egg, almost pointed egg.
Yeah, and one of the pictures I posted in the chat, the 3 different curves, I'll repost it. The globe would be like the blue one, and the flat Earth would be the green one. Just metaphorically, I'm not saying that is the math, but just for example's sake, that's what I'm saying. The difference would be across the measure, and again. The big document that I posted, it's engineering toolbox hold on. Is this the right one? No, that's not the right one. There's a document. 150. Here it is. Here's the document. It's 157 pages long, and it goes through alloy chain, wire ropes, wire mesh, nylon, special chain, polyester, like all these different types of wire materials, braiding styles, assembly, arrangement of different sizes in the same there's a lot of data out there that would help you, at least point you in the right direction. But anyway, I don't know. I think it's plausible, and all I've been told is it's not plausible.
Well, how about we build an inverted structure, 8 inches per mile squared going the other way, right? Concave. That's how you build it. And then if that's a level, then it should be a perfectly straight line. Right? If it's a globe and you leveled it, it's curved, that would be a straight line if you invert the curve.
Yeah, that's true.
Then you stick a ball on it, and if it rolls, and if it doesn't roll, and it's a flat earth, and if it does roll, and it's a ball.
I see what you're saying. Building a 6 or 5 mile long curved surface and flipping it upside down so that it's a dome.
Yes.
Yeah, that's an interesting
because
idea.
they say the Earth is so big, but so-called gravity will tell the tale when you stick a ball on it.
That's a good one.
Yeah.
It should do it when you build it concave too, right? I mean,
go to the center. Yeah.
It should make it straight. It should sit straight. I'm not sure I understand that. Could be me.
So don't you think the military just has like a laser that shoots insanely far?
Well,
yeah. It's called LIGO, and it's in a vacuum chamber, and they can compensate for any curvature.
I think they have like some type of weaponry, though, right? That we don't know about. I mean, that's not even like some conspiracy theory. Like, we never know the intricacies of the top tier of the current military technology. That's counterproductive, right? I mean, So anyway, I'm just saying, in my mind, immediately when I think about physically testing the Earth, I'm like, dude, you just shoot a super strong, badass laser really far. That's how you would know. I'm just saying, I think the military can already do that.
This claims to be 2,000 trillion, so I guess 2 quadrillion watts. The article I just posted. Allegedly, they have a 2 quadrillion watt laser.
Well, like if you had a powerful enough laser to shoot, like, hundreds of miles,
wouldn't you be converting the everywhere that it shoots?
Something like supposedly that powerful sounds insane to me. I'd have to look on this, but it would be a super dangerous weapon, right? Like if you turned it on, anything in its path would just be a goner.
Yeah.
But so they would obviously get altitude. Military technology would get altitude, but it would obviously know the horizontal underneath it is how they're going to achieve target acquirement. Because even over horizontal, of course, you'd increase altitude, but I don't know. I just think that you could shoot a really powerful laser that they already have in existence. Because does that sound crazy? I mean, because the weapons that they make, even the weapons they claim they make, like nuclear weapons, are so incredibly irresponsible to produce.
Where would you shoot it from, and where would you point it at?
Yeah, that's what I'm saying. Okay, that's one good
Antarctica? The tip of South America to Antarctica? He shot a hole through the ice wall.
Yeah, it's crazy. I don't know.
You wrote about it, I think. 2 quadrillion watts.
Well, dude, they're using these off-the-shelf drones to do targeting. They're not accounting for any refraction. These are just off-the-shelf drones that they're buying, they're retail drones. Yeah, that's true. And they're using them to target. They're using them to target armored personnel carriers. They're illuminating them with the infrared, and then they're shooting them from an airplane. They're not compensating for any refraction. Okay.
Yeah, of course not.
So they're claiming that they did this thing, this 2 quadrillion watt pulse of a laser, but it only lasted
somewhere else. But somehow
one picosecond.
Picosecond. And that's like a billionth of a second or something.
1 trillionth of a second, yeah.
I just got dumber hearing that. I mean, yeah, I mean,
We are
cool
all
story.
dumber
Yeah.
now.
Now, they also claim that in 2013 they shot a 50 kilowatt laser, or 50,000 watts, which is much tinier than 2 quadrillion watts. 50,000 watt laser shot down a drone from 2 kilometers away. So
there you go.
It sounds to me like even if you had a
2 miles?
50,000,
Ouch. That would hurt if somebody could get you from 2 miles away.
2 kilometers, but
Zapping you. Well, yeah. Or what is that, like 3 miles?
1.6 miles.
1.5 miles.
Yeah.
Oh, 1.6. Oh, yeah, that's right. I guess that would be the same. Yeah.
So, I don't know if that is right. I don't actually. But anyway, so I'm just saying, don't you think that if you just lowered the altitude of the laser and shot it horizontal, that it would just end the discussion? There would nothing left to be said.
it's still light as opposed to a physical object. But
if you shoot down a laser with it, okay, so you can say whatever fairy tale you want to say about refraction, the light bends around the ball, and all this nonsense.
Yeah.
We just shot something with it, though, right? So, I mean,
true.
What would the argument be that we accounted for refraction to achieve physical target acquirement? Okay.
Yeah.
I think it's just there's no doubt the technology exists, man. There's no doubt. If you start looking into lasers, it's like, oh, damn, they got laws everywhere about these things.
Yeah.
It only looks like it blew up.
It only looks like it blew up. I love
it. Mirage explosion.
It was a mirage. It was a mirage of an explosion.
Nice. Makes sense. When everything is quantum and everything is relative, you can basically say anything you
Fired
want.
a laser, but it refracted.
Look, the multi-frequency targeting they did over the Fine Islands. It's 80 miles. They hit a 3.5 meter target from 80 miles away. They didn't count any refraction. They did laser frequencies at the exact same time. One experiment done by the Navy or the Air Force.
Let me ask this. Did they have to aim when they did the radio transmission from England to Australia?
No. And what would they aim at?
That's my curiosity.
Like that, it's an antenna array. So back then, like they would put up like, I don't know, like a square of like 32 towers, and they would string like wires that connected all the towers. So it's basically like a grid of wires and just transmit.
So basically, almost anybody in the entire world could have picked up that radio transmission.
Yeah, exactly. That's how they got the idea, is because they were picking up radio transmissions from Berlin in Australia. So they're like, hold on, why are we picking up radio transmissions from Germany? Let's try to do this on purpose.
Wow.
Yeah, that's a trip.
Yeah, if you go on the wiki page, right, it's the if you go on observations, it's the Marconi one, and in that I got the citations. So it's 2 ham radio clubs on the anniversary of like them doing this. They both posted articles that go into the whole history of them doing it.
Mm-hmm.
What motivated them, the guy that did it, yada, yada, yada.
So how? Of course, the one I
The
see
first
here is
radio
like
transmission was an official government transmission. It was like an official government thing. Like the Secretary of Defense of Australia was in the UK, and he transmitted a message back home to basically say, "Yeah, this shit works."
Mm-hmm.
Gospel. Where did you find something about 50 kilowatt? I see 30 kilowatt. Of course, it's named
50,000. Yep.
Athena.
It's in that article that I posted. That Japan fires the most powerful laser.
Okay, it's right here.
So on that article, it says, for a rough comparison, in 2013, a 50 kilowatt laser shot down a drone. And then there's a link. I'll post. German military laser destroys target over 1 kilometer away. There's the article. And this happened allegedly in 2013.
Yeah, what a trip, man. This is such a, you Google it, 2021 article is going to tell you that the biggest one openly known about is 30 kilowatt called Athena.
Yep, this is Rheinmetall Defense 50 kilowatt high energy laser ground facility in Switzerland.
Okay, look, I'm going to drop this screenshot.
Beam superimposing technology where they actually combine the strength of a 30 and 20 kilowatt.
Oh, wow. Okay.
It says it sliced through a 15 millimeter thick steel girder from a kilometer away. So two-thirds of an inch thick. Shot down drones. It's a pretty cool article.
I'm trying to see like the furthest the laser shot something down. That's what I want to know.
And that was 9 years ago.
Yeah, that's what I was saying. That's 2015, and then 2021. You got like late last year an article saying that the beam from the Advanced Test High Energy Asset, or Athena, just a coincidence, just like Lucifer telescope, is believed to be most powerful ever documented in a laser weapon. So I don't know. Because we could FOIA, I guess. They're going to swoop that up so fast with national security coverage.
Hey, how well do you think aircraft can see everything on the ground? Like most helicopters have that technology? Only police helicopters? Only military? What do you guys think? Like they can use infrared, right? So they can see heat signature. So how well?
Yeah.
So how well can they see you? Like, let's say.
I would imagine that something that's not military level is going to not really do that much.
Right.
Because I've actually worked with some badass helicopters, but they're just like private helicopters. You know what I mean? Like they're not. There's no way that they're the same.
So they may be using like a high magnification, looking around, actually visually looking around, right?
I don't know. I don't know. I would think that the most efficient way to see vast distances is to manipulate the light spectrum to isolate what you're looking for.
I'm just trying to figure out exactly what they're doing now. Like, what are they seeing when, like let's say, I know there's Cal Fire helicopters, there's Coast Guard helicopters, there's military. Now, the military helicopters around here, who knows what they're looking for? I don't know. Those are the most high tech helicopters flying around. But you have PD helicopters, there's sheriff helicopters, fire department helicopters. There's lots of private helicopters. So I'm just curious, like what they're able to see on the ground and who would be using what kind of technology. Anyway, didn't mean to.
So there's so much misinformation about this, man. Like we got the longest one known about military use is like a mile.
So, I mean, even if you shot at a mile directly horizontal, but there's no way that's actually the longest one. So, what's the difference in radio transmission and light? What's the difference? Like, what's the difference?
Frequency.
Right. Okay. So, but it does the same thing, right? I mean, like, in the sense that it's a propagation of energy outward. So, it's just a different spectrum. So, like, if you can send a radio transmission that far, I mean, come on, bro, you can definitely shoot a laser further than a mile, bro.
Right. Linear propagation. Yeah.
Sure. I mean, it'd be certainly trickier, but nevertheless.
I'm sure if you knew what these military technologies were, it would blow your mind.
Right. Like the picture Indio just posted, like, how do you look at that and think it's curving? Like, there's the one laser test they did. They shot like 32 miles. It's in Flatlanders or whatever, and there's hundreds of feet that should be blocking the laser. And then they have the shots from the outside, looks just like this, just horizontal.
Yeah.
So the refraction made it look horizontal as it actually gravity curved it around the ball.
Wow. So that's funny how everything they're saying it's doing, it all makes it look flat. Everything look flat. Isn't that interesting that it's not actually just flat as we see it? I think it is, yeah.
When I first heard that people thought the Earth was flat in like 2015, if someone had shown me a laser shooting 30 miles from the outside horizontal over a lake for 30 miles and not hitting the curve,
yeah,
I would be like, "What? You can see that it's horizontal. It's a laser." I would immediately know, but like we've had to inch our way and do all these and scratch all this money together and we get all these different observations, and then people get this information and just still ignore it. It's so crazy.
Yeah, all it would have taken, you're right. All it would have taken is someone to show that and go, now look at the surface. Is it curving underneath the laser?
Dude, just to show me the math that the laser was at a certain height that should get blocked by the Earth curve, and then I see it from the outside being horizontal, I'd be like, oh, wow. Well, I guess this is game over. I mean, wow, why hasn't this person been killed yet? I'd be like, this is definitive proof.
You guys just don't understand refraction.
You have to be an insane person, I think, man. Like,
fraction.
See, I can tell you one thing, man. 99%, okay, maybe a little high, but 90% of people in the real world just walk around living their everyday life distracted, have no idea you can shoot lasers to test the curve or that it's been done or that nothing like that. They've never seen this picture or anything like it. You have to be pretty insane to like look at this and be like, that's not horizontal. Like, obviously you have divergence in the beam divergence, but I mean, it's a laser, so. If anything, that would help the globe Earth. The divergence would help the globe Earth. Right. I mean, it would get obstructed. It would get obstructed sooner. Like, sure, part of it would go over, but it shoot up in the air. It would be noticeable, and the bottom would get blocked sooner.
But if lasers disappear from the bottom up, then boats would too. Either way, bye-bye radius.
Mm-hmm.
I'm saying beam divergence doesn't help the globe, though, right? I mean, it doesn't help the globe at all. Because even the part that gets wider and goes, so then say hypothetically the Earth's a ball, but divergence causes the beam to go over, the curve. It's just going to keep going wider and higher with half of it or more blocked, right? I mean, that doesn't help the globe. Like, if the laser gets to the target on the other side, then the globe doesn't help the globe at all. The beam divergence is actually somewhat irrelevant, I feel like. Like, it just helps the globe. Like, it helps the globe to, I don't know.
Divert.
Well, just to hyper focus on beam divergence, I don't think.
It's the beam. They use beam divergence to divert the conversation.
Yeah, exactly. But like you, I mean, you obviously want to minimize that just for efficacy of the test itself. Does anyone have any take on what I'm saying? I'm just spitballing here. Like, if the beam is diverging, I mean, that doesn't actually help the globe, though, right? Like the beam's just going to get blocked sooner by the globe.
Yeah.
Yeah.
Right, because it's getting wider, right? So it's angling out wider, so it would hit sooner. Hey, so Whitsett, I know you're pretty busy, obviously, but I want to wish you both of you the best of everything this place has to offer. But I want to say, if you ever make it out to the West Coast, like I'd be ready more, like coming up here to go and do some observations here. You know, I know a lot of good places, so I would like to see a whole thing. Once I'm able to travel around more freely and so forth in the next coming year for me, I'll be able to go around and go to different places and do observations and things like that. I really foresee doing like a whole West Coast circuit, go up down the coast and find the best places on the best days and do these sorts of things. Anyway, just thought I'd mention that.
Yeah, I think we're planning on going around the whole U.S. again, bro.
Yeah, man, that'd be cool. I wouldn't even mind like a little caravan for a little while, caravan along with the flatmobile for a week or two, you know, and go do something else.
Yeah, like I mean, dude, I'll be honest, man. Like that tour was very exhausting for me, but
I bet it was.
Yeah, like it's gonna be a little different, but like we're gonna be posting the RV. Like Chris and I were just, bro, we were just going place to place to place to place, day, 2 days, day. Like it's not gonna be like that with this one. It's gonna be more, at least weeks like a week at a time somewhere, and then hitting surrounding big areas. Like it's not feasible for her and I with the cat to live in that thing and do that. It's not gonna happen. She has to work and.
Yeah, no.
So it'll be different, but we are planning on getting around the whole U.S. doing a tour again, right? And then I can just drive to the major areas around where we park for that week or 2 weeks or a month or whatever.
Yeah, pull up with a whole freaking entire like Flat Earth Media Center. Like music, we could have comedians up here, snack bar on the left.
No, I think music is a glitch for real. If you can glitch it out, like I think when I do my activism, I'm just gonna start doing this thing where I freestyle like off of what people are wearing or what words they say in the moment to random beats, and then just integrate Flat Earth. It's like, how can you really get mad,
Yeah.
Anyway,
we just need to like mobilize. I mean, like you're doing, and get out there and make this thing happen. You know, as far as connecting and building community and that sort of thing.
I'm trying to figure out this laser thing, man.
The what thing?
The laser.
Oh, the laser thing. Yeah.
I want to know how far a laser can shoot down something, man.
I'll tell you what. I was up on the bridge of my ship, and you know those navigators that are up on the command center up there at the bridge? They can see really, really far. I've also stood lookout watches myself on the bridge. You can see really, really far. Never really talked about it because it wasn't an issue. It was just that's how far you see. Like, yeah. I bet I've seen the horizon myself at 100 miles. I'm almost, I'm sure of it, actually.
Do you have a plane landing, or am I hearing?
Here where I am, there's lots of noise.
Okay, because I'm hearing a plane land.
No, someone's running a leaf blower. There's a bunch of. It sounds like a rocket engine taking off sometimes in here. It's like, I don't know what it is. There's lots of noise from outside. The city's loud. Either that or they're trying to attack me with the frequencies and it's not working. Just kidding.
Yeah, I don't know. I just keep trying to say 1 mile.
Have you heard about the new laser technology, the 7/6R laser technology?
No,
incredible. It's mind bending. Speaking of being attacked with frequencies, just found out that my father-in-law got his free wearable device from Medicare. Medicare and Medicaid handing out the wearables.
Wearable? What kind of wear? Oh, maybe we shouldn't talk about it. Okay, gotcha.
You know, the Fitbits and the whatnots.
I fall down and I broke my hip. I need help.
No,
I can't remember what that's called.
Fitbits.
Nice. I remember that being one of the things that I looked into. I remember watching a video way back when of somebody going on the Fitbit and that other watch company and looking at heat signatures for people's walking and running. And I remember spotting in Antarctica the bases that are out there, people running around the airfields.
Yeah, that was a couple of years ago. What, 17, 18, something like that?
Yeah, so why don't they have this laser? I don't know why that wouldn't be on market. That's amazing. They should have the 7/6R laser. That's what I mean about technology. That's what's so laughable. Yes,
So
again.
marine
Elon
traffic.
Musk is selling flamethrowers. Go ahead, bro. I'm sorry.
Say that about.
You cut out there.
Sorry, I cut out. Yeah. So marinetraffic.com showed boats in Antarctica like 500 miles inland.
What? Yeah. Yeah.
Yeah.
Good
So I don't know how that works exactly.
Good for them.
There's gotta be refraction.
More than just like one boat. It's happening all the time. You might be able to go on right now and see boats that are
So they
hundreds of
don't
miles inland.
Refraction.
It's making boats move 500 miles inland in Antarctica. Stay tuned for updates. They don't know where they are.
What website is this? Because I would like to look into this.
That's hilarious. Somebody get a screenshot of that.
So that's marine traffic, and I found one that's just pretty bizarre, but it won't click on. So it's fishing, but it's like, okay, so it's fishing position received by satellite, and it's smack at the edge of Antarctica on the map of marine traffic.
Wow.
2 hours ago via satellite.
Okay, we have
So it's close to the Ross Sea. It says fishing, but it's not showing which boat it is. Maybe you need a subscription now.
What are they fishing for? Narwhal?
Oh, here, yeah, I've got another one that's close. So it doesn't say what ship it is. Oh, it just jumped out. Just jumped out. Yeah.
This is talking about the Pentagon working on competition to see who could build the best 150 watt laser.
Oh, there's a freaking sailboat right at.
I mean, kilowatt.
Dang, these people are in a small sailboat. On, holy crap. All these people around Antarctica. Hole in the sea. Cargo vessel right on the edge. Fishing vessel right on the edge. Another fishing vessel. Tugs and special craft all around the edge. A bunch of tugs and special craft, whatever special craft they might be, around the Waddell Sea there. People they have a small sailboat over there. It looks like about a 50 or 60 foot sailboat in Antarctica. Oh, it seems to be a lot of fishing right around their fake border. Who's over here? Yep. What's this one? Ocean going tug. Moored. Vessel details. Let's see. This thing's right at. Past track.
The other two names of these lasers is Odin and Helios.
Checks out.
So we got Athena, Odin, and Helios laser weapons.
Perfectly normal. Exactly what you would expect. Do you ever notice that all the futurist movies, like sci-fi movies representing the future, everybody looks like they're dressed like a Roman? You ever notice that?
No, but what movies would you be referring to?
Every future-looking movie that I've seen
Like
for quite a while.
Star Wars and all those things. Yeah, the Council,
Sure.
all those things. Star Trek. Yeah.
They've got robes. Everybody looks Roman in the future.
They do.
Excuse me, gentlemen.
She said the Odin capability is definitely something the military wants.
Just wait. Someone will come in that doesn't know anything about military technology and tell us what's really going on.
I bet they'll have to give up an eye for that laser.
Yeah, Helios, it has growth potential up to 150 kilowatts. High energy laser with optical dazzler something. Optical dazzler and surveillance. You gotta admit, it's pretty hilarious that they always find a way to make it like blatantly their gods' names.
Mm-hmm.
Well, Google says 35. Military documents say 150. So
I'd go with the mill document.
they don't seem to be particularly keen on releasing the actual data, though, of the testing. You know, like the target acquirement testing.
So I was thinking about those numbers on the crazy article. What's it? I was like, what are the chances that this is some type of mathematical trickery? Because they're like, well, it only happened in a picosecond. What are the chances that it's some type of equivocation fallacy or something like that? Like they're multiplying the amount of energy by reducing the amount of time and pretending that it was actually a higher amount than it really
Yeah,
was.
that's
That
probably
sort of
exactly
thing.
what. Yeah, that's probably exactly what it is. And then they actually leave thinking that it's profound.
For sure. Well, the reason I'm wondering that is because I'm sitting here thinking, how do you get 2 quadrillion watts of power in the first place? If even only for a fraction of a fraction of a fraction of a fraction of a second, where does the 2 quadrillion watts of power come from in the first place?
Particle smashers are using up to 15 TeV. I don't know how to translate that into words that we all understand, but apparently it's like more than photon.
More than what?
Yeah, I was trying to use a scientific term, fuck ton.
Oh, I thought you said photon.
Yeah, sorry. Yeah, whatever 15 TeV is, that was a few years back with CERN.
I mean, how far do you think you could shoot a 150 kilowatt laser?
I don't know, man. I guess it depends on what's the medium. If you're shooting it up, pretty far. You're shooting it down from up, pretty far. But sideways, not as far.
A TeV is a tera electron volt or trillion electron volt.
So when you take your laser and you aim it up to the drone in the sky, is your angle based on a horizontal
Absolutely.
So how long you can shoot it is still my question. You know, it's like, yeah, if you, it doesn't matter if I shoot it out of the air or not. Like, to get the angle, what are you doing? The laser shooting straight, man.
Exactly. How do they get the angle from their artillery or their rockets? Elevation angle from what?
Like, just like India said, 10 miles, you're 66 feet off.
Mm-hmm.
So, like, I mean, I guess it would be required to have, yeah, I don't know. I mean, even if you can see it, right? I mean, if you can see it, your angle would prove it. The laser weapons would prove the Earth pretty handedly, is what I'm saying.
Yeah, that railroad track right there, that precision aligned track.
Well, if we can get a time, right? If we can get a time, how long it takes to traverse that 10 miles, we can calculate how much it would drop due to gravity, right? Acceleration of gravity. And I guarantee in the time it takes for that sled to go down the track, it doesn't drop 66 feet.
Absolutely.
That would be like 3 seconds. That thing is going down that track in like a half a second.
Well, where's the extra track?
Meaning that thing should be off the ground.
They don't have no extra track. You only lay it down as much track as you need. You don't lay down freaking 66 extra feet of track.
Well, I mean, the curve, it should be curving down because it's right. You fire the rocket, takes off, it's going straight. The ground is curving away from it. It should be coming off the track.
Mm-hmm.
Right?
Yeah,
Unless
but
it's got something keeping it attached to the track.
Yeah, but Earth isn't a sphere, it's an oblate spheroid.
Oh, that's right.
Like that matters.
That's one of those. That's a flat spot right there. Another flat spot.
That's another detail of the cartoon made up part.
So many flat spots on this ball. They're everywhere.
Wouldn't that be terrible that your whole religion is based on cartoons? I mean,
well, there's a lot of Scientologists out there, and they're based on L. Ron Hubbard's sci-fi books.
Yep, cartoons once again. I mean, that's all you have to go by is cartoons. Pretty sad. But by all means, come on in and talk about your cartoons with us. That's why we're here. Anybody in the YouTube live stream chat? Even though you never come in, maybe this will be different today. That was pretty fun talking with that doctor the other day.
Oh,
did you
hold
hear
on.
that Indio, did you hear that conversation?
If you're producing track for something like a train or anything,
say what?
If you're producing a track for a train or this rocket, okay,
mm-hmm.
and you're making, let's say, 100-foot sections, for instance, after a certain distance, aren't you going to need more track to account for the curvature?
Yeah, that's what I'm always talking about. In 100 miles of railroad track, you'd need 6,660 some odd extra feet, a mile of extra track.
Right?
For every 100 miles. Same thing with undersea cables, Gospel.
Yeah.
100 miles. So
yeah, me and Human Sheeple actually analyzed the undersea cable thing, and there's way too much undersea cable. Way too much.
Yeah. It would
like way, like 3 times too much.
Yeah.
Why do you think that is? For future splicing purposes, allegedly, or some other reason?
It's only in the Pacific where it's like this way too much.
Uh-huh.
and that's kind of like the big kind of like the mystery, the South Pacific.
Like they accidentally made too much and just used it anyway, or what is the idea behind that?
I don't know. I just remember like one of the ones we looked at was like from Australia to Canada, and it was something like 17,000 miles too long. It was some ridiculous number. Yeah.
They probably just snaked it down there. It's probably got S curves going down deeper than they thought, up higher than they thought, all kinds of stuff, huh?
Yeah. Who knows, man?
That is super absurd.
Amazing.
But this train thing, though, right? Straight line.
Yeah. And they probably use the linear decoders that Get is always talking about to line that thing up within nanometers.
What are they saying? I've never heard him talk about them.
You could do this every 100 feet or something. So at the very
wouldn't all railroad sections of track have to have a curve already like manufactured into it?
They would have to. Yeah, they would have to. Where is this?
Well, no, they would. I think that they would argue that at each meeting point, that fraction of a degree is taken into account at each segment end.
Oh, sure.
Yeah.
So.
Or no, when it cools off, right? It's cooling curved.
Disco ball. So disco ball railroad tracks.
Disco ball railroad track, but it's so slight because the curve is so slight. World's longest stretch is in Australia, and it's 297 miles long.
It's so slight, Gospel, because you're so small.
So 297 miles of straight track in Australia. So who lives near Perth?
I'd have to go look at it. I know Antonio Subaretz did a whole bunch on railroad lines, and how they were like way too long. They were like longer than what they were supposed to be on the globe. Like I think there's one that goes from like Europe to China, and if you actually like do the length on the globe versus how long they say the track is, it would end up somewhere like in the South China Sea.
Well, shouldn't it be shorter if you measured it? It would need to be longer for the globe.
If you assume that the globe coordinates are correct.
Yeah.
Does everyone realize that all of us at the same time could point to the direction of Perth from wherever we are, and all of our arms are outstretched horizontally? Thanks.
Yeah.
Why is that?
And I know the direction too. How about that?
Me too.
It's behind my left shoulder right now.
Mm-hmm. Interesting. It's almost right out in front of me.
Yeah, if you point your finger out and you spin in a circle, you pointed at every plant, animal, tree, everything.
All of it is on a horizontal. Yes, everything. And unfortunately for the Globers, the light and the luminaries, all of that phenomena only occurs above the horizon. This is like first grade. This should be first grade.
Oh, and by the way, Sonny, I did not hear the doctor, whatever that was. I was freaking sick for a week.
Oh, sorry about that. Sorry to hear that.
Oh man, I think where I've been doing work. I leave coffees around all over the place, and I think I drank one that was like 2 weeks old.
Uh-oh. Yeah, you got to watch for that. You're right. You had a stomach problem? That's the only kind of thing. I think I got sick here because of the plumbing, actually. And they fixed it.
Well, I didn't have a stomach problem, but I instantly had one. Well, not instantly. It actually took a few days.
Right.
Started getting brain fog. Then I was like puking for like 20 hours straight.
Oh, God.
Not even an exaggeration. Like puking for 20 hours straight.
That's what I had. You know what? The last time I got sick like that was, well, not that long ago. But before that was 3 years ago, like 2019. I hadn't been sick at all since 2019. Nothing. But yeah, stomach problems. Gotta watch.
Fast.
I go out and eat a bunch of wild greens growing. I don't always rinse them off. I try to make sure it's far enough from the path, though. Then any dogs can take a leak on it. Pass.
What's the opposite of slow?
The opposite of slow.
Mm-hmm.
Slower.
Expedient.
The opposite of slow is slow. Oh man, that was a good one.
Slower. Slowest.
The opposite is slow. Yeah, it depends on what you mean by slow.
More slow or less slow?
I have 3 speed: slow, super slow, and stopped.
Reverse.
The opposite of slow is backwards.
The opposite of slow is how slow? Well, negative slow. Yeah,
Don't fall for that stereotype that Hispanics are hard workers. Gemsy is feeling that.
Bro, I haven't slept in 8 hours, I think.
What's the opposite of slow and rhymes with past?
Fast.
There you go. See, that's all I'm saying. You should just fast, bro. Maybe do some fasting.
Fast. I fast every morning.
You intermittent fasting?
I should stop leaving coffees around and just drinking them randomly. That's what I could just stop with.
I fast in the morning with greenery and some coffee. I fast for the first few hours.
I did
All I'm
18.6 for a long time, and it was.
I did fast. I was puking for like 3 days, so yeah, I fasted.
I'm just saying, we like Kai and I were talking about we were eating dinner. Like, it is interesting that even when certain people, when faced with like death, like whether like they tell them that's cancer or whatever, if you told them you can fast, if you can work your way up to fasting for 3 days, you can maybe reset your body. But either way, just fast and get your alkalinity right, so you don't have such an acidic thing, and they'll just die, dude. They'll die first. Yeah. They're like, no, I'll die. Actually, can you just make me bald, make me really small and weak, but I want my Oreos and Coke. Like, they'll die before they even try fasting. It's so wild.
Well, listen, Antonio Subarets, he ended up dying from cancer, but he was given like 3 months to live, and he lived like almost another 18 months, and that's what he did. He fasted. I think he ended up going overboard though, because he was taking. I don't know what that is. There's some chemical, something. What was that?
I can't.
I didn't hear what you said, Hank.
Oh, I'm supposed to be on mute, bro. Sorry.
Okay. Okay. He was taking. What was that? MMR or something? It's like some chemical that people were drinking.
MMS.
Anyway.
MMS.
Yeah, I think. Yeah, that shit.
Yeah.
I thought it was.
But he was fat. But the point is, he fasted and he was not fast. because he was misdiagnosed for like 6 months. They kept telling him he had like strep throat or something, and he actually had like cancer in his neck. He never had any surgery done. He just fasted, and it went away. But I guess it ended up spreading to other parts of his body. But it left where it originally was, which is kind of strange. But whatever.
Look up the benefits.
Right. So like fasting's good. It's not gonna like fasting's just gonna help you reset, right? Like whatever gave you cancer, if you just keep doing it, then you're gonna get sick again. Like
Yeah.
you know what I'm saying? But I'm saying people won't even fast to do the reset. They'll literally be like, you know what, man, I'll lose all my hair and probably die. Let's run it.
I almost do it every single day. Sometimes I'll work, like I'll drink a bunch of liquids and I'll go work.
Well, when your body's in starvation phase, right, your metabolism completely changes, and your body will just devour itself. And pretty much, it devoured the cancer in its own body.
Correct.
Yeah, it's good to get.
That's why most people are overweight. I think because their metabolism just forgot how to work.
Yeah, you're right. I think you're right.
Yeah, it isn't actually normal to eat 3 times a day. Like, that's not normal. That isn't how people really have ever eaten in nature. It's like,
yeah,
great.
Like once a day, maybe twice a day, or people eat like little bits throughout the day. You know, like a handful of berries or something.
What I usually do is like I flush my whole entire system with liquids during the first part of the day, like the first half of the day, and I flush everything out of my system, and it all goes through. So once I do that, then I'm ready to eat in like early afternoon. Then I'm ready to eat my dinner, and then I'll just eat that. That's all I have.
Well, that's a very intriguing part. Saying like you just grab some berries throughout the day. That seems much more natural, right? Like another argument I've heard is
That's called living in your environment, you know.
Exactly, and we were brainwashed to like mix all the foods together. You know, like we eat meals where we mix them all together and eat them all at the same time.
Yeah.
Maybe you're supposed to go eat berries when you came across the berries, and in an hour you might run across some more berries or whatever it is. You eat them separately.
I've always done much better like that. Like when I eat meat, I just eat it by itself completely. I don't eat vegetables anymore with meat and different things. Like I eat like a single portion of one single thing. That's what works best for me. I can't mix a bunch of stuff.
No, I do. I eat meals too. That's like the thing. I like eating a bunch of fish.
Listen, I can too. I can do that, but generally, if I'm by myself, I don't eat that way.
No, I think it's good. I think it's a good argument. I mean, I don't know any science behind it or anything, but it's interesting.
Well, there is kind of a science about it as far as depends on your system. Some people can handle certain things mixed together in their system, causes reactions that are not beneficial. Too much acid, not enough, like too much liquid with the food that's diluting your digestive system, you know.
Plus, almost everything we eat is factory farmed. It's artificial fertilizer, not naturally fertilized. You know, we're not getting like the actual nutrients that we would get if it was grown under different conditions.
Mm-hmm.
Yeah,
probably suffering from malnutrition, most of us.
And, we can't digest anything without like the microbiome, the bacteria and enzymes and shit in our stomach. And obviously, because we take and everything sterilized 24 hours a day, we're probably like running on, half power, half availability of what we should be doing.
So the gallbladder is said to hold all those biomes, the microbiome. That way, when you wipe it out using, whatever, like non-steroidal anti-inflammatories, like over-the-counter painkillers, or some sort of, amoxicillin or something like that, penicillin, right? It's supposed to repopulate the gut, right? But if you have that removed, the only way to repopulate the gut is the stool transplant. So somebody with a good, healthy gut, they got to get a swab, right? And then, you got to take it in. So that's really bad. Try not to lose your gallbladder. You need it.
Yeah. Another thing that they've researched is baby vomit. This is gross, but they've tested this in mice that they'll use mice that have knocked out immune systems and then they'll give it like the vomit of baby rats, and because their gut microbiome isn't like, I guess it gets depleted as you age, or you get other bacteria and shit in there that fights the good stuff, the good bacteria. So over time, your gut microbiome, it gets depleted. So what they did was they gave the adult rats baby rat vomit, and it replenished their immune system. They ended up living longer, basically, than rats that did not get baby vomit, which is gross, but you know, it is what it is.
Have you seen like some predatory animals like orcas when they hunt, they eat the liver and the organs of the prey and leave the rest?
Yeah, some birds do that, right? They just like
Yeah,
rip out the organs.
the liver and other organs.
The liver, yeah.
Yeah, I was just about to bring the liver up because I was going to say, when you brought up the gallbladders, you guys have heard that really most of the stones go all the way to the liver and like get stored there. And if you do a liver cleanse, you'll have all this stuff flushed out of you. It's crazy. And then you'll get the bigger, darker, more calcified, hardened ones come out later. And so like everyone's liver has all these stones built up in them that you can get out. Like you drink organic apple juice and it softens it up. And you have to already have like pretty like frequent bowel movements to do this, though, you know. But it's really interesting, bro. Like when you see the stuff that comes out of everybody, you like healthy people, you'd be like, wow. Like liver cleanses are a trip and stuff, like even like turpentine in a certain way, and like I don't know, it's crazy. I think that we have all this toxic GMO processed nonsense built up that couldn't get filtered out of our system, and it's stored in our liver, and no one really talks about it.
I have a question. Distilled water is good or bad
Distilled water is like
to drink?
Well, call it what it is, pure water. Because distilled means what? Pure?
Yeah. You just pulled the other
So
particulates out of it.
Steam pure.
that would be like drinking rain, right? So spring water is what we're naturally supposed to drink. But in a pinch, you could probably drink rainwater for a little while and get away with it. But wouldn't it be natural to drink spring water because you live near a spring? Most populations do, right?
Yes.
Yeah, I'm all for the distilled water personally, bro. Reverse osmosis, even. I mean, in the world you live in, just get the stuff out of it.
Yeah. I put some Himalayan sea salt in my water, so
Yeah, that's good.
work good.
We put that on everything.
Mm-hmm. How about anybody use iodine? I was doing it regularly for a while, and I kind of sort of forgot.
No, I eat white fish.
Yeah.
You guys ever heard of the liver cleanses, man? I'll see if I can find some info. It's gonna blow your mind. Like what comes out of people.
I've heard of coffee enemas, which is really pretty much the same thing, but you have to use
similar
coffee. You have to use organic coffee because if you don't, you can have hundreds of pesticides and stuff in regular coffee.
Yeah, I mean, this is very interesting because once you do it, you need to kind of frequently do it, however often, to really clean yourself out because it'll start to push them forward to get out. So, like, if you push some of the stones out forward, but you leave them there, it could be even worse in a way. Like, you're pushing the more calcified ones towards the front. So you have to kind of really, you have to see it through. And dude, videos will blow your mind. Like people that look like they're in great shape, dude, will just have dozens and dozens and dozens of these stones come out of them. It's so insane.
So what kind of substance do you use? You use food only? You use like certain, I don't know, supplements or?
No, yeah, it's just food. It's like
food.
Yeah, it's like I'm trying to remember. I don't want to miss it. I can't remember, but like I know organic apple juice is the first step. Like some people can drink other stuff if they have a problem with the sugar or whatever, but organic apple juice softens it up really well so that they'll pass.
How about any other juices like mango, guava, or any of those tropical juices? Do they do the same?
I don't really know. I just listened to this guy that's like known for it, and it was all about the apple juice. And I think they said maybe
I heard celery
cranberry.
juice. If you take all the fiber out of the celery, like just copious amounts of like celery juice.
That's probably really
I heard that.
I can make
That might be it.
smoothie. That's a good idea.
There's like 3 things they mentioned that I can't remember what it is. It's some other type of juice, but anyway, that's just the first step, right? But I'll get the information for you. Kai and I were watching it, dude. It's insane. And the person that's telling you about it, you can tell the dude's skin is like oddly radiant. You know what I mean? Like it's like weird.
I'm gonna get me some juice. So I used to drink it all the time because I had a health food store that was close by. I could get big jugs of organic apple juice and take it home. And now, like, all those are closed down around me. So, but there's one little store. It's very expensive, but I can get some there, I'm sure.
I mean, there's so many of these damn quick fixes out there.
Hey! Speaking of apples. Apple cider vinegar, it's sort of the same thing, right? I used to drink that in the morning as like a cleanse. Like you drink a big glass of water with like a quarter cup of apple cider vinegar and maybe some, what else did I put in it? Lemon juice, water, and apple cider vinegar.
Dude, all that stuff's relative, man. It really just comes down to lifestyle. You just have to change your eating habits. Is really what it comes down to. You can do all the cleanses you want,
even if
but
you do
I mean, it'll always revert back to the same if you're still doing the same shit. You know,
that's true. That's kind of the problem because we are creatures of habit. You know, unless we break these habits.
That's our problem. Yeah, exactly. I mean, it's all about moderation and maintaining. I mean,
yeah, the way I do it, my lifestyle is I just fucking get moving in the morning. Like I'm going to do it earlier today. I need to start doing it earlier and earlier. Go out. I'm outside like 3 or 4 hours out in the sun, and it's been really great. It's like paradise.
Because you got to be careful with cleanses. Because, like, dude, if you don't replace the electrolytes that have been used and push out of your body, you can shut down your kidneys. I fucking did that shit. I was doing a cleanse a while back, and that shit was no joke, bro.
I would everyone look into. Well, I don't know, Fra, where you are, if it's anything growing up there yet. Probably not, but anywhere where you live, where it's springtime, there's anything green starts to grow. Start looking at what you can eat because. Dude, I go right along the trail and I find all kinds of stuff now because I chose to learn about this topic of what plants, how to identify them. And just, it kept getting bigger and bigger to now, like I'm riding along these same trails where a few years ago, I didn't know there was anything I could eat along there. I was like, I wouldn't eat anything. And now I pick up these flowers that taste like little peppery flowers with these big, huge green leaves that are full of lutein and vitamin C and B's and all and they're just right there. So now I use it I can pick up enough greens for one day. Like I can just pick up as much as I need every day. That's it. It's great.
So if you go, I'll post a video. If you go to the channel, that's his channel. I'm pretty sure he died though, but anyway, that's his channel, and it's very interesting information, man. I think you drink the juice, it softens up so they'll pass, and then you fast, and then you drink like oil, like olive oil, and then some mixed with some type of juice, and like you'll pass out these crazy stones that are in your body. And
I'm gonna try it.
So I mean, if anyone wants to, I mean, I'm just saying everyone's gonna always poo-poo on everything, but so when you go look at all the stones that come out of people, you can decide yourself if you think it would be better that those are inside you or outside of you. I'm saying, I think that's kind of the point. It's
I don't think there's much of a choice, man. I'm gonna try it.
It
I'm
looks
willing to do
crazy,
whatever.
dude. It's so crazy.
That's how knowledge is power. Look, if I can be healthier and enjoy life for longer, that's I'm willing to try whatever. Like I know now, I'm willing to work for it. Like I can put my own wants and needs to the side. Like I need to learn. Everyone needs to practice that anyway. And so, yeah.
But just really research it, right? Because your current bowel movements are important and stuff like that. So you just like really look into it. Because anyone that's done it successfully will tell you all the stuff you need to know. Though, I mean, we're gonna end up doing it. I think it looks crazy, bro. It's like I want to know what's inside of me. I want to get it out of me. You know?
Exactly.
I remember finding this guy a while back, and he was talking about how the tumors in the body are designed to protect the rest of the body by trapping the reproduction of bad cells.
Mm-hmm. Yeah, cancer is like your body. A tumor means your body's working, in my opinion, as well. So it bottles up the toxicity and doesn't let it spread. And if you don't cure it, eventually it will still spread.
Yeah.
All right, this is my world, right? So I'm a vegan. So all the shit you guys are talking about is great. But what I'm saying to you is you have to change your fucking lifestyle. That's the main thing. You can do the cleanse, yeah, but then you go back to the same fucking lifestyle, you're just gonna make it worse. It's gonna come back even more aggressive than it was before. So when you change your lifestyle, then you don't have to do all that shit. You know, the cleanse is basically because you're sick. Our bodies are sick. That's why. So there's so many fucking cleanses out there. There's this guy called Dr. Seaver. Dude, this guy had the cure for AIDS, all of this shit.
Dr. Sabi, yeah.
Yeah, he did all that shit. And then he's dead. The chick from TLC is dead because she knew him. So there's a lot of shit out there. If you look into it, that'll point you in a direction that it's another rabbit hole, but if you choose to go, that's where it's going to take you, you know?
Nipsey Hussle was literally doing a documentary on him when he died.
Right, exactly. He died too, right. So he died too. And so now
and they arrested him for having cash on him at the airport, and then he died in transport.
And he died because of the connection to him and to that Dr. Seaver guy. I mean,
I'm saying that's how they call Dr. Sabi died, because they arrested him at an airport having cash, and then when they transported him, he died in transport.
Yeah, and then no, they said he died in they incarcerated him, and then he wouldn't.
Right, but then they transported him from one jail to another one, and he died.
Right, because he was refusing to eat the food that they were trying to give him, because he just figured it was poison. So, this shit goes deep, man. I mean, like this guy claims to have the cure for everything. Seriously, like it's
well, he
no
did.
joke.
He beat the FBI with a 99% prosecution rate, defending himself. He had to bring in 7 witnesses. He brought in like 70.
Yeah, he did. Yeah, so you watched the whole thing like I did. So yeah, you know about it too. Then.
That dude's a legend. He says the same thing that everyone says. It's if you have cancer, then your body is way too acidic, and you need to get in a more alkaline state. The most efficient way to do it is to just fast and let your body get a bunch of the stuff out of it, and then just maintain alkalinity with alkaline water and vegetables. That when you do eat, and that's what will get the cancer to go away. Of course, with everything, if you just go right back to making your body acidic, then yeah, you're going to be screwed. But that's what everyone says. My friend Frank, who married Kind, he knows a guy he used to hoop with. He was like 65, oldest dude out there hooping with everyone that was young. And he was given 6 months to live, and told he had cancer and all this. And so he just fasted, did the alkalinity thing, got his body out of an acidic state, would eat like fungal mushrooms and stuff. And 3 months later, no cancer. So, I mean, there's tons of stories like that.
Cancer's pretty easy to defeat, because when you realize it's something you're doing to yourself, you know, it's not like something you contracted, right? So I mean, it's literally your body, like the guy was saying, it's tumors. It's tumors because they've been surrounded by white blood cells, and what they try and do is they try and flush it out of your body. But what happens is if you don't do what it takes to get it out, they're just gonna keep attacking it, and it's gonna grow in size, and that's what happens.
Yeah, for sure.
The cure for AIDS is to stay away from the man who rhymes with ouchie.
Yeah.
Which guy is that?
The man responsible for creating AZT. because AZT is AIDS.
But the overall diagnosis of the immune system, like being messed up and attacking itself, is how I use it now, just so I can tell everyone they have AIDS.
Yeah, but stay away from remdesivir and AZT, allegedly.
And genetic modification injections.
Just ask Magic Johnson.
That fucking guy.
Ask Magic Johnson
Magic
if he
penis.
ever took AZT.
Yeah. Magical penis.
Nah, nothing magical about his dingling. It's more magical that he somehow avoided taking AZT. What do you know?
Yeah, it's just funny that the guy they said was super promiscuous, so he got AIDS. His name is sexual.
Yeah, that's all part of the game.
But I think people actually have AIDS now, bro. I mean, what else are we gonna call it?
Yeah.
I think they have AIDS, man. Autoimmune deficiencies.
Yeah, well, unfortunately, it's a handful of my loved ones.
Same, man. I know, and I just is what I mean, dude. You know, I would feel worse if I just don't say anything, and then my children are coerced in the future.
Oh yeah,
I never even noticed that Magic Johnson got AIDS. That's hilarious, dude.
Wait, what?
Magic Johnson got AIDS. Wizard Dick got AIDS.
Yeah, we might just call him Wizard Penis or something. It's so funny.
Wizard Dick. Wasn't his number 33?
Yes.
Bro, what?
Oh yeah.
His number was 33.
I didn't realize it was that bad. Oh, gee.
They're just trolling me. They're totally trolling.
It's pretty funny. It's actually pretty funny, though.
His number's 23. Oh, or no, 33. Sorry. Wow.
33.
All right. And he was born in 1959. Okay.
Man, why y'all hating on this guys?
Did you say he was actually number 33 or 23?
No, it says his number was 32.
32.
Oh, 32. Oh, that was Larry Bird then. It's 33.
That's
right?
pretty close.
Hold on. Number 33 retired. So maybe he was 33 at one point as well, because I see two references. Number 32 retired and then number 33 retired. So he was both.
Whoa.
Yeah.
No.
Yeah, correct. In college, he was 33 for sure.
What a trip.
Yeah, it looks like for the most of his career he was 32, but
yeah, like an NBA.
Yeah. Anyway,
he's like infamous for being like insanely big, but being able to play point guard.
Hey, look at this cute little picture, guys. Look at that.
Yeah. I saw a meme with him the other day,
shaking
dude.
hands with there?
Yeah. I saw a meme with him the other day on a beach with a bunch of girls, and the meme says, "This is the day."
What?
Pretty funny, because that's the story. Is that he just running around wild and he got AIDS, magic penis. You know.
He probably really did. Yeah.
So they had to use a famous person to get the AIDS thing across. You know?
Uh-huh. Michigan State Spartans. So you're saying that's high school? The Michigan Spartans is some high school?
College.
Oh, college. Gotcha. Michigan State. Yeah, that makes sense.
I wonder how does that work? You know, they're like, hey, you're tall, man. Now you're gonna be famous. We're gonna say you got AIDS. Like, or does he have no idea? Did the doctor scare him? You know, don't worry, you'll be famous, and then you'll be like the one person that survived it, not that you're fine.
So there's an
Don't you
interesting.
remember that professional football player that came out and kind of outed how what was going on 2 years ago? He wasn't. Let's put it this way: he had one good year, but he wasn't like down for the program. And he said the dudes that are down with the program, they're the ones. He said they get opportunities. So basically, the way he explained it is everyone pretty much has the same skill level, but it's really just the people they choose to give the opportunities to that succeed. So, you could be as good as the next guy, but if you don't get the ball, then, you obviously aren't going to perform because you're not on the field. So the ones that go with the program and do whatever they say, they're the ones that get the ball. They're the ones that get famous, yada, yada, yada.
So if your Johnson ain't
Wow.
magic enough, then you're not going to go to the pros.
The announcement was made about Magic Johnson shortly before the Agenda 2020 or the Agenda 21 council was had, just time frame wise. It was in November of 91, and the council took place shortly after that.
For the what? For the
Agenda
Agenda
21 council that met in 1992. I just can't remember the exact date.
That's when I was born. That year was popping. So, yeah, that's pretty interesting, right? I guess that means in the New World Order they want everyone to have AIDS, so they're right on path.
June of 1992, apparently, is when the meeting happened, the conference in 1992. It was in Rio de Janeiro, Brazil, by the way. Kind of interesting location.
I wonder if he feels like Buzz Aldrin. He's like, dude, I just gotta keep holding this in, man. I don't have AIDS, man.
Yeah. Yeah. The Rio Declaration on Environment and Development and the Statement of Principles for the Sustainable Management of Forests.
Yep. So everybody go eat weeds today. Peace out.
This imagery on the Agenda 21 thing. Check this out. This is fascinating. A little bit. What does that look like in the hand or the artistically portrayed hand? What it doesn't look like, doesn't look like any land masses I've ever seen. Kind of weird. Oh, it's still their symbol. Never mind, I see.
So I was talking to Globers yesterday about electrostatics, and dude, it was so funny. They got smoked so hard. Dude, it just destroys the globe religion, man.
But I want to keep my bending and warping invisible, space time.
Just super funny, man. Because, like, yeah, of course, we destroyed the globe Earth already, and it's done really most efficient in physical measurement. But without gravity, you can't even propose the idea. Like, when people say that, I know I'm kind of like a broken record, but I really want people to start picking it up. That's why I talk about it so much. When people say, so why do things go up? Why do things go down? What are you talking about? Things don't just go down. Like, okay. And then, well, the density relationship. And if someone asks you, well, like, what causes density? Like, what is the answer? Like, why? Now, I know what the answer is, typically from flat earth, is like, why do things have density? I don't know. Ask the creator, But
Well,
anyway,
let me try. Let me try because I've been listening to you, bro. All right. So if you look at the most dense things, right, aren't they usually metals? And don't metals usually have the best conducting ability? So they're at the molecular level, they're easier to condense and compact because of this capability to hold an electrostatic charge.
yes, correct.
And it creates a much stronger bond than other things that are not as susceptible to static bond or static charges, right?
Right. Say you have some matter and it's got these attractive bonds. If you strengthen the attractive force, what's going to happen? It's going to pull them in together. It's going to compact the matter. That's the definition of density, compactness of matter. But Globers that kind of know what they're talking about, they'll end up conceding that everything that has to do with matter itself, like the inner workings of matter itself, is electrostatics. And they'll typically say electromagnetic until you correct them to be more specific, but they're still not technically completely wrong. So anyway, so I don't see what I'm saying. Why it's frustrating, because it's like it doesn't in any way combat the flat Earth density point, like, at all. It only further strengthens it. Watch out for those false binaries, cuz. I don't know. I mean, I don't know what I'm missing, man. I don't know why people don't want to jump on board.
Hey, I'm with
I
you.
do know.
It's just this week is the first week that I've had an intelligent guy come along, and I've kind of set him up already. I believe he's some sort of student of physics. Can't remember his name right now, but he sounds like a middle-aged black man. I forget his name. Somebody want to help me out? That's what he sounds like. I don't know what color he is. Never seen him, but that's what he sounds like to me. But yeah, ever since he's been coming around, I've kind of been working on the argument, see if I can get it right the first time. I did have a little while to talk with him the last time he was here, but I'm sure he'll show up again. And I did propose a question: what causes this density, right? So yeah.
Nice. Yeah, just like it's really easy too. I mean, everything's electrostatic, man. It's not even like a hard thing. Yeah, in the intricacies of it, I get it. When to prep But anyway, I think I know the reason why there's a reluctance from the flat earthers to adopt it. And it's a sad reason, bro. And the reason is pride, right? Because a lot of people just very adamantly said what they've said for so long. They can't just like admit, well, there was a little more to it than that. And there's nothing wrong with learning and adapting. That's how we got here. But I'm just saying that's my current assessment, because like no one can debate me about it. I'm like, okay, all the flat earthers get triggered about it. I'm like, okay, debate me about it then. Why don't you just debate it then? You know, and it's like, I just think it's weird because, yeah, it's just such a good thing to say. It's such a good point. It just ends the conversation.
Yeah, I never heard you say the thing about the metals. I figured that out on my own, right?
Yeah,
Because the
see, that's
metals are
cool. Yeah.
usually the most dense thing. So
Correct.
like, once I started thinking about what you were saying, I was like, yeah. And I think about the diagram where they just slap gravity over density. And it's like, no, that's not right. It's something else. So once I started thinking about what you said, it's perfect. Makes perfect sense.
Yeah, like maybe I need to work on how I deliver it or something. But yeah, I always feel like it's really simple and it gets really quiet and people don't want to talk about it. And it's like, and people get triggered when I talk about it. I'm like, dude, how long I gotta wait, man? I think I've been on this server a couple of years now. I mean, you know what I'm saying? I found out about the Earth 5 years ago. A lot of people wonder, how long are you gonna wait, bro? Just let it go, dude. And here's another one for you. There's a downward electric current on the Earth. It doesn't matter if you like it or not. It doesn't matter if you want to ignore it. It doesn't matter if you want to not integrate it. It's still there and it's still objectively relevant. So to say there's no downward current on the Earth is patently false and wrong and inaccurate, because there is a measurable one, a provable one. So, like, just address it. We as flat earthers don't have to be dogmatic. We don't have any type of confinement or religious book that we're supposed to be parroting. We're just addressing reality for what it is, what can be tested, proven empirically, and that's it. So there's no reason to be dogmatic and like scared or confined and stuff, right? It's the opposite of what we should be doing.
Hey, Witsit, you might know this. So in an electrical circuit, does current flow the opposite way of the alleged electron flow? Meaning the electron flow is towards the negative and the current flow is towards the positive? I'm just wondering, because when you said there's a downward current, I was just wondering if somebody could overturn that with actually the current flow would be upward, but if everything's following along the same path as the electrons would flow within an electrical circuit, then it would be downward.
We've seen lightning come from up and go down and come from down and go up too, right?
Yeah, that's right. I mean, I'm not sure I'm understanding your question. Like the Earth is typically like right around neutral, but it has like a negative charge that
Slightly
goes
negative,
on the surface.
yeah.
Yeah, like could you manipulate that? No, you can never. I mean, when the downward current comes down, there's the reciprocation in the physical medium, right? But I don't know like exactly what you're asking.
I'm just trying to say like a constant flow, kind of like what Zach was talking about with the Earth being similar to like a capacitor, meaning you have like a negative side and a positive side, and the negative side would be the ground. Everything grounds into this slight negative charge, and then there being some sort of positively charged plate or something above us, right? So like in a capacitor, you have varying Gauss readings depending on how close or how far you are from the positive or negative side of that capacitor.
Mm-hmm.
And it's my understanding that like what they call the electron flow goes from positive to negative, and what they call like a current, like the electrical current, goes from negative to positive. So it's like two motions, one moving negative to positive, one moving positive to negative, is constantly taking place within an electrical circuit.
Yeah, they're
intertwined. I think I know this. So it's gonna take the path of least resistance to the ground, right?
If you're talking about just like an energetic charge, Yes.
Yeah, like the reciprocation's intertwined. It's just like if you look at a magnetic field under a ferrocell, like that black is the reciprocation of it. It's like dielectricity and magnetism are always
Yeah,
present.
like
Like if you look at a toroid, right? Like a toroid, you can draw it one way, or you can draw the inside of it also, right?
yeah, the hyperboloid. Yeah, it's like Steinmetz drawing of like power lines, right? Where you have the magnetic represented as almost like circles, right? And then you have the dielectric going 90 degrees to that at every intersection, right? So basically coming out as like emanations in straight lines almost.
Yes. That drawing is actually was very useful for me.
Yeah, me as well. But it's my understanding like within like a AC current, you don't necessarily just have flow in one direction. You have multi-directional flow, meaning from positive to negative and negative to positive, depending on what you're looking at within the current. Like the electrical, what we would call the electrical current, would flow one way within that electrical circuit, but the actual whatever you want to call an electron or however you measure that would flow the opposite of what we would call the current flow.
Right. Pretty much, yeah. Like the electron is just a part of the dielectric field, right? So it's just a part of the dielectricity. It's an isolated area. It's really a gap. Where actually electrons are isolating nothing. It's isolating the pressure mediation point of the dielectric field. It's actually isolating like nothing. It's a gap in a field. That's the irony of it. And then they say it's material. Yep. No, it's actually nothing. It's actually the gap in the field.
Right. Which is the same as what they would, at least in my opinion, it's the same as what we would call a photon, but when you're speaking in terms of the EM spectrum.
Correct.
To me, I feel like these two words are fairly synonymous as far as how we look at them.
Yeah, just different frequencies. Or vibrational spectrum. Like electric pressure going down to the earth, man. Like it's just objective, man. And this is what's so beautiful about it. It's so weak that butterflies can fly. I don't need to make up fairy tales about how it's actually so strong it makes water bend around a ball and all this. What? No, it's so weak that butterflies can fly. So cool. That also explains why bees fly, because not just what they do, but what they're doing it within. They're just counteracting the downward current. They're utilizing the current. Or one could say, as you're describing, they could just get into a certain vibrational pattern that helps them to ride the opposing current, or quote unquote current, but like reciprocation of energy. You know?
Yeah, like bees, bumblebees.
Yeah, exactly. Well, if anyone wants to, I guess what it is people have gotten so in arms about there's no downward bias, saying that phrase over and over, that anything that resembles the idea of a downward bias scares them, and then they can't swallow their pride. Just being blunt, that's what it is. We all know that's what it is. We all know when people keep it at a distance. People want to keep the background medium at a distance. I'm like, bro. And I understand why, but like, I'm trying to explain it. When you're talking to someone that's new but kind of informed, and they ask you these questions, and you just tap out saying density over and over, like they're gonna be like, "Bro,
yeah,
I'm out."
You put God in it.
So, lots of times, density and weight get equated to be something similar or the same. How would you define weight, or if you're having a discussion with somebody around gravity, and they tend to keep referring to gravity being weight, or weight being synonymous with mass or density? I mean, I feel like lots of times these words are used interchangeably.
No problem.
Yeah. So I
These,
like
these
go ahead.
people think the Earth is still a ball.
Yeah, we know, man. But some people aren't going to think you know what you're talking about when you say it's flat, when you can't answer some basic questions. So, like, weight is nothing more than the force pushed down to the earth, right? So, pressure over area, pressure mediation, based on the compactness of that matter and its surrounding environment, its relationship with it, it's going to emit a certain amount of force or pressure over that area. Like the pressure is going to mediate. That's all the scale picks up. And so it's all about electrostatics. It just becomes redundant. Like density, mass, conceptual quantification of matter. Well, matter itself, any compilation of it, is bonded with electrostatics. The compactness of those bonds is based on how strong the electrostatics is. And anything that is going to the earth is also going to an electrostatic resting place. And so it's just an electrostatic relationship that, based on the seeking of equilibrium, mediates pressure accordingly, right? So a simple way is just like electrostatic pressure is all that weight is. And so gravitas means weight. So.
True story, bro.
It's not possible to just correlate volume and density to answer the question.
Sure, you can, but there's, I mean, like, what causes the different spectrum of density? Like,
Yeah, it is very simple to talk about density and buoyancy, right? But typically what's left out of that conversation is, like Austin was saying, it's the downward vector or the downward bias, like downward or upward, depending on what you're referring to. And that's undeniable. Like, you can't just gloss over that. Like, there has to be an explanation for that as well.
Because if someone hears you just ignore it, like it's not there, and all you ever get back is it's not relevant, their cognitus is going to interpret it as, oh, they just don't know the answer. So that's why they think the Earth's flat, because they just don't understand it. That's how they're going to view it. It's detrimental to flat Earth.
Well, yeah, well, the truth is nobody knows the answer because no one can do that experiment. That's the truth. That's why Neil deGrasse Tyson, when he asks what gravity is, he says, I don't know, because that's the true answer.
Right, but we do know what's actually there, right? Like, we do know, like, it's a good...
Yeah, we know the observation, but we don't know the cause. The causal mechanism is unknown to man, period. Not been scientifically determined.
Right, so as flat earthers, what we do is we acknowledge the observable phenomena that we do know, right? Like density relationship, and we can manipulate that. We can manipulate electrostatics, you know? So it's like, I just ignore electrostatics.
True enough. But, I mean, I guess you would need to do some sort of, like, I don't know how you would do this test.
It's difficult. I mean, the Van de Graaff generator, you can make things levitate.
Make a horizontal density gradient, see if you can make something move sideways that way. I'm sure you could. How would you actually physically do that? That's the problem. Like, how to do that experiment.
I think we're focusing too much on how you would do something.
Well, that's how you test things.
Science is based upon experimentation, dude.
I know. But
we ain't Globers, dude. We don't make shit up.
Yeah, so you can take your Van de Graaff generator and make things go up and down, right? You can make it go up, you can make it go down based on the charge. You can take the helium balloon, or not the helium balloon, but you can take the balloon, rub it on your hair, stick it to the wall until it loses charge, falls back down. You can manipulate charge and make it change directionality laterally or vertically. So it's like, we know it's there, right?
What if it's got fuck all to do with anything, bro?
How could that be the case if it's literally involved in everything? Like, that doesn't make any sense.
All right, listen to me.
Okay.
We find ourselves in a world where everything is upside down, topsy-turvy, and they're lying to us. Why would anything else make sense? Why would we take anything that they say as factor 3 or factor 4?
Well, we're not taking anything that they say. We're just talking about what you can test.
Right. So we've tested it, and we've figured out that it's a load of balls. What are we going to do now?
I kind of had an idea. It might be stupid. It may not work, but if we were to get, like, let's say a pail of water and just spin the fuck out of it, right? And the ping pong ball is floating on the water, like it's never going to go down, right? So this spinning sideways, and what answers the questions, why do things not spin sideways? Why do things don't fall sideways? You guys know you hate that question. Well, that answers it because you didn't spin it or you didn't throw it. That's why it doesn't fall sideways. But it also, it's kind of one of them things where it's like amplifying gravity because you can spin it a lot faster than the so-called downward force. And the ping pong ball, I think, is still not going to go to the bottom of the pail. So that just kind of, amplifies what we're saying about specific gravity.
Yeah. Do you think we get a density tower out of it? You know what the density tower is like with the
Right. That's what they do with the blood, right?
Oh yeah, centrifuge.
Well,
Yeah.
the whole thing. The whole thing is just to make
The
you believe in
centrifuge.
something and try to figure it out and make no never mind. And in the end of it, it doesn't actually make any sense at all. You know what I mean?
What do
You know
you?
what I'm saying?
What doesn't make sense?
Well, nothing makes sense. The globe makes sense. Yeah, the globe doesn't make sense. Where we are doesn't make sense. What if where we are doesn't actually make sense? What if we're actually fucking
It
hijacked?
does make sense. It makes sense. It
Oh, it
makes
does.
perfect sense, man.
Oh, it does. Okay. Well, explain that to me.
Okay, so you never feel the Earth moving because it's stationary and founded, and all the water found its level, and you're on a topographical plane with energy that moves over top of you in a cycle. It all makes perfect sense.
I actually don't care about topographical fucking movements. Yeah.
So I guess the point I'm making.
I'm only here for like 60 years, maybe tops.
Yeah. So there's
Uh,
a electric downward current. If I increase the
there
downward
is.
current, would it make things fall faster?
That makes sense. Perfect sense now. No, it
Yes. The
doesn't.
answer is yes. Yes, it
Is
does.
it yes? Sorry, I say yes.
Yeah. If I introduced a ton of electrical charge down a downward current, if I increase the current and drop something, the pressure pushing down would cause the object to fall faster. So
How
I'd
does
be
that
interested in
happen?
testing that.
How does all this shit happen with upside down electrical currents and mathematics? How does that all happen?
Upside down. What are you talking? There's a downward current in the earth. You can measure it. You can put a
Listen
string
to
in
me.
the air and measure it.
Right, so we're in a completely fucking defunct, crazy fucking world, right?
Too much, PMAC. Too much. Just
Okay.
try
All
some
right.
water. Drink
So I
more
really
water.
want to hear what you guys, especially Indio, Witsit, and Napalm, I really want to hear what you guys think. Just real quick about what I said about spinning the ping pong ball in the bucket of water.
Let's say hypothetically you could spin it fast enough to make the ping pong ball go to the bottom of the pail. What would that
That goes
bring?
against what I've been saying about specific gravity.
I don't understand.
What I'm saying is what I'm saying is that specific gravity is the real gravity. Right.
Oh,
And what
okay.
Woodson is saying is that, yeah, but you left out this. And I'm saying, yeah, but I haven't met someone smart enough to get that far yet, until recently. I don't
Okay.
think most globe earthers have been willing to entertain specific gravity until I said that I think it's the fourth leg of the second law of thermodynamics. And then he was like, okay, that's interesting. That's begging some questions, not accusing me of circular reasoning, but that's making him ask more questions. Like more questions have to be answered. And then at the end of it, I told him, so what is the cause of density? So if you put the ping pong ball in a centrifuge, I guess in a large centrifuge in a pail of water, and the actual ping pong ball plastic touches the metal at the bottom of the pail, this is going to be a problem for what I've been saying. It's going to go against, because I've been saying this is the real gravity, and if we increase the force by using centrifugal force to emulate gravity, then this is going to be a problem. But I don't think it's going to happen, because what we know about what the people do with the blood, they put it in a centrifuge and they spin it, and it makes everything go into a density tower. And then they pull it out, and then everything's all Yeah, in a density tower in the vial.
It
Yes.
there's a word for it. You're basically undissolving. You're creating a separation of dissolved components in the fluid solution. That's what the centrifuge accomplishes. You can also do this with coffee. There's a really cool coffee YouTube channel, and he puts coffee in a centrifuge.
I knew it.
To separate the dissolved solids.
So yeah, Hank, I don't think your ping pong ball would ever touch the bottom or the side, however you're looking at that. I mean, has this experiment been done and the ping pong ball does somehow go
The experiment hasn't been done.
Okay.
Because I'm wanting to spin it faster than the Larry go round. You know, I want to get it really, really booking. You know,
Ping pong.
Yeah, I don't think the ping pong ball would ever touch the side. I don't think that's possible.
I mean, I got a mean lasso, but I want to spin it faster than I can spin it. So, you know,
because
maybe
the faster you spin the bucket, the density of the water is going to increase, making the ping pong ball stay out even more. I mean, of course, the ping pong ball will never.
Yeah, it doesn't just spin the ball. But it's like the electric.
Sorry.
Electrostatic charge density, man. Electrostatic charge density. Electrostatic charge density. Like that, dude. To think that the density isn't based on electrostatics is really insane, bro. It's like it's just unfounded. Mainstream academia admits that it is. So it's like flat Earth should absorb that. It's a cherry on top of their argument.
Fine.
Yeah, Richard, I bet you thought about what you're talking about before. I think it's called polarization density. It's the charge density. There is a charge density. The amount of electric charge per volume.
Yes. Exactly. It's called charge density, I thought, but I don't know. Electrostatic charge density, bro. It's crazy, man, because it's like,
you look
dude,
so
it's already being done. It's already being done.
See,
the globe Earth model just says that out on the big magic scale, things change, bro.
Well, think of this,
on.
right? When you
sorry,
just let me say this is when you say I have two mediums. So in this instance, we'll use the Earth and the air as an example, and they have different charges, right? So we know that the air has a vertical gradient, and we know that the Earth we just call it ground. To everybody, we just call it zero. But the interface between two unequal mediums, where that boundary is, that charge difference is always zero. And the only way that can happen is if the charges in one medium and the charges in the other medium rearrange themselves to equalize the surface charge. And there's actually a name for this. It's called the method of images, right? So if I took like an electron, right, and floated above a positively charged chunk of metal, the electrons within the metal would rearrange themselves so that the charge equalized, so that at the boundary it would the potential difference would be zero, right? So there's always like a mirror within a material. So I guess the way to explain this would be is if I was highly negatively charged and I walked up to something, right, a block of concrete, the actual the molecules within that concrete would rearrange themselves. Of course, you wouldn't be able to see it. You'd be able to measure it, but they'd rearrange themselves so that the charge, so that the boundary between the air and that brick, that concrete, was always zero, right? And if I got further and closer away, there'd be literally like a mirror image, the reverse mirror image of my charge in that material. And this is happening all the time, everywhere, without us seeing it.
Right. That sounds like a fucking.
Because things, like this is a fact of the universe.
Shit
Yeah,
wants to be at equilibrium.
it sounds like a
It
fun.
just wants to be at equilibrium, period, all the time. It wants to be in its lowest energy state. And for some reason, going down is the lowest energy state.